various administrative and academic bodies of Mangalore University, and even he is serving for the other institutions and universities. He nominated as a member of many the organizations, and also is a faculty of science in Kstacademy University, Karnataka, and is an expert member in the selection or promotion committee for the faculty position at the university level, and also he is an expert member of selection of research position at university level also. And sir is a member of the Animal Ethical Committee, even Human Ethical Committee, and Institutional Biosafety Committee of Mangalore University. Sir is also a nodal officer for the Village Adoption Program of Mangalore University, and sir is also a chairman for the Environment Audit Committee of Mangalore University. Sir is also worked formerly Academic Council for the member of council in Mangalore University, and also he was director in PMEB, Planning, Monitoring, Evaluation Board, and also he was a coordinator for the Vijay Bank Chair on Ecology and Environment. And sir has also formerly worked as Deputy Coordinator for UGC Special Assistance Program sanctioned to the Department of Applied Geology, Mangalore University, and he has worked as a chairman or member of the many board of studies and even board of examination in various departments of the Mangalore University. And his sir has also worked and he has conducted research on many aspects of ecology, biodiversity and conservation. And sir is also he conducted many research programs on worming technology in waste management, and also cytogenetics and molecular systematics. And sir has got many awards and recognitions and even fellowships. One the award or the fellowship that is Commonwealth Fellowship during 2002 to 2003, and sir is also has a fellowship holder of UGC research under UGC SAP program from Mysore University, and sir has published many the research papers, more than 48 research papers, both nationally and international journals. So he has attended many national and international conferences, and sir has guided 7 PhD students, and currently 5 students are working under Dr. Shipa sir. And he has handled many projects, both funded by the government and other institutions. With this brief introduction, I welcome you to the session also.
Very good morning to all. I hope yesterday's event, technical session, and the evening entertainment session was really fruitful and you people have enjoyed. So welcome back for the today's session. I'm sure that the messages, whatever have been delivered by the real expert in different areas, the keynote talk, and also the model and presentation given by the faculty members and the research scholars were really message. Okay, thank you for all your cooperation in yesterday's program. On behalf of the organizers and on my behalf and on my chair, Dr. Basappa, I welcome all of you for the today's session. We have, I'm not sure, but really I can be the, I really deserve the post of a chair to session, a talk being given by an eminent scholar who has extensively worked on, particularly on the topic which is very relevant to the theme of the program, climate resilience, and sustainable development. Very fortunate that he is here, even though you know that scientists who really work in an institution, they don't find hardly a time to go to other areas, but their main interest is to deliver their knowledge, whatever experience they get in research or probably to interact with the scientists from different parts of the world. So their main interest is to interact with the people, and that through the younger generation, like people who have attended this program. I'm really happy that he is here with us, and he will be delivering the talk, which is very much relevant to all of us. So in brief, I just introduce the today's speaker, Dr. Govindasamy Bala, Professor of Atmospheric and Ocean Science in the Center of University of Science, Bangalore. He received his PhD in Atmospheric Oceanic Science in 1994 from McGill University, Canada. After 2 years of postdoc at Princeton University, he served as physicist, as climate scientist at the Lawrence Livermore National Laboratory, USA, between 1996 to 2008. And Professor Bala uses Earth system models to understand the climate, carbon, and water cycle changes to external forcings such as greenhouse gases and land cover change. His main research interest includes modeling of climate change, carbon and water cycles, solar green engineering, land cover change, and global and regional monsoon systems. He has published more than 125 peer-reviewed journals, particularly on the first areas where today's and maybe the whole theme of our program. He is addressing mainly on climatic change, carbon cycle, solar, green engineering, and monsoons. Professor Bala is the recipient of 2008 Scoopus Young Scientist Award, very prestigious award for Earth Science. He and his collaborators from China and USA have won the prestigious World Meteorological Organization's WMO, very well known in the field of Earth Science, Norbert Debye International Award for 2014 for the research paper on fast climatic system adjustment. Professor Bala has served as a lead and contributing author in the fifth, that is 2013 and 6th, 2021, Scientific Assessment of Climatic Change by IPCC, and is currently a member of Earth Commission Future Earth. He was a member of Scientific Steering Committee for the Analysis, Integration, Modeling of Earth System at the global level for Future Earth during 2016 and 21. He has also served as the editorial board member, Earth System Dynamics and Environmental Research Letters. With his brief biodata, I'm sure that all of us can take a very important message. I just had an opportunity to interact in the morning hours before we assembled here, but he has explained everything, what kind of things one can really take away. His research area is, however, even though confined to atmospheric science, a modeling system which he is going to explain in detail, probably all biologists or physicists or chemists or engineers who is assembled here take a visit. I really request you, sir, please on behalf of all gathered here and the organizers and administrators, I will
thank you, Professor Sripata and Dr. Ramesh and all the other organizers. I'm actually pleasantly impressed by the intellectual crowd here, and particularly the theme on sustainable development, which is, I guess, today it's a globally it's a conversation that everybody is having in international meetings as well as national, state level meetings. Is that ready? Anyway, I think as Professor Sripata talked about me, I have basically a wider background in some sense, because I started as a physicist, but my background is actually physics. Then I moved to meteorology, which is basically with the aim of doing weather forecasting, but I felt I'm not really a good operational person. So I basically ended up really becoming a researcher or scientist, and basically around year 1995, I moved to actually look at the whole climate system, and how climate system is basically affected by human activities, right? Then not only the physical climate, around year 2000, I started looking at the global carbon cycle and water cycle. So one thing, in fact, I have learned through my journey is learning never stops. There is always lots and lots of exciting things to look at. It's only that we don't have sufficient time, I guess. Most of our careers are only about 20, 30 years. So today what I'm actually going to talk about is a relatively new topic that is not many of, even among scientists, climate scientists, not many are aware of this. This is only a, okay, it's not appearing here? Okay, okay, and this is that, okay, fine, thank you. So I'm going to talk about basically, should we engineer the sky? So what do we really mean by that? I mean, you may be wondering what do we really mean by engineering the sky? Okay, so I just, it's not going. Oh, the bottom one, okay. So I know this is we are most of our action take place at a state level, district level, local level, and national level. But I think this particular thing that I'm going to talk about, this is really on a planetary scale that the scientists are actually talking about. Why they are talking about? Because the climate action is not proceeding at a rapid pace. So scientists are thinking about radically, it's in some sense more like a scientific fiction idea. So as you can see here, okay, so what is engineering the sky here? So you see this key term here, that is large scale and intentional. Intentional is key here. So basically it is like modifying Mother Earth itself, right? So these particular approaches are called by this name, solar radiation management, and briefly called SRM, solar radiation modification. And these approaches are also known as what's called solar geoengineering. And here is a schematic that basically represents many options under this particular SRM option. So what are these actually? I mean, these ideas have been actually around ever since climate change was actually known. So basically, I think the first idea, if you look at here is an idea where you would put gigantic mirrors or a single big reflector in space that would basically reflect solar radiation back to space, right? And then there are other approaches. So I'll come to some of these approaches later in a slide, all right? Okay, so before that, why we are actually really, some scientists are alarmed, not only some scientists, in fact, if you look at the newspapers today, almost every day there is a news about climate change, right? So here is a graph that shows how humans are, this is on a planetary scale, on the global scale, how our energy use is increasing with time. So this is 1970, and somewhere here, we are in 1920 here. So our energy use, what is energy use? As simple as, electricity used here in this building, petroleum that we use in our car, the fuel that we use in our airplane transport. So almost all human activity needs energy to drive this economic growth, right? So if you look at it, it's almost the growth is exponential. So basically, in 50 years' time, our energy use basically tripled, right? So this is the main concern. Why we are talking about sustainable development, resilience. This is because of this alarming growth in energy use by civilization. All right. Now, here is the key message, that is nearly 85% of that energy comes from fossil fuels, okay? So basically you can see in this graph, so this is coal, this is oil consumption, and this is natural gas consumption. These are all fossil fuels, and then there are nuclear, hydroelectric, and renewable. So you can see actually on a global scale, renewables and nuclear, they are contributing only about 15% to meet the global energy needs. So, in fact, I have been watching this particular type of graph for last 30 years. So we are stuck at, for renewable energy, 15% for almost 3 decades. So this fraction of fossil fuel use is, always stuck at about 85%, right? Now, the problem is this: fossil fuels release carbon dioxide into the atmosphere. So you may be already, many of you are already aware that today's climate change problem is mainly driven by the carbon accumulation in the atmosphere, carbon dioxide accumulation, right? And also look at just on a global scale, how big is the problem? Currently, we are releasing about 40 billion tons of carbon dioxide into the atmosphere each year. I mean, if you look at each one of us probably is emitting maybe, few tons a year. But when we add it up for 8 billion people on the planet, you are talking about 40 billion tons of carbon dioxide. This is not the total amount we have added into the system since pre-industrial time. This is every year right now we are putting into the climate system. So again, you can see here how this is exponentially growing. This is our emission starting from pre-industrial time, 1900, so this is 2020. It is really an exponential growth. All right. Now, so there is a global level network. It's called the Global Carbon Project. So they basically track the carbon budget of our planet. So basically, they calculate how much humans are emitting into the atmosphere and how much the land biosphere is taking up that carbon, and how much each year oceans are taking up that carbon, and then remaining is staying in the atmosphere. So this is one such figure from that particular project. So this figure shows from 1990 to about 30, 35 years. So again, you can see even in the last 30 years, our carbon emission, right? This is basically fossil fuel carbon emission each year. So right now, somewhere we are here. So even as we speak, every year, the amount of carbon we put into the atmosphere, it is keep on increasing. And this is a milestone. For example, let's say 1990. 1990 was the year when Kyoto Protocol was signed. So if you remember, one of the agreements that protocol was the developing nations will phase out fossil fuel emissions. But where we are today, you look at the numbers. Today we are emitting actually 65% more carbon dioxide into the atmosphere than in 1990. Okay. All right. So because what it is doing, so you start with the energy use. Energy use is leading to emissions. Emissions are leading to carbon dioxide emission. So here is a proof that carbon dioxide concentration in the atmosphere is increasing. So the measurements started in 1958. You can see how it has been increasing over the last 60 years or so. Even in the last 60 years, the atmospheric CO2 concentration has increased by 110 ppm. If you compare to the pre-industrial period, it was 280 ppm. Today, our concentration is 420 ppm. So, in some sense, humans, not just us, on the whole planet, the entire civilization is basically creating a massive disturbance to the planetary atmosphere. What is the problem with carbon dioxide? Carbon dioxide traps IR radiation, and that is what is leading to global warming. All right. So now let's look at if humans were. So this is our carbon dioxide level today. Now, if humans were not actually emitting fossil fuels, we would be confined to this narrow range. This is a carbon dioxide series over the last 800,000 years, right? Almost 1 million years, carbon dioxide basically varied between 180 ppm to 280 ppm. Today, we have basically, so this is what I would call as human footprint on the planet, okay, or atmospheric CO2 composition. So some estimates indicate, in fact, the atmosphere did not see this level of carbon dioxide concentration probably in the last 20 million years. So even on a kind of long geological time frame, humans are having a major impact on the Earth system, okay? All right. Now, I'm sure some of you may have seen this, if you are following this environmental news. This year is actually a record warming year. So there was news about every year, every month of this year being warmer, breaking the record. For instance, you see, starting from here, almost every month was, these are various years in the past, starting from the pre-industrial period. So every year you can see there is a gradual warming of the global climate system, and this year is exceptionally warming. So the last 6 months have been, I think every month was basically a record-breaking month in terms of global mean surface temperature. All right. Yeah, so this is a, in fact, a curve that shows as a single number for basically the month of September. This is only for the month of September, how temperatures have been changing since pre-industrial time. You see that September was basically, compared to the pre-industrial time, it was 1.8 degree warmer than the pre-industrial time. But if you remember, the Paris Agreement was 1.5 degrees on an annual mean basis. So this is, of course, only a monthly mean basis. So we are very close to actually breaking the Paris Agreement target that was set in 2015, I believe. Yeah. All right. Okay. So what are the conventional solutions that we have been actually? You can also broadly categorize the climate change, how we are addressing on a planetary scale the climate change problem. There are two ways. One is what we call as adaptation. So adaptation is basically, many do that. If the sea level is increasing, for instance, you can actually build a wall around the coastal areas, so that will actually prevent the seawater coming into the land area. Or even this room, I believe it is air conditioned, right? So nature didn't provide this air conditioning. So this is in some sense an adaptation. So if we have, just imagine if you had infinite, amount of energy available to us, we could actually air condition every building, every car, everything. I mean, we can still live comfortably. That's an adaptation. But the problem with that is humans can live comfortably in a home or a building. What would happen? Natural ecosystem, right? I mean, they will bear the brunt of climate change. All right. So the next broader method is what's called mitigation. Mitigation is basically, the simple mitigation method is basically reduce the amount of carbon emission. But so far, as you saw in the previous slides, there was no way carbon dioxide emissions were going down. So, but scientists have been telling about this, the best solution is basically find renewable energy, increase the proportion of energy, renewable in your portfolio of energy, but at the same time reduce basically the carbon-based energy, energy usage. I think that was. But I mean, ever since I entered into this field, I have been hearing about this, but that's not happening. As I already showed you in a slide, the carbon emissions, even since 1990, we are actually emitting 65% more carbon dioxide emissions. So in fact, this is the right time. I think in the end of the month, COP28 is starting in, COP is basically Conference of Parties, where 195 countries assemble every year to talk about, to negotiate how we can address climate change. So this is basically, again, we have been, ever since 1990, we have been having these conversations, global level conversation about how we can address climate change. And so far, I mean, there is progress in terms of at least awareness and awareness about sustainable development, etc. But the emissions are still very large. So, 65% larger than what was in 1990. So, I think this is a question, any risk. I mean, every day our life, of course, we face lots and lots of risk, right? So, some scientists are actually seriously thinking about this, that we are already on an exponential track. And let's say if we don't, still if the carbon emissions do not come down in the next 20, 30 years, right? What if climate change becomes unmanageable, right? Unmanageable. And suppose we overshoot the Paris goal of 1.5 degree or 2 degrees global mean warming. Do we have a solution at that point? Because all these agreements are not legally binding, right? There's not legally binding on anybody, because this has to be mostly a voluntary reduction of carbon emissions by each country, right? Now, what if that doesn't materialize and climate change becomes really catastrophic, let's say? I mean, we are already seeing it. Bangalore, for example, you ask the Bangalore people who lived here for last 50 years, you would know how much the temperatures are warmer here during the pre-monsoon time as well as post-monsoon, right? And similarly, in many places, you do hear about extreme rainfall and extreme flooding and etc., right? So, what if something like that becomes manageable and we really cross this planetary threshold of 1.5 or 2 degrees? And if there is really we don't know. Sometimes, we really don't know what's coming up in the future. It is possible, in everyday life. I'm sure if you think back, there are a lot of unknowns you experience suddenly, right? So in the case of planetary climate, we could be facing such a situation. So what should we do? So this is a selective group of scientists at the global level. We are asking this question: do we have a solution if something like that happens? I mean, this is very unlikely, but if it happens, do we have a solution? All right? Now, first of all, okay, what is that planetary emergency? What could be, right? So, for example, let's say last year there was a big flooding in Pakistan, right? 30 million people are actually affected by the flooding in Pakistan, all right? So, it was also a major problem for 2 or 3 weeks, right? Almost 1/3 of the country was underwater, right? Now, first of all, do we know it is caused by climate change? What if it is really due to climate change, right? So this is one particular extreme event, right? And you could also have what's called a prolonged heat wave. Typically heat waves last for a week or so. Now, in the future, it is possible, in the future summers, you could have very prolonged heating periods, not just in India. It could be in Europe, it could be in the US, and it could be in even Russia, right? It can happen around the world, right? And what if, right now the planet actually has major ice sheets in Greenland and Antarctica. What if these ice sheets break because of, it can happen. It's not, unlikely, right? And similarly, that could be famines because of failure of crops in successive years. Even in India, for instance, if we have 2 years of consecutive drought, our economy is severely affected even today, okay? So these are some possibilities, right? Then, okay, so in that kind of situation, can we consider this solar geoengineering option or this solar modification approaches? First of all, so this is all of you, I'm sure many of you must have heard about this IPCC, that is Intergovernmental Panel on Climate Change. So their main task is once in 5 to 7 years to come out with a global report. These reports basically are produced by scientists around the world. So it basically produces report on the science of climate change. It also produces reports on what are the likely impacts of climate change in the future, and also what are the ways we can actually tackle this climate change problem, all right? So this particular report, it is about the scientific, physical science basis. So you can see here. So this report is, it assesses, there are about 200 scientists who are involved in this, producing this report. So I was involved in the last 2 reports. So this is the latest report. And what it says is that, the definition of this particular approach. Because remember, it is heated by sun's radiation, right? And then the planet actually loses energy through thermal radiation. Now, to counter climate change, let us actually, can we use this particular approach of reducing the sunlight that is absorbed by the planet? So what are those? Yeah, so this is, of course, if you back, after this talk, if any of you are really interested, you can go back and look at, Google these terms: geoengineering, solar geoengineering, climate intervention. Intervention, by that, we are basically, humans intervene in climate. I think that's what it really means, climate engineering or solar radiation management. So at least there are about 5 or 6 terms that, during the last 30 years, people have been kind of using to describe the same methods, all right? So here is the methods that have been proposed. All right. So first one is basically the original proposal was really more like a space technology. Can we build mirrors and put somewhere in between sun and earth to reflect solar radiation back to space? So this was very intelligent idea in some sense. People who are looking at people who are interested in reading sci-fi books and movies, it is something like that. You basically put a big mirror in space which will reflect 1 to 2% of the solar radiation back to space. And the second method is what's called the stratospheric aerosol injection. Here the idea is, if you remember, there is a stratosphere between 10 to 50 kilometer height from the surface of the earth. So here, that's where the ozone layer is actually present. So the idea is basically to inject reflective aerosol particles into this particular stratosphere, where you will basically increase the reflection of sunlight again back to space, because these aerosols can reflect light back to space. The next idea is what's called a marine cloud brightening. So here the idea is to inject micron-sized salt particles into the clouds, so that this will eventually lead to brightening of the clouds, or the reflective power of the clouds will increase, right? So that's one approach. And then there are also proposals to basically put some basically on the surface of the ocean, make them more reflective. And there are very interesting ideas, bioengineering. So basically, it's a very simple physics. Dark leaves absorb more sunlight, light color leaves reflect more sunlight. So can you do bioengineer the crops? Because crops are around 1/3 of the land surface today. So can we actually make the color of the leaves color lighter? That's one option. And something that everybody can do today, that is this what's called whitening of the roof. So you just have the terrace. In every building there is a terrace, right? And if you keep the terrace light color, maybe basically white color, so you could actually reflect much more sunlight. So that's also another option. So these are various options that have been actually proposed and discussed in the last 2 decades, all right? Okay, so these are the approaches. Now, I think as time progresses, as we study more and more, today in the literature, these 3 approaches, which are all aerosol-based approaches, they are the ones that are under consideration for studying. I wouldn't say they are going to start this, but people are studying these, researching these options. So the first one is the stratospheric aerosol injection. We already talked about this. Second one is cirrus cloud thinning. Let's not really discuss this here because nobody is really today talking about this. And the next one is this marine cloud brightening that we talked about. All right? Okay, so these 3 options are the one. Right now, there is some modeling studies on this. And the last, but what is really happening today is more and more research papers are coming on one particular theme, that is basically putting aerosols into the stratosphere, because the reason is this is doable, and also once you put aerosols in the stratosphere, this could quickly spread around the entire planet within a couple of weeks. That's one reason why seriously people are considering this. And also the cost of taking aerosols into the stratosphere and putting them, this can be done. You have to of course develop new aircrafts for this, but it is feasible. So because of its feasibility and cost, scientists are seriously looking into this particular option. All right. Sulfate aerosols, which are reflective. So you need to, of course, you can't just put, let's say, absorbing aerosol. That will be catastrophic. For example, there is an aerosol called black carbon, soot. Soot is also an aerosol, but it's an absorbing aerosol. So you have to also optically choose the right aerosol. So mainly reflecting aerosols. Okay, in the beginning, I remember when I started working in this area, definitely I felt like it's a science fiction story. Who is going to do this, right? But it's really, as I talk more and more to other scientists, some of them are really serious about this, right? Because I think they're really afraid that looking at the history of last 50 years of carbon emissions and also the progress that is taking place in these COP meetings, we may actually come to one day a situation to do this, okay? Now, the question is, okay, this looks, as I said, unnatural. Are there natural analogs? You know, many times people immediately question, you know, if there is a nature, if there is a no example from nature, let us not do it, right? I think there is an option because people like nature-based solution, right? All right. So apparently there are what is called the major volcanic eruptions. These are different from minor volcanic eruptions. Minor volcanic eruptions, usually the volcanic plume, it goes to maybe a few kilometers into the atmosphere. In major volcanic eruptions, the volcanic particle injection, it takes place, it goes all the way into the stratosphere. So these kind of volcanic eruptions very rarely happens, something on the order of 30 to 40 years, once in a lifetime kind of eruption. For example, the last major volcanic eruption was in 1991. This is called the Pinatubo eruption. This was in Philippines, right? So this injection basically reached all the way into the stratosphere, and it releases sulfur dioxide into the atmosphere. So the sulfur dioxide can be oxidized to sulfate, and the sulfate basically reflects sunlight. So that's the option. And even in nature, actually the phytoplanktonists in the sea, they emit what is called DMS, dimethyl sulfide. So these basically get converted into sulfate, and this sulfate actually helps the cloud formation in the ocean area. So there are natural analogs for at least the marine cloud brightening and the stratospheric aerosol injection. Okay. Now, in fact, the major volcanic eruption that was closely monitored was this Pinatubo eruption in 1991. So there is observational evidence that the eruption actually went up in 1991, and you can see in 92 there was a continuous cooling for a couple of years. So this is the evidence that now scientists say that yes, in the nature, when there was a major volcanic eruption, the planet actually cooled by about 0.5 degrees. Now, what if you actually, so in nature what happens is these volcanic sulfates, they get cleaned out by atmospheric processes within a couple of years. So that is why the planet temperature went back to 1991 temperature within 5 years. So the idea is, what if our man-made sulfate eruptions like this, if we do this continuously, because you have to do this continuously, because any aerosol you put into the stratosphere will come down in 2 to 3 years. All right. So that is basically the natural analog, and the people believe if you do something very similar to this natural volcanic eruption continuously, you could actually cool down the planet. Okay. All right. So now I think one can immediately look back at the history of this whole geoengineering idea, right? So I was also pleasantly surprised. There was a report as soon as, it was actually in the late 1950s and 1960s, people were actually thinking about that man-made this carbon dioxide into the atmosphere could be posing a serious problem to the climate system. So at that time there was an environmental report written, basically produced by scientists for the US president in 1965, and they were aware of this carbon dioxide problem at that time. The first solution, in fact, they talked about in that report was basically spreading very small reflecting particles over the large ocean areas. So this is basically the idea is to counter the warming created by carbon dioxide by reducing the amount of sunlight absorbed by the planet. Okay, and they also made a cost estimate. At that time, they said that 1% change in reflectivity is enough. Right now the planetary reflectivity is 30%, right? So they said, okay, something like if you increase that just from 30 to 31%, you would be able to actually offset the warming, and the cost would be $500 million a year at that time. But today it's about it could be much more, because this was 1965. We are talking about something like 55 years or so, right? The cost of this magnitude does not seem excessive at that time. All right, but this particular whole field was pretty quiet. There was this 1965 report. Then after that, in 1970s, there was a Russian scientist called Budiko. He basically, in a textbook, he writes how to mitigate climate change. So he also talks about putting sulfates into the stratosphere. Then again, here and there, people thought about this. But occasionally, maybe once in 5 years, there is some article like that in the scientific literature. But then, I mean, I actually also started working on this area I think my first paper on this topic was in the year 2000, 23 years back. All right. Then, of course, I'm not a Nobel laureate, so nobody took me seriously. All right. But in 2006, there was this scientist, basically Paul Crutzen. He's a chemist. He got a Nobel Prize in chemistry in 2006. And he advocated research into this area. So because he was also very concerned that the emissions are coming down. All right. So he said, okay, let us be ready with an option, backup plan, in case something goes wrong to the planet. All right. So basically, he asked scientists to research into this artificial injection of the sulfate aerosol into the stratosphere. Okay. So immediately after that, I think the field basically, a lot of researchers. So you just need some guru to basically advocate the research, right? So within 3 years, Royal Society of London, they came out with a report on solar geoengineering. I mean, again, this report basically advocates research into this area, all right? And then after that, there was this 2013 IPCC report. I was also involved in this particular scientific assessment. It basically, and immediately a recommendation was made to at least assess the state of knowledge in this particular domain. And so in 2013, so these were basically some of the highlights from that IPCC assessment of SRM. So it says SRM methods may be able to counteract a portion of the global warming effects. So it says yes, you can maybe it can offset some of the global mean warming, but it says numerous side effects are there with the risks and shortcomings from these options have been identified. I think some of them are like this: precipitation pattern could change. Because remember, you are actually trying to put particles into the stratosphere. So this could affect the stratospheric ozone, which is actually very important for the life on the planet, right? Ocean acidification is not addressed. So some of your biology students might know the increasing atmospheric carbon dioxide is actually making the ocean acidic, right? So this acidic ocean problem may not be solved with this particular option, right? So that's what this particular international report found out at that time. All right. Now, this is a report that was produced by UNEP, and it was published just this year, 2023. In fact, I was also an author in this particular production of this report. It's a very short report, only 40 pages or so. So here are some quick results. I mean, I know you are probably only geography students are maybe used to seeing these kind of global maps. Many of us are used to seeing India map or Karnataka maps. But anyway, this is how the global, when you look at the global picture of the climate change, we are used to making these kind of global maps. And what it says is, this is just an example, illustrative example. For instance, if you increase the carbon dioxide, if you double the atmospheric CO2 concentration level, this is the warming pattern that is produced around the planet. This is by computer simulations, right? So the global mean warming, if you double the atmospheric CO2 concentration, is 3.26 watts per meter square, all right? Now, if you basically choose exactly an amount of sulfate in the stratosphere that can offset that, you can see that the global mean warming is completely perfectly offset, 0.01, and this is 3.26. But there are some, I mean, the offset is not perfect, you can see. There is some residual warming in the high latitudes, and the tropical regions are a little bit cool. But when you average this whole thing out, so this option is not a perfect at every point, but at the global average, it can offset that. And this is the rainfall change pattern with the global warming, and if you do the solar geoengineering, right? So you can see the climate change causes overall an increase in precipitation over the planet, something like 6%, the planetary rainfall increases. But if you do solar geoengineering, look at this. Even though this you perfectly offset, this is not offset. So there is a hard science related to this, why you can't actually simultaneously offset both the water cycle changes as well as the temperature changes. If any student is interested, maybe after the talk, we can talk about this. This is really a research problem. All right. Now, yeah, so the natural question people ask about is, what about extreme temperatures and extreme precipitation? So this is actually research from my own group at the Indian Institute of Science. So you can see this, the pattern here, the red color indicates the extreme event intensity of extreme events under climate change. And then you have this, the blue line is what we have currently. So under climate change, you can see that the extreme events actually increase. All this red is on the top. But if you do geoengineering, you can see, in fact, most places, the green line is in line with blue, or it's even actually slightly overcorrection. So the extremes could be actually overcorrected by solar geoengineering. So it does work. So the solar geoengineering actually is able to mitigate global warming, as well as it can actually reduce the extreme events. Okay? All right. In fact, but again, once you get into the research problem, then you have to actually look at all kinds of issues. How you are actually going to inject aerosol? I think that's the one question that people are you going to, how are you going to get uniform aerosol around the planet? Okay, so we actually looked at what if the aerosols are actually injected at various locations on the planet. You can inject the aerosols at the equator, or 20 degrees north, 30 degrees north, or 40 degrees north. So this becomes now a research problem. So what we found was, if you inject the aerosols at the equator, so here is the equator scenario, the rainfall is actually a little bit reduced over India, something like 4% there is a reduction in rainfall over India. That is not bad, but for some reason, if you inject the aerosols at, let's say, 15 degrees north or 30 degrees north, so in general, if you inject the aerosols in the northern hemisphere, India is severely affected. Indian monsoon, as you can see, up to 30% reduction in Indian monsoon can happen. So you have to, this is where it becomes an engineering problem now, right? So how we are going to design a scheme, right? Okay, but people are working on this, so nothing to be alarmed about that. So we have to identify exactly how you would do it and what are the risks associated with that, or basically it's more like an optimization problem, how you can actually maximize the benefit, all right? All right, so this is another study in my own group at the Indian Institute of Science we did almost 5 years back. So there is a, people are actually, there is a lot of conversation about this, whether you want to do global scale geoengineering, or you want to only do regionally. For instance, people are worried about Arctic ecosystem. Arctic is the place where it's cold, there is ice cover, so people are concerned that in the Western countries, the sea ice might disappear in the future. So there were some proposals, okay, let's do the solar geoengineering only over the Arctic to cool the Arctic, but let's not worry about the other place. But if you do that, in my research group, what we found was, if you do only Arctic geoengineering, you could actually reduce the rainfall over all the monsoon regions in the northern hemisphere. So you can see here, this patch of red, it indicates rainfall reduction. So, right? So again, you have to, before you do, you can have a proposal, but you have to actually verify how it's going to benefit. This is obviously going to benefit the Arctic, but at the same time, remember the global, just like we are talking about globalization. We are talking globalization of only humans, but nature is interconnected, right? So atmospheric circulation, it is of course interconnected. What happens here, it is connected to what happens in the polar regions. It's a fluid, right? So what we do to the Arctic actually affects what happens in the tropical region. So these are some of the questions that we have to really address before taking any decision. The decision may never come, but it's good to understand how the climate system works. All right. Now, there are, of course, problems identified. I'll just go through very quickly what problems. So, for example, you look at the sky when it is a clear day, beautiful blue sky, but if you have particles in the sky, it's muggy, right? slightly invisible. So although we are putting these particles in the stratosphere, remember these are particles, micron-sized particles. They will produce diffuse light. So this is what happens if you increase there is a metric called aerosol optical depth. If you increase, when the aerosol optical depth is really small, you see beautiful sky. You see this how it becomes hazy, and then, so this is the amount, if you want to offset, we might actually end up putting. So you can see the skies could be actually permanently, in fact, made a little bit hazy. That is one problem. The other problem is, this is people thought this is a major problem. I mean, remember, acid, sulfate is acidic, right? So this could actually eventually change the, even though you are putting in the stratosphere, it's going to finally fall down. So within a couple of years, actually it will fall down. Just like you saw in the case of volcanic eruption, within 2 years, the volcanic effect vanished. So these particles basically rain out from the stratosphere, they come into the troposphere, and then finally they get into the surface, right? But then you could actually, but the only good thing is, humans right now, we are emitting nearly 50 times more than what is required to do this. So the problem is not that severe. It is on the order of, you might actually increase the acid rain problem by 5 to 10%. So if we can actually take that risk of 5 to 10%, this is okay. So it depends on what level of tolerance is okay. Okay, we did talk about the ozone problem because we are talking about disturbing the stratosphere where ozone is present. Already there is a hole, ozone hole in the stratosphere in Antarctica. So this is a study that looks at the ozone column in the Antarctica, 63 degrees to 90 degrees, and it did actually find, as soon as this is the point where this is a model simulation. It shows that Antarctic hole could become deeper initially, 10 years. So we are already on the path of recovery. You see this Antarctic ozone hole, it is recovering. It is actually supposed to recover by 2070 or so to the previous level, all right? But if we do this stratospheric solar geoengineering, it could delay the whole process. The recovery of ozone hole could be delayed, okay? All right, there is one severe problem that is what is called a termination problem. To be, let's say, so what we are doing by putting aerosol into the stratosphere is, we are not really addressing the root cause of the problem. Root cause of the problem is really carbon dioxide. So we are not really doing anything about carbon dioxide. So some people have really bluntly said, aerosol is actually a pollution, right? Aerosols are a pollution. So you have a pollution problem with carbon dioxide. So are you really trying to address that problem with another pollution, right? So now, in that sense, putting this aerosol is, for instance, during COVID time, we all put masks. COVID is around, so we are masking it, so that it doesn't get to you. Same way, putting aerosol in the stratosphere for climate change problem is a mask. The moment, if you remove that mask, the problem is still there. The higher atmospheric CO2 concentration, that is actually already there. It's not gone. No, in case, because of, let's say, we have implemented stratospheric aerosol engineering to the full extent, and the planetary temperatures are, let's say, offset by 3 or 4 degrees. Now, what if something goes wrong? It could be a simple terrorist attack of this system. Then you are exposing the planet in a very short period to huge amount of carbon dioxide that has actually built up into the system. So for quite some time, people thought, this is a serious problem because, then you are subjecting the Earth to extremely rapid climate change. The climate change that is happening over hundreds of years, you might actually make that happen in just 10 years if this unmasking problem happens, all right? Okay, so I think if there is, what I have next is really mostly political, what is happening in the international community, how serious the problem is. Just to maybe I'll show a few slides. So, the US Science Academy, National Research Council, they basically produced 2 reports in 2015, 8 years back, climate intervention, reflecting sunlight to cool Earth. So that, it was a book. So if anybody is interested, you can go back and look at, this is a scientific report. And then they also looked into this carbon removal option. I didn't really talk about this one, but this is also called climate intervention or climate engineering. And then, we did, there are lots and lots of reports now then after, but all of these reports, if you really look at, it happened only in the last 1 or 2 decades. So this is a European assessment of climate engineering. You can see here, European assessment of climate engineering. And then this is about carbon dioxide removal methods. But I think I talked about this termination problem. So this is one way now scientists are looking at the long-term approach to address climate change. So let us say we are basically on this path of emission, right? So I think we need to cut emission, but cutting emission may not really, so let's say this is a target of 1.5 degrees or 2 degrees. Now, cutting down emission, it's not possible to bring the temperature all the way here. So instead, you reduce it a little bit, and then the so-called, I'm sure many of you are aware of this, people are talking about afforestation, and afforestation is one way you can actually remove carbon dioxide from the atmosphere. There are multiple options like that. So those are what is called carbon dioxide removal. So the carbon dioxide removal can bring the CO2 temperature to this level, and then you would employ this geoengineering only during this short period so that the temperature can be kept at your target level. So this is a proposal, all right? Okay, so then this is basically an assessment report which basically said SRM would be effective to address climate change, but it is too early to assess its feasibility. This was mainly, there will be, I think, all I have talked about here is really the physical science issues of solar geoengineering, but there are a lot of social scientists who are, also should be involved in discussion of this. And what do they say? They say public resistance, ethical concern, and potential impact on sustainable development could render SRM economically, socially, and institutionally infeasible. Because there is a whole spectrum of people who are doing social science research. We have to actually involve them, and I think that is, of course, happening. But this statement was actually probably, this is a report written by a report written by a group of scientists, and the lead was a social scientist. All right. So the latest IPCC report, which came out in 2021, they also assessed this. What do they say? They said, yeah, SRM has the potential to offset warming, but there could be residual climate change and overcompensating change. We saw that in a previous slide. And it could introduce a wide range of new risks to people and ecosystem, like the acid rain problem that we looked at, the termination problem we looked at, the ozone hole problem. So there has to be a holistic assessment of that. And also it said, yeah, there is a lot of uncertainties and knowledge gaps are associated. In fact, there is a lot of risk associated with that, mainly the societal risk, okay? Yeah, so very latest, 2021, the US government actually took this even more seriously compared to their 2021 report. This report even actually said, okay, the US government can actually invest some money to study this particular problem, $100 million to $200 million over the next 5 years. All right, that's anyway, that's only a recommendation, so we'll see what happens. All right, so this is the latest report. I think I'll just quickly go through this. So I think just to inform you, the large number of reports now coming out about this new, one of the new options of addressing climate change. So this is UNEP report. This is not a US report, this is a global report. So what do they say? They say a robust scientific review is needed for this particular thing, because there are benefits, there are risks. So what is the optimal thing? And so there has to be a rigorous scientific assessment of this. And then governance framework is needed because this is a global commons problem. This is not a single nation problem, right? So what you do, what India does will affect China, or what China does will affect India. So this is a trans-boundary problem. So there has to be global conversation on that, right? So yeah, so globally inclusive conversation is needed. And because you could affect the stratosphere, probably there is a regulatory framework for how we basically protect the stratosphere in the future is also needed. All right. Right immediately after that, the White House also came out with a report. This is this report again. I think it's very similar to the UN report. So it says, okay, make an assessment of the risk with climate change, risk of climate change versus risk of solar geoengineering options. And so, yeah, you need to have a social, basically justice perceptions, acceptance, etc. So you need a holistic assessment of this problem, not just the physical science aspects. And you also need transparency, right? Because what we do could affect others. So you need transparency in research as well as if you, in case, if you deploy, we need transparency in that. And also international cooperation is needed, just like how we are basically dealing with the climate change. This is also a global problem, so we need to have a international cooperation. Yeah, so these are a whole bunch of new things that are happening. UNESCO is writing a report on that. There was recently a report called Overshoot Commission report. This is American Geophysical Union is looking at this. European Commission is looking at this. So, I mean, they're all just looking at this because, I mean, I think what I'm trying to say is it is basically sensitizing the governments about this particular option that is being discussed by scientists. In fact, right now, what has happened, this is the latest, this paper came out in very, very recently. So it's saying that because of this, increased activity in this domain, what the US government actually has initially put some money is to observe right now the stratosphere, because you need to first understand the background stratosphere before you do anything. So right now there are planes that are basically being used to basically observe or monitor the stratosphere. But that doesn't really get into the SRM research domain. But all this indicates is people are getting serious about this, right? Okay, finally, I think I just anyway wanted to give a holistic picture of the climate change problem. This is probably extremely useful to connect all the dots in the climate change problem, right? I mean, I spoke only about one specific issue. Now, let's go and look at this. I think this is very important for youngsters to understand. You start here, desire for improved well-being. We all want to actually live better, right? I mean, we all want to have car so that our transportation is easy. We all need air conditioning or conditioned temperature. So there is a desire for all of us to live better, right? Which will lead to consumption of goods and services. Here, consumption of energy, consumption of water, consumption of food. All of this actually, unfortunately, if you want all of this, it needs energy, consumption of energy. That's going to lead to carbon emissions, right? So the whole carbon emission is really driven by economic activity or our desire to have good lifestyle. There is absolutely no doubt of the link between economy and climate change is well established. So it's very important for youngsters to connect the dots here. So what that is doing, the carbon dioxide emissions, that's leading to carbon dioxide increase in the atmosphere, which is basically eventually leading to climate change. Now, we all know climate change, of course, leads to impacts on human ecosystems and everything. This is the biggest actually puzzle. That's why I put it as a red. Will it affect eventually to the extent of, it's going to affect our consumption pattern, or is it really going to create catastrophe so that we can't really consume what we actually would desire, right? Now, and also there is a inner writing here. These are the various options. So there is a link starting from our desire to live better to all the way to climate change impacts. So at every stage, you can break the link. For instance, you can conserve. The very simple step says conservation, right? If you are not in the room, turn off your AC, turn off your fan, turn off your lights, right? That's a very simple conservation. Or use less energy, right? I mean, you can still live comfortably, but at least you can remove the wastage of energy, right? So that's the conservation. So that will basically reduce consumption, right? And then consumption of energy is efficiency. You can, same electric appliance. I mean, there are improvements in this. I'm not saying anything new here. Everybody knows this, maybe not the youngsters, right? So you need efficiency improvements of appliances, right? And then consumption, so this is the low carbon energy, that is basically greening, right? So you can always go for different options of energy. That's going to reduce the carbon dioxide emissions. And then there is this is the engineering option that people are now working on, that is this CO2 emission. Basically, we are emitting CO2, but the carbon dioxide is increasing in the atmosphere, right? So you can break that link if you can devise methods to remove carbon dioxide from the atmosphere, right? Tree planting is a good example, right? Okay, the next link is, yeah, this is the one, CO2 in the atmosphere to climate change. So this is where this sunlight reflection methods come in. And then for climate change to impacts, of course, you can address that using adaptation. So the whole cycle here can be broken by conservation, efficiency, mitigation, adaptation, carbon dioxide removal methods, as well as solar energy, sunlight removal, sunlight reduction methods. All right. Finally, I think this is something to keep in mind. Why we are having this problem? Mitigation, including CDR. Mitigation problem is it's slow, costly, and scaling issue. Why I say that? We can't really get energy today from, carbon energy is still by far the cheapest available. I think that cost. So reducing carbon dioxide emission could be detrimental to economic growth. I think that is the single most reason why countries are unable to reduce carbon dioxide emission. All right. Adaptation has problem. You can adapt to 1 degree change, 1.5 degree change, but you can't definitely adapt for 4 to 5 degree change. We are already seeing unbearable conditions in certain time of the year in many parts of the world. All right. Now the problem. Okay, so this also has problem. So you can't also adapt. You can adapt to certain extent, but big climate change, serious problem. Now, what is the problem with the SRM? It is, the benefit is it can act within 10 years. You can bring down the temperatures. It is also cheap, but it could be institutionally infeasible. These are some of my thoughts on the various challenges we are facing in addressing the climate change. These are the options, but all of them have some challenges associated with them, right? And finally, this is my last slide. This just to give some instructions to youngsters what they should do. So, these are some popular solutions. So basically, increase the number of trees, reduce carbon emissions, reduce concrete jungles, right? And then finally, increase the number of lakes for. So these are all nature-based solutions. But I think by far still the biggest problem is carbon emissions, and unless the carbon emissions are brought down, that is the best solution, and that is basically what I would call as the prevention is better than cure. That kind of approach for medicine they use. Prevention is better than cure. So our carbon emission is the problem. So we need to really ultimately, it doesn't matter whether we have whatever option we have, the final ultimate solution is really reducing carbon dioxide emissions. Thank you.
Thank you very much for your wonderful talk, sir. It was very inspiring. I really don't know, because the meticalness, discipline, and the presentation, the message what you are taking from the presentation and that Bala, I have got every day. Even though I thought when I was forced to sit at the back of the session, I was not knowing anything about it. But I see what is all the time whenever you were presenting it, from first slide to last slide, you could have each and every point in a systematic manner. Our duty as a chairperson or the first chairperson is only to manage things and summarize in the end what has been spoken by the speaker. But our job he has made our job very easy, simple. And I just need to the audience, please see that you have a chance to interact with the scientists, great scientists. Suppose not expose artificial, right? They just made the thing very easy to take the message. Every one of in the end he has mentioned about prevention is better than cure. Very important message. Everybody in our day-to-day activities we mentioned that, but we are not following it. So bioengineering or geoengineering, whatever method we follow, ultimately it is individually how best we can cooperate and mitigate all kinds of solutions whatever we come across. So that's the message we have mentioned about these opening up all private. Yeah. It was excellent presentation and somebody also was excellent. But I have my worries. The worry is, after all, the planetary production on planet Earth is supposed to be better. The entire consumer system depends on the primary producer. What I mean by primary producer is the crops and forests and the land, fertilizer comes on the ocean. The solar radiation is modified and reduced as far as it operates right. Where do these primary producers get adequate, specifically active radiation, which is the driving force for the Earth system to function?
Okay.
So that was my worry.
No, very good question. I missed this out. I actually, since this was popular talk, I actually had a slide on this, but I didn't show it. Basically, you have to reduce the incoming sunlight by only 1% or so. So, in fact, in one of the slides I had, reflectivity has to be increased by only 1%, or the amount of radiation that is absorbed by the planet, it has to be reduced actually 1 to 1.5% only. So, people have actually also looked at this effect of, because we know definitely 1% reduction in sunlight is not going to be a major problem for phytoplankton or plants. People have looked at how this will affect solar energy production and things like that. But we have also papers looked at the carbon cycle, which means basically primary production and things like that. The sunlight reduction does have an effect, but it's not going to be of significantly, to be visible to affect our consumption.
But I am so with Krishna, cleaning of the planet Earth, both on the land as well as the ocean, should ultimately be the best solution.
Well, that is the best solution, but scientifically, the problem is, we have looked at this, there are a lot of papers on this. Even if you go back and completely, which is, let's say it's not possible, but still the best case scenario, where we completely recover all the croplands and put trees back, it will solve 5 to 10% of the climate change problem. The amount of carbon dioxide that we are putting from fossil fuel emission cannot be simply taken by plants. And the scale of the problem is, as I explained, we are putting 40 billion tons per year. The plants actually, I can't remember exactly, but we did work out this, and the best case scenario, by year 2100, you can reduce atmospheric CO2 concentration even if you bring back all the forests back, in the sense you basically fill your croplands, that all the development areas with forest. You can reduce atmospheric CO2 concentration by only 30 ppm. That's only the capacity. It is good, so I think it is so. If you look at many of these solutions, they all look attractive, but when you work out the numbers, I think the main conclusion I always come to is you need a portfolio of solutions, because they constitute only 5 to 10% of the overall solution. entrepreneur.
Okay.
I have limited knowledge on this subject, but the best thing is that there are so many points which one can pick and implement on day-to-day activities,
Yeah.
even in your professional life.
Yeah.
Here I have 2 points. One, is there any herbal way?
Any?
Talk about
Herbal.
When I said herbal way,
Yeah, yeah,
we keep talking about air quality index
yeah,
and particle matter. It's very complex field for common man.
Yeah.
Even at the scientific world also, it is very difficult to differentiate the variance of air quality
Yeah.
index and composition behind that at global level. If you go back to say 100 years or beyond that, the air quality index was totally different.
Yeah.
Maybe if you go back to millions of years when you say,
yeah,
that was totally different. At time, I think there could be healthy volatile organic compounds.
yeah,
And volatile organic compounds now, considering the emission by recent fossil fuel and industrialization,
yeah,
there can be a lot of scope to think how to bring back that particular volatile organic compound which was there in the forest
yeah.
and which due to urbanization has impacted all our health. When I said herbal way, is there any way where that can be understood better? And is there any points you have which a common man can make use of it? Thank you.
Okay, yeah, first I want to clarify, I think what you talked about was a air quality problem, which is really very, very different from climate change problem. Let me tell you the distinction. Climate change is caused by CO2. CO2 is not a particle, it's a gas, right? Aerosol are particles which are micron size, micron or submicron size particles. Particles are different from gas, single atomic molecule kind of stuff, right? The air pollution, of course, it is co-emitted with CO2 gas. When you burn coal, the coal, for example, when you in the burning process, you release CO2 as well as sulfur dioxide particles and other soot and things like that. Okay, so air pollution and climate change are linked, but they are different. The source is there is a common link. All right. Now, the air quality, I think you can actually solve. Many countries have solved this. I mean, I wouldn't say completely solve this. For instance, the U.S. they had problem, acid rain problem in the 1970s and 80s because similar. I mean, it's just they didn't have the knowledge about. I mean, they were, let's say you use the coal in your power plant, you just directly release it, and you just basically release the sulfur dioxide out. But then they basically found a way to, right at the source itself, remove that sulfur dioxide before it gets emitted into that. But they didn't, of course, do that for CO2. CO2 is a different problem. So many countries have actually taken effective measure to reduce this pollution problem. UK faced it because they were the first industrialized nation. So they basically phased down coal-based energy. Same thing is happening in developing countries. Now China, they had some years back very severe air pollution problem because again, coal related, right? India, we have severe problem in the North India right now, mainly because of crop burning. The farmers in Punjab and Haryana, they burn the crop residues right after harvest. So that's basically the wind is carrying that to the Indo-Gangetic Valley. So the problems are different. Air pollution is localized. Climate change is a global problem, right? Where you put the aerosols by the nature, the aerosol lifetime is only about 10 days, but CO2 lifetime is hundreds of years. So the problems are different, and air pollution, countries have taken effective measure, and I'm sure we will tackle that problem in time because, but always, the air pollution problem, it has always gotten worse before people addressed it and reduced it. For instance, China is now taking very strong measures to control the air pollution problem. So in Delhi, and in fact, if you read the newspapers, every winter you hear about this odd even, the transport during the capital. But we know the problem is it's mainly from the crop residue burning in
Punjab and Haryana. And the government, I mean, that's the source. We don't know right now how to, it's a political problem right now. Yeah. See, even Bangalore, we definitely have, as per the World Health Organization number, the whole India is above that number, there is no doubt. Because even if we don't do it, it's a pollutant that is carried away by circulation. So in general, the background numbers are pretty high in India. And I am actually very confident it will come down as we move away. All basically countries have gone through this, all developed, all the countries that developed, they have gone through this stage. So we are in that stage right now. So, but it can be effectively taken care of. Yeah.
He means there are plants, I suppose.
Oh,
they can absorb carbon very efficiently, as I mentioned some time back. There are different plants which radiate or absorb radiation. Can we select such kind of plants where there can be at least little bit of carbon which is being, unnecessarily being released in the atmosphere? That's what I think we need.
Yeah. Yeah.
It has impact on the entire, I was under impression that acidification and all these are interlinked.
No, volatile organic compounds, as a climate person, to looking at the big picture, it's a very minor, I mean, regionally, locally, it could create asthma and all that thing. But it's a local problem. That has to be addressed locally. Yeah. I mean, if you have, let's say, if you select a tree that produces enormous amount of, let's say, pollen during a particular period, I mean, the residents around that locality are going to suffer from asthma, right? So let's not, I think, bring, I mean, that's not part of the global climate change problem that we are actually, we are talking about warming and those kind of, not the health issues. Yeah.
Just one or two questions from the student side. So God says, I will not change any settings. He has not changed any settings.
Yeah.
Please go to remote setting.
Yeah, right.
Increase number of trees.
Yeah.
Reduce carbon emissions levels.
Yeah. Yeah.
Reduce carbon fingers.
Yeah.
Increase number of lakes.
Yeah.
Basically switch to doing more from artificial.
Yeah.
Doing all these reduce carbon emissions, reduction, competition, increase number of lakes.
Yeah.
Actually, all these are getting reduced already. In Bengaluru, there were so many 600 and 800 lakes. Today, come to less than 100. God only knows how we can survive in cities like
Yeah, right. Yeah.
concrete jungles, if you see, it's close.
Yeah, I mean, Bangalore is,
And 80 crores, something like that. Carbon emission levels, how better we can reduce. Number of trees maybe will increase, so plant all like rainbows and all that.
well, trees also need water.
Number of lakes cannot be, all the lakes are eaten up.
Yeah.
Every lake, in Bengaluru, it was a classical, it is a classical example that
We are all going to pay price for this.
we have
We are already paying. Yeah.
buy it many reduce and all that, bad place, you
No, I mean, I 100% agree with you. I don't like it. I feel I'm paying price for all this development.
Sir, thank you for the very good talk, sir. You have done all the research and presented and all that, sir. But you have given a very decent solution in the last slide. So, are we not wasting our time doing research on increasing the aerobic and the aerospace and that's indirectly affecting the forestation, the deforestation, acid rainfall, and as such that it will reduce the ocean productivity and carbon dioxide. So why can't we do more research and our time and energy towards your last like solution?
No, but it is not happening. That is what the concern is. I'm not giving anything totally new, and people have been talking about, scientists have been telling these things 30 years back since. But the reality on the ground is different, because right or wrong, I don't know. I mean, I can only tell what the reality on the ground. Let's say COVID was a year when actually carbon dioxide emissions actually went down, right? Because the economic activity slowed down. But as scientists, maybe that's a good news. But for politicians, that was a very bad news, because the economic activity slowed down. So that's all gets into politics. So we as scientists, we can tell the facts, but these are solutions that involve society, involve multiple countries, multiple states, negotiations. There is a political process at the international level. It's a complex problem. The reason is simple. If India decides, oh, emitting CO2 is bad, right? And we stop emission, but we still will be affected by climate change, because so this has to be done by all. If you want to address really the big picture global change problem, you can solve your problem within the national boundary, whatever you can do, for example, to the well-being of your people. But the global atmosphere, there is a nice paper long time back, it's called Global Commons. In fact, it tells very clearly, when it comes to your own property, you don't make it dirty. But when it comes to public property, you don't care how it is. That's exactly climate change problem is, because the atmosphere is a public property. It belongs to everybody. So we are polluting it, we don't care about it. I think, I'm a scientist, I don't want to discuss, the intricacies of all this, the complexity involved in this problem. Yeah.
There are many things to be questioned and answered immediately. So, hopefully, always available here also in the institute. Anybody who has got any doubts, further doubts, you can clarify now only, and also you can have his contact number, and be in touch, and let us all together join and see that there is not any such pollution again to carbon emission. So, on behalf of all of us join here.
Thank you. Thank you. In fact, I was real. Thank you for, in fact, very quietly listening, and I was really, this is one of the best audience I have seen, and I thank you all. Yeah.
Thank you very much, sir. As you told, it is all human-made. It is in our hand to save it or destroy it. So, with this, once again, thank you very much, sir. Now, I request our CEO, Dr. A.M. Ramesh, sir, to present a plant as a token of our respect to the keynote speaker, Govindaswamy Bala, sir. And also appreciation certificate. I request Dr. Vijay Kumar sir, please present appreciation certificate and plant to the today's chair, Sri Pada sir. Professor Sri Pada sir.
I am really thankful to the opportunity given to STA, particularly my personal thanks to Dr. A.M. Ramesh and his team. We will see that this will go on, because he has got a better vision, and we all come together to join his effort for making any scientific adventure what we make as a scientific organization recognized by Karnataka state government. Okay, thank you very much on behalf of me and also my coach.
Thank you, sir, for chairing this session. I request Sripada sir to present a plant and appreciation certificate to co-chair Dr. Dodbasappa sir. Thank you, sir. So please request all of you, please come quickly in 5 minutes having tea. Already we have another next resource expert is waiting here. So don't make late. Please come as quick as possible.
Yeah, I was looking for you in the morning, but you are busy probably.
Dr. Gopal.
Yeah.
Gopal Swami Bala. Bala Gopal Swami
Govinda
should
Swami.
be, Govinda Swami should be, stop leaping. He looks at the sun and
Oh, okay.
make him bright.
Malay University. He has got more than 21 years of experience in private and also government organizations. He published 21 books, 58 papers, research articles both in national and international journals, and 31 scientific papers. With this brief introduction, welcome you for accepting as a co-chair, Dr. Vijay Kumar sir. Now, please introduce today's chair, Sir Gangadhar sir.
Thank you, sir. A brief introduction of Dr. Gangadhar Narbanji. He is the head of Department of Entomology and Department of Entomology, College of Horticulture, Bangalore, and his educational qualification is PhD in Agriculture, Entomology, University of Agricultural Science, Bangalore, and MSc in Agri, in Agriculture Department of Entomology, University of Agricultural Science, Bangalore, and BSc Agri, Entomology specialization. And his total year of experience is 20 years in teaching, research and extension, and student guided for MSc Agri 10 and PhD 2, and external funded project is 400, and publications of his 62 research paper and international papers of 12 numbers and national papers of 30 numbers, and paper presented in seminar and conference is 20, and participated as a resource person in more than 200 farmers training programs. With these brief introductions of Gangadhar Narbanji, welcome you, sir. Thank you.
Thank you, Dr. S. Vijay Kumar, co-chair of this session. It is my privilege and I am very happy to introduce this the speaker of this particular technical session. It is on role of geospatial technology in climate change mitigation. Ramchandra Hebbar sir, very experienced scientist, and sir has experience more than 30 years in geospatial application for utilizing multispectral, hyperspectral, microwave, LIDAR and UAV images for agriculture, forestry and ecology and urban studies and water resources, etc. And sir has executed many projects which are related to the urban sprawl and change protection and growth modeling and urban flood and urban lakes, etc. And he has trained at Israel Aerospace Industries on microwave data processing and analysis. And current interest in UAE and artificial intelligence and machine learning applications for geo intelligence. And sir has delivered more than 102 presentations or lectures at various academic forums, and apart from that, he has guided more than 65 batches of BTech, MTech and MSc students, and has published more than 83 papers in reputed peer-reviewed journals. And he has wrote more than 5 book chapters and 26 reports in various journals. And most importantly, I am happy to share this information. Sir has received ISRO Team Excellence Award during 2012. With this brief introduction, and I invite Hebbar sir to start his presentation. One of the very important topic, role of geospatial technology in climate change mitigation. Having agriculture background, I am working in agriculture and horticulture, the science, and we know the importance of remote sensing, application of remote sensing in particularly in agriculture in general and horticulture crops. Probably I think yesterday one of our senior professor by Dr. S.L. Jagdish sir mentioned about the importance of application of remote sensing and geospatial technology in particularly in agriculture scenario. So one of the important thing is that a lot of the discussion is going on regarding measurement of soil moisture and soil health, and also pest management including insect as well as disease management and cropping pattern across the state, across the nation. And when we talk about the cropping pattern, vegetation analysis and soil health measurements and mapping of the soil health condition, a lot of initiation is taken by the government side also, particularly soil health cards and other things. So when we talk about all these things, crop health management and soil health management, and apart from all other things, the remote sensing plays a very important role. Or geospatial technology comes into the very, very important other thing, and this topic is need of the hour, and the understanding about application of this technology is the timely required thing, and hence I appreciate KSTA for positioning this particular the aspect that are included in this particular national conference. With this, I request Hebbar sir, please.
Thank you, both chair and co-chair, as well as a lot of students I am seeing from Bangalore University. So I was just discussing with them. So one thing what Bala told, Professor Bala told is very good audience. I hope you will keep the same tempo even future, in my session also, because I am giving a lecture or a presentation during lunchtime. So already it is, I think 12:45, 12:40. So I try to complete at the earliest. They were given 1 hour time. So I have to take at least 45 minutes. No? Otherwise, I will not making justice to this thing. I hope you will be peacefully sitting and listening, if possible, because it will be sometimes it will be difficult during lunchtime to sit, and not only for you, even for me also to give a presentation. Professor Bala also touched upon some of the things. Last slide I could see regarding more trees, more lakes and all those things. So that is where geospatial technology will come into the picture, in the sense that how much we have degraded. Climate change is happening, all of us know, because of various reasons. So how do you map all these things? How much of natural resource whatever is having, how much it has been degraded or improved or whatever is, how do you do this? So this is where geospatial technology will come into the picture. So I'll try to touch upon some of the aspects of fundamentals of geospatial technology along with some of the applications with reference to climate change as far as possible. Lot of geography people are there, students of 30 students I understand. And I also invite people to our center, which is located in Marathahalli. So any of the students and a lot of students, they come. It is a little tough for us also to organize many times because of various reasons. But I invite students who can come there. You can also do some your internship and other things, at least minimum 3 months, not 1 month, 15 days I cannot provide. But if you want to do it for say 3 months, 6 months internship and other things at BSc, MSc, not BSc, MSc, MTech or PhD level, you can come. There are a lot of interesting things that can be done using remote sensing or geospatial technology. With this background, as rightly pointed out by Mahatma Gandhi ji, Earth provides enough for our satisfy our needs, but not every man's greed. So this is how the climate is changing very fast. So I think probably we have observed, especially people like me, where we are all around 50s, 60s and 70s, we have observed the climate change very fast, very, very fast. 80s, I was there in Bangalore, in the same campus of GKVK only. It was fantastic. There was no need of fan. But now the scenario is very, very changed. It is not only the fans, we also require ACs now. So that is the situation. So these are all because of, I can say, some of the grids, if not all. So with this UN, United Nations, they have come out with the developmental goals. Everybody have, aware of these things. I don't want to touch upon this. I just want to touch upon this. Some of these, especially the poverty, the hunger and all these things, how to come out of all these things. That is how the UN, the Food and Agricultural Organization, also working towards how to reduce this global level issues and other things. What is climate change? Probably in the last 1.5 days, they would have told you what is climate change. Basically, it is anthropogenic. Climate change happens, there is no doubt about that, but it is in the geological scales, in some millions of years. That happens very naturally, it happens. It happens not only in, in Earth, even other planets also, it happens to a great extent. That's all, maybe most of you are aware of that. But this is where the problem is the anthropogenic. And the major drivers is GHGs. So all of you are aware now what is the GHGs. And also the aerosols. And in addition to that, you have a lot of land use, land cover changes that is happening, especially with reference to the forest and other things. So degradation of forests, that is one of the biggest challenge probably our world is facing now. So now after maybe last 2 decades, before that people are not believing that there is a climate change, because there is no enough proof was not there. But with a lot of satellites and other things, and also conventional techniques, measurement of a lot of this, especially the temperature, rising temperature and other things, it is very clear cut now. There is a global, climate change is happening, and there is an increase in the temperature. And there is very consistent that there is an increase of more than 1 degree centigrade temperature increase. So now everybody agreed. Earlier there was a lot of hot topics or discussions are happening whether there is a change in climate or not. But now it is very conclusive evidence is there saying that there is a climate change, and all of us are feeling now. Everybody is feeling that there is a lot of climate change is happening. So in order to understand the climate change and other things, they have come out with what is called as essential climate variables. So there are 54 essential climate variables are there. Students who are interested, you can go through this. There are a lot of literature is available, lot of data is available. For your kind information for all your students, there is Google has come out with the Google Earth Engine. You please go through that. lot of studies can be done, lot of analysis can be done. All open source data is available, right from satellite data to many other things are available. You can do a lot of research. If you are having some Java or Python knowledge is available, you can do a good programming, you can do it. So there are at least around 34 ECVs can be estimated using the satellite data. So that is one of the important things. With this contest, ISRO has come out with what is called as one group. They have come out with one group, what is called as a NICES, basically National Information System for Climate and Environmental Studies. We generate lot of global or especially for Indian context, we generate a lot of products and services we are generating. So that is available in our NICES portal. We also have one portal called Bhuvan. So a lot of data is available which can be downloaded. So these are all essential for generating information at regional and national level, not at micro levels. Okay. So these are the products and other things we are generating under NICES, which is openly available. People can download. There are almost 70 different products, satellite derived products. When I say product, it is a geophysical or biophysical parameters. Whether it can be temperature, it can be rainfall. You are getting in terms of the maps. Okay, may not be at a local level, but at the regional level, at a higher levels. So it is all validated products. So with this background, there is a lot of potential is there as far as geospatial technology is concerned. I have listed many of the things. There are many more things can be done. I will not go into the details of this thing. These are some of the things. Basically, the land, water, and atmospheric monitoring. When you talk monitoring, there are many things can be done. Okay. So what is geospatial technology? Now it is more or less clear that the geospatial technology, when you are talking, it is a different convergence of technologies, especially from the Earth observation satellites. Then you have global positioning systems, geographic information system, basically to analyze the data and other things. Then you have with the latest development in terms of mobile application, web-based solutions, artificial intelligence. Everybody now talks of artificial intelligence, especially it's a buzzword now. Everywhere you see there is artificial intelligence, people talk. So these are all possible because of a lot of satellites in terms of LEO satellites at 300 to 800 kilometers above the Earth, which is remote sensing. Now many of these service providers, internet service providers, they are also coming out with the LEO type of satellites, that 10, 20, 30,000 satellites being launched by different groups, basically to provide low orbit internet connectivity. So it will be very efficient because we can provide anywhere in the world, any local, rural areas also. But not like Bharati and Aarti now coming out with such type of internet connectivity. Now you have GPS satellites started by this Navstar US, that is at around 24 satellites at 20,800 kilometers, which gives a location of the any point on the Earth. Then you have a lot of communication satellites, which is at around 36,000 kilometers. It is not only communication, all broadcasting, meteorological applications. So nowadays, anywhere in the world, if you want to see cyclones and earth, it can be monitored. I think recently there was one cyclone happened in, I don't remember, I think near to the Palestine or some that region, because they are unable to monitor. So that's why lot of damage happened. But in the Indian context, many of the developed countries, if you see, they monitor very critically, and we can find out where exactly the cyclones and earthing movement and earthing. There are a lot of satellites are available for this. So this is one of the satellite images what you are seeing, where you can find out the movement of clouds and earthings. Very interesting for some people to study this. These data sets are available, freely available. We can every hourly movement and earthings can be easily found out, and we can also find out where exactly the cyclones and movement and earthings. So this is exactly what IMD gives. When you come to GPS, global positioning system, started by the Navstar, what is called as a Navstar. So basically it works with the triangulation. I will not go into the what is triangulation and earthing, triangulation, all mathematical or trigonometric this thing, which is very easy to understand. And but all this what you call global position GPS, which is having inaccuracies. These inaccuracies vary from 10 to 50, 60 meters also. So we need a higher accuracies. So one of the system what we have come out with, SBAS, space-based or satellite-based augmentation systems, which is basically for Airport Authority of India. But during the Kargil war, there are a lot of discussion you must have heard. Even during the war between this Russian war also, they have stopped giving the good signals, GPS signals, accurate GPS signals. Same thing happened during the Kargil war. So India wanted to have their own GPS system, but it's called as a NAVIC. Probably in a couple of months or couple of year time, we may get NAVIC signals in most of the mobiles. Okay. So when you are coming to remote sensing means I don't want to tell much because our eyes itself is a best remote sensing remote sensing technology I can tell, where you can see so many things we can see from the eyes. So that it can be from ground based to satellite based. So different initially started with the balloons. So now we are migrated to one is a satellite and other is towards UAV. I think yesterday you had a very good lecture on UAV also. So most of these satellites, they contain sensors. What are these sensors? Initially we had panchromatic sensor started during 1950s by US and other countries, basically for Cold War period, to find out what is happening in each of these countries. Subsequently a lot of technologies happened, and nowadays we are having sensors which can monitor many things, including land, ocean and atmospheric constituents. We have atmospheric chemistry instruments are also available. I will not go into detail of this thing. Now currently we are having most of the sensors are available, data is available, which can be at a local level or at a global level. So depending on your interest, you can utilize this type of data sets. So one of the important things what is required, especially if you want to do hydrological modeling or even for agriculture, whatever he was telling about the soil and earthing, what you require is a very good elevation models. What is called as a DEM, digital elevation models. So there are several techniques are available, whether it is a satellite photogrammetry or close range photogrammetry. Using your normal camera also you can generate 3D images can be generated. You have SAR interferometry, very complex phenomena of SAR interferometry, and you can measure a centimeter accuracy. You can generate the information about the land subsidence and earthing, what is happening in many parts of the Himalayan areas. Then you have altimetry, which can be LIDAR or radar. I will not go into details of all these things. If anybody interested, they can visit our center. We can show all these things we can show. Then GIS, Geographic Information System, basically it is a statistical tools are integrated in GIS, where you can do data manipulation, data integration, all this union, integration, everything can be done, and very high level of integration and earthing is possible, and also modeling and earthing can be automatically done. Even the hydrological modeling, watershed delineation, all this can be done using a GIS. Mobile application, nowadays everything is mobile, cloud-based, cloud-sourced information. So now we are also having mobile applications. Basically, we have given to many, hundreds of applications has been developed from different ministries, all cloud sourcing, a lot of information is available with the Bhuvan. So some of this can be downloaded also. So that's what I was telling at the Bhuvan. So a lot of information is available, land use, land cover, and all such type of things are available. People can download and use for any of your research purpose. So just to tell about what is remote sensing, so basically when you are taking a picture or on our human eye, we can visualize what you see in the left side corner, which is a RGB image, a natural color. Basically the combination of blue, green and red. But remote sensing sensor, they have a very good capability beyond 700 micrometers, 700 nanometers. Up to synthetic aperture radar, what you are talking of, microwaves also, centimeter level. So this is where now we are coming out with one of the important machine that is called as NISAR, NASA and ISRO machine, which is recently it has gone from our campus to SHAR for launching. Probably in January or February we are going to launch that satellite, which works at microwave frequencies. So this is how we are getting an image, what is called as a false color composite in comparison to a natural color composite, where all vegetation looks red in color, because we can see these spectral plots we can see simply because we are having a very high reflectance NIR band, that is a near infrared band beyond 700 nanometers. So because of this combination, you are getting all the vegetation red in color. As I told earlier, microwave data, because during the optical data, when you're talking of 400 micrometers to nanometers to 2400 nanometers, there is a problem of cloud during the Kharif season or the monsoon season. So you will not get the data. So in order to get data, you will have work with the microwave data. That works at microwave frequencies just below radio waves, something like a centimeter wavelengths. So this is which can penetrate through the clouds, so that's why you will be able to monitor many of the things. But there is a difference between optical and microwave data because its interpretation and other things are very complex. So still we are trying to understand these things. But at global level, there are many synthetic aperture radar machines are available which can be utilized for many aspects. When you are talking of satellite data, you have different resolutions, spectral, spatial, temporal, all those type of resolutions are considered. So when you want to do a global studies, it can be 1 kilometer or 5 kilometer type of spatial resolution. But when you're talking of cadastral level or cartographic level information, our geographic people are there, and they may be aware of what is a cartography. So when you're talking of such type of thing, we require very high resolutions to the order of centimeters are better than meters are better than meters. So in that context, we require a very high resolution data. The problem what is there is a this thing what you call you will not be able to get every day if you because its swath is very narrow, 16 kilometers or 20 kilometers. So in order to cover say Bangalore frequently, you require number of satellites. So earlier it was not possible. Nowadays you can see PlanetScope, which is the one company from US, they have launched around 160 satellites. So that every day they will get the data at interval of every day they will get, and not only every day they will get even hourly data also. It's possible to get it with the type of satellites what they are having now. So that is how possible with the number of satellites. Otherwise you will get the frequency of data will be very less. So now we require very temporal resolutions are very essential in order to monitor crops, especially when you are talking of crops, crop phenology. When it is sowing has started, when it is getting harvested, or even if you are talking of forest and other things, if you want to monitor, you require a frequent data, at least at important phenological stages, maybe once in 15 days and other things. There are satellites are available which can give such type of information can be given. So what you can see from satellite data, you can see so many things, but only surface. You cannot see anything subsurface. Subsurface are also possible, but there are different instruments are there for subsurface, but basically that is only for surface phenomena what you can see. Here you can see a fantastic, I think many of you are from Karnataka state, you can probably you will not know all these things. You see the Karnataka, if you see the in the western part, beautiful coast, followed by fantastic your biodiversity hotspot, Western Ghats. Then you have southern part of you are having a Mysore and surrounding where a lot of plantations are available, coffee plantations or coconut, such type of thing. You go to northern part of Karnataka, you have black soils, a lot of crops are cultivated. Of course, this is the crop season which is during January, February, so you will find exposed soil. So soil mapping and other things are possible. And this is what I am seeing the right side, which is very high resolution data acquired for GKVK campus, where you can see this thing also. This campus also is there. You can see high-rise buildings and other things of our administrative buildings and other things. You can see mango and other crops you can see. So we wanted to study some of these things, and also we initiated some R&D activities with the University of Agricultural Sciences, how we can monitor all these crops and other things, do a very high-level research. So as I told you earlier, I is the best interpretation you can do it, you can do anything. So that's how during the 70s and 80s when you are just joined our office around 18, I joined around 93 only, I'm still young only. We used to manual, I think there are people are there, our colleagues are there, they may be knowing more about manual interpretation. I had the occasion to do only digital type of classification. Initially we used to do visual interpretation. We were having some tables and other thing. We'll put a hard copy, then we will do interpretation. Very difficult. Then came the per pixel classifier type of things has come, which is basically automation. Think of PCs during that period, workstations, a very big workstations where it will have a hard disk of only 150, 160 MB only. But nowadays we are having, in terms of TBs we are having. Then object-based classification come into the picture during 2000 and beyond, which is also very good. But still, when you had a very good resolutions, there are advantages, disadvantages. You can go through the literature, you can find out all these, what are the advantages, what are the disadvantages. One of the biggest disadvantages as far as remote sensing is concerned is we will not be able to get optical data during the cloudy seasons. So I can say that is one of the culture, archaeology. So we are doing some of these applications we are doing. Just to say, so one simple example, earlier days, when a lot of subsidies are given for agriculture, especially the farmers, and a lot of subsidies are given. There is no monitoring mechanism. So now mobile application has become one of the very important tool for monitoring, especially watershed and other things. Pre, during and post. You take photographs and send it. That is how the mechanism have evolved for monitoring this watershed or ponds and other things. They monitor. We have lakhs of crores of such type of photographs are there. Most of these things go through BOAN. So with this background, we have land resource, what I told earlier. When you talk of land, it is a land use, land cover. When you talk of land use, how humans are using the land, whether it is for agriculture, whether it is for urban or any other things. When you are talking land cover, it is a natural these things like forest and other things. So there is a capability to do land use, land cover. Every year we are doing it, as well as every once in 5 years, very high resolution, 50,000 scale we are doing, and recently we have completed 1:10,000 scale. So these data sets, if anybody, any academic institute, if they are interested, we can write to us, we can give. And Karnataka State Remote Sensing Center also is doing the similar type of work. I hope they will be able to help you in getting this type of data sets. Soil, of course, there is no doubt, soil mapping can be done very efficiently. It can be done using satellite data. And with the climate change, as well as with the type of management practices that is being done for the agriculture, there is a lot of land degradation is happening, especially in terms of saltified soils, water logging and other things. So this also can be monitored very easily. So we have very mega projects are there to monitor all these things at a national level, so that ministry can take some relevant measures. So sometime back, there was a discussion about that enough research is not happening. There is a lot of research is happening. There is no dearth of research that is happening. But the problem is the policy interventions. That is where India lacks, especially the bureaucracy or the politicians. They don't take it especially at the state government, state level. Central government still is very good, excellent. I can say they are doing their implementation every time they ask this, we want this, we want. But the state level, no, because majority of the things, policy decision will be taken at state level, it becomes very, very tough. So we do a lot of work for agriculture, Ministry of Agriculture in terms of crop mapping, yield estimation, then agriculture drought, horticulture is becoming very important, doing a lot of mapping and other things can be done. Why I am telling all these things, when you have information about natural resources, if there is any climate change that are happening, we can find out how it is going to affect the natural resources. So first of all, you should have that base database. So remote sensing is one of the very important tool I can say to generate this type of database, a baseline database which can be used for many other things. Agriculture drought monitoring, especially for this is operational. It is being used by Ministry of Agriculture. Try to find out, sitting at Delhi, they can find out which are the districts, which are the taluks they are affected by the drought. So recently we had a big meeting in Karnataka, because Karnataka this year experienced a severe drought. So the team has come from Delhi. We had a meeting at Department of Agriculture, and this is what is the beauty of the things. Whatever the information that is generated by the Karnataka Agriculture Department in terms of the rainfall and its distribution are things, and what is observed from the satellite data by the ministry, more or less it was matching. So that is how the evidence-based solutions and other things can be provided for this type of thing. Otherwise, no, it is crores of rupees are being spent. You can see the relief as well as if you see the subsidy and other things given for agriculture or even insurance, it is crores of rupees, lakhs of crores. 50,000 crores is for insurance. So how do you give? This is even they make. I understand recently earlier, no, they were giving rainfall based insurance products. What farmers are used to do is they simply put water to tell that there is a water logging has happened. So these are many cases happen. There are automatic weather stations are available in many places. The people ella kaldre irudille. So what they do, they put water and it will show, always it will show there is a rainfall. So they claim compensation. So this is what, this is where, otherwise India can develop a good country within no time. But unfortunately we are seeing all these type of things. But another advantage is the remote sensing, we have a long-term database. For almost last 30, 40 years, we have a medium resolution, our core solution data is there. So we can utilize this for trying to find out how the drought and other things occurs naturally as well as because of the climate change related aspects. You can see here the drought vulnerability map, what you are seeing here. These are the areas, if there is any problem in the monsoon, automatically we can find out these are the areas where you have the problem as far as the agriculture drought is concerned. So this is the important information policy makers saying that this is the areas where we have to do some save the water. The saving of water may be any, there are many ways and means where we can save the water. So one of the day I was listening to Gadkari Saab, a very excellent, the way he talks, it is really very good to listen to such type of politicians. He was telling we are having so many square kilometers or kilometers of road is there. Road is the one of the very important this thing where water simply flows. Correct, no? You save all that water, it is sufficient for India. There is no need of anything else. I mean, it is true also. The amount of water that is going from the roads, you consider some good ponds or whatever the structures required for saving this water. So it is a very quite interesting this thing. Nowadays, politicians have become very, very knowledgeable, especially in the central government. One day, one minister I was watching, they were telling about the growth of India. They were telling in terms of we get satellite image during night time. So night time is what it tells about the light. So depending on how much light is there, you can find out there is an improvement in the electricity consumption. So this is one of the where we can tell there is a GDP in terms of GDP. And a lot of studies have been done. So this is other information I want to tell. There is a data is available, nighttime data is available, and recently we have done a good work for this Principal Accountant General for trying to find out in Karnataka there are 3 different regions are there. What is that regions? Mysore region, then Kalburgi, that region. 3 regions are. They want to find out whether these regions have growth, how the growth. So we have taken nighttime data. They have given a very good report. They have given, PAG has given a good data. In fact, they got some good award also for that. So this is other thing. Now, as earlier told by our Professor Bala, there is no other way. We have to improve our forest cover. There is no doubt about that. And we don't have a reliable estimates of what is the trees which are outside the forest. When they are talking of forest, we have very good knowledge about how much forest is there. But we don't have knowledge about what is the forest that is outside. In the sense that we have 142 million hectares of agricultural land is there, whether there is a forest or trees are there or not. So this is the one work we have done with the very high resolution data of 0.5 meters as well as artificial intelligence, the deep learning concepts, probably you people are aware of that, trying to find out what is the forest that is available outside the, so what are the trees outside the forest. Very, very important information we could generate. You can see a district like Hassan. Hassan is one of the very good district. If you have not seen, you can go and see. Beautiful district where you have very good agroforestry based systems are available. I think you can add to that. Very good. But there are many other districts where the forest component is very less. So what happens? You have a national agroforestry policy is there. If you want to implement such type of thing, allocate the funds and other thing, you require a reliable database. So this is how we can generate the reliable database. What happens? We can report all these things to every year the Department of Forest of FSI has to report what is our forest and other things and trees outside the forest. The reports are available. You can go through that report. So they have to but there is no, even now there is no authentic sources not available. Basically they do based on a statistical sampling approach they are doing. They take only some 1 or 2% of sample and aggregate for the national level. But with the type of data that is available with very high resolution data, you can find out these trees. Nowadays most of the state government, they have taken what is called as a tree census. So this is the first one is Haryana state. They have started with the generating this census of trees, like population census. What we are doing, tree census, that is becoming very essential, because with the carbon footprint which is increasing, we have to find out what is the carbon sequestration potential, how much we can reduce. When we were studying here, the carbon dioxide concentration was around 300 or 320 ppm. Now it's almost 400, I think it has crossed 400. If it goes to 600 ppm, I think we will be in the danger. No doubt about that. Nobody can stop. That is at, I think, RPC 6.5 or 8.5. If that situation comes, we will be in a very dangerous. So the other way we can improve is agriculture is in terms of crop intensification. So a lot of agricultural land being not utilized during the post-Kharif season, which can be utilized for cultivation of pulses. This is one study which I also closely associated to find out what is the amount of post-Kharif rice fallow land that is available, which can be utilized for cultivation of pulses, because you have nutritional security is required. So when there is nutrition security, we require a lot of pulses are required. You are importing a lot of pulses. There is no doubt about that. We can improve that. So this is how the government of India has started utilizing all these data sets to improve not only the oil, not only the pulses, even the oil. There is a tremendous increase in oil in terms of palm oil palm cultivation. So coffee is one of the very important this thing, especially for South Indians. We drink a lot of coffee. When you are talking of coffee, I just want to inform you, coffee, there are two varieties are there, coffee Arabica and Robusta. You drink more of Arabica, it is very good. Robusta is not so good. You are drinking a lot of chicory also, which is not good for health. These are the informations that are available. This is where the coffee is cultivated. Now what is happening with the climate change? Coffee requires some good climatic conditions, which cannot go. I mean, if the climatic conditions, the temperature goes or the temperature goes beyond some level, it cannot survive. Especially the Arabica type of coffee. Most of the consumption, if you see in coffee, it is Arabica. So, if there is a climate change, there is a tremendous increase in the temperature, we may lose most of the Arabica related Arabica coffee. Then what happens? Farmers will start cultivating in the higher elevations. So where they will cultivate in the forest lands. Because India is the only country where coffee is cultivated in the shade trees. Okay. So now recently I had attended one meeting where coffee board, European Union encourages coffee, importing of coffee where there is no, in regions where there is no deforestation happened. So now they want to find out in Indian context which are the areas where it is not impacting this deforestation. So we are going to have an MOU with the coffee board trying to find out. I think KSRSAC people also are there in that meeting. So this is one of the very important information. Because what happens, if you don't have the information, no, how do you give the information to the European Union that we are cultivating coffee in regions where there is no deforestation is not happening? How do you do it? When you talk of Brazil and other things where it is almost 30 to 40% of coffee cultivated, totally they have degraded the lands. Now if you want to find out, you require historical data sets. How do you find out? Recently we attended the meeting with the revenue department where they want to legalize the lands which is occupied by some of the farmers and other things. How do you do it? How can anybody can go and occupy land, say that it is? So this is where remote sensing will come into the picture, where you can find out using the historical data whether it is really it is a forest or not. We can find out. So this is one study done by Adhikari et al. Trying to find out what is the situation as far as the coffee is concerned at the global level. How it changes, both in terms of Arabica and Robusta. They have found out that Arabica is having a serious problem as far as its distribution is concerned. Water resources is very important. As I told you earlier, what Gadkari is telling, in that context, there is a lot of work is being done, not only in terms of irrigation, even the lakes and other things. If I go slowly, then I cannot complete. I will try to show most of the things at least by 120, 125. So this is Watershed Development, Karnataka State Remote Sensing Center, as well as National Bureau of National Bureau of Soil Science, NBSS. They are doing a lot of work now. Initially it started at ISRO, especially most of these watershed funded by World Bank. they want to monitor how the progress and other things. So that is how they have started utilizing the remote sensing, where ISRO started working with what is called a very, very popular Sujala project, which got a lot of awards. They got it. Subsequently, it was transferred to the ministry. Now many of the state as well as central government, there is a watershed separate department also is there in Ministry of Karnataka government also. They do all this work will be done by them. You look at, I think some time back, one of the professor, I don't remember, he was telling about sitting there, I think, lakes, Sahibra, or Nidya Martidara. So he was telling about the lakes and other things. So if you see, earliest data what we are having is 1965, and also we have cadastral maps. We have mapped all the lakes of Bangalore, which is about 3 acres. You can see here 86 lakes have been vanished in the central part of this thing. But it is not only that, the vanishing of most of the lakes have no water. This is the biggest challenge for us. You can see here the top Hebbal drainage, Hebbal watershed. You can see there are many of them they don't have water, or they will be infested with weeds and other things. This is the biggest problem, and we are also trying to find out whether we can monitor the pollution also. Oh, very difficult, water related pollution. In Bangalore, water is really totally, it is degraded so much, polluted so much, it is not possible to restore it. Restoring will become very, very difficult. Forest resources, we have a very good mechanism for forest resource assessment, especially now FSI is the #1 user of remote sensing data, trying to find out what is the yearly forest cycle and other thing. It is not only forest, even the biomass and other thing, biodiversity. Karnataka, especially the Western Ghats, having so much of biodiversity is there. Recently I was going to this Hornadu and Belur and other things. The number of people who are going, really, it is really a dangerous trend, what we are seeing. I think, I don't know what will happen in the future. Number of bikes, number of cars who are going to these picnic spots are so much. During weekends, it is impossible to go. There are traffic jams happens in the Western Ghats. This is the biggest challenge maybe government is facing in the future. As far as geology is concerned, of course, we cannot do any, the groundwater prospects directly will not come, which is only interpreted from the various other things like slope and other things, and some other geological features and other things. But we have done for entire country what is the groundwater prospects is concerned, with the help of our state departments. Entire country we have a groundwater prospect. That means there is a prospect of water. But if you want to dig borewell and all, it will become one of the information, but we require a local survey is very essential, a geophysical survey is very essential to do such type of thing. Of course, minerals prospecting is one of the very important things. In fact, all remote sensing is started with the geoscience applications, because where there is money is there. Whether it is a talk of hydrocarbons or whether it is a talk of minerals, there is a lot of money is involved. So where they can fund for all these things. So that's how, if you see USGS, United States Department of the Geological Department, they were the people who started working how best it can utilize. Subsequently in India also, many other countries, slowly it migrated from many other applications. Disaster, we have a disaster, with the climate change there is a lot of disaster happening. All of you are aware now, every day you are seeing, yesterday there was a rain, we were going to KSNMT, we wanted to go to KSNMT at 4 o'clock, suddenly it started raining, full traffic jam. We told we'll come at 5 o'clock, we would go only at 5:30. So this is the impact of climate change. In the sense, not only climate change, our roads are also so bad. But with this, we have under the MHA, Ministry of Human Affairs, there is a big program is called DMSP. So under DMSP, we have one center we have established in NRSA, National Remote Sensing Center at Hyderabad, called as Decision Support Center. One of the fantastic database has been created under that, what is called as NEDM, National Emergency Database. Fantastic database has been generated. Now every information can be generated through the satellites and other things, can be disseminated very easily with the various communication tools. So we wanted many things, whether it is cyclone, forest fire, landslides, early warning system, so many things are being developed, and you people may not be aware, lakhs of forest fire happens in India every year. This is one problem, and the other problem happens is the biomass burning, especially in the northern part of India, especially in Punjab, Haryana and other places. Even in Karnataka also, I understand recently we had a lot of meeting with the Department of Agriculture where they are telling that sugarcane is being, sugarcane post-harvest, they burn sugarcane residues and other things. This is a very, very other dangerous things. So monitoring is fine, we can do monitoring and other things, but unless these policy decisions are done, then it is very difficult. So yesterday you must have seen the court is telling that people who are burning biomass, let them not give MSA or MSP, the minimum support price. So these are some of the minimum policy decisions has to be taken so that this type of things can be arrested. I don't know, people are visited Delhi, very, very horrible. It is impossible to stay in Delhi nowadays because of so much of pollution. One is natural pollution, pollution because of vehicular traffic, other pollution because of the biomass burning. We do monitor disaster, especially the flood. It's a very important because it is unseasonal floods and are happening not only in northern part of India, even southern part. I think you are all aware, especially during last 2-3 years, what has happened even in Bangalore also. 2017, we received around 1500 mm rainfall. It is almost 3-4 decades before we have received such type of rainfall. Last year, I think around 1640 mm. Very high rainfall. Everywhere you are having water only. But one good thing is we are having a drinking water, this borewell water problem is not there, reduced. So it can easily, not only the flood, even the flood inundation days, in the sense duration of the flood can be monitored. This is where microwave data will come into the picture. So when I was talking of NISAR program of NASA and ISRO, this is where it will be utilized very heavily, especially for the disaster. As far as the disaster is concerned, there is a different set of programs are available wherein international cooperation is there, where any part of the world, any flood or anything, this type of disaster happens, the space centers will give the data free of cost. So that is one agreement is there across the world. Disaster risk reduction, especially in terms of mitigation, preparedness, recovery, response, that is how the NEDM database will help in generating this type of information. Bangalore, I was telling, 90s is such a fantastic one. You can see here the green color what you are seeing, but now you see which has grown so much from 153 to 368 square kilometers. The BBMP is having around 800 square kilometers area. Out of that, almost 50% is you are having buildings only. Now you take out roads and other things, and you know how much greenness is there. We have only around, I think around 7 or 8% greenness is there, which is very, very, very poor compared to, but still there are many reports from University of Science and other things which I don't fully agree. Still we are having a very good, trees compared to many other cities, many other cities. There is no doubt about that. But still, I don't know. I hope because these trees are remaining because of the rules and regulation rather than anything else. We have very stringent rules as far as the these parks and other things. Because of that only, Bangalore you could see a lot of greenery. This is what I was telling earlier, where we can use nighttime data, where we can find out the mark. But only the problem, it is all available in the little coarser resolutions of 1 kilometer. But nevertheless, it is a very good information as far as the growth and other things are concerned. Don't take it as a very literal meaning because it is 1 kilometer data. You are maybe having a bulb of a small, but because of the resolutions and other things you are seeing, that doesn't mean that you are having so much of light may not be there. Okay. We also did a lot of work related to climate change, its impact, especially for the agriculture related activities at a national level by integration. This is where GIS will come into the picture. We have a lot of data is available in terms of rainfall, in terms of soil moisture and other things, whatever he was referring earlier. So which can be integrated into a very nice this thing to come out with what is happening in agriculture or the land use, land cover over a period of long term. So this is one of the example. The problem what is happening now with the last 2-3 decades of data, if you analyze, the problem what is happening is the night time. There is a tremendous increase in nighttime temperature. So this is very, very harmful not only for humans, even for many other, even for plants and other things. So daytime anyhow it is too much temperature is there. Even nighttime temperature it will really harm many of the biological systems. That is what is the problem. And the second, ocean. Of course, ocean I will not touch much. Ocean also, because a lot of machines are available for ocean monitoring also. Ocean is there, ocean color monitor is there. There are many other things are there. There is you can see very clear-cut trend. You can see there is an increase in the temperature in many places. But you can also appreciate that wherever there is a forest and other things are there, the impact is much less. So this is exactly, everybody suggests that you have to grow for more forest. So last time when we had a meeting, when we had a similar type of workshop, so one of the things everybody agrees is nature-based solutions. Instead of going for the all these things, come out with the nature-based solutions where students and artists can work out how to come out with the nature-based solutions. There are many things are there. For example, if you are talking of our one, yesterday I think Ganesh Raj came. So when he was a general manager there, we started how to harvest the rainwater. Straight away, rainwater we are giving it to the bore well. So there is a nature-based this thing we have put it where it can be filtered with many of the this thing, whether it is stones or sand or charcoal and other things. So this is where how we can really. So many individuals also can take many appropriate measures. At least as earlier told, it is only not that only India can take some measures. There are many other people are there who are doing spoiling the this atmosphere. So if everybody takes a measure, then only. So recently I was having a discussion with one of the this Nisar. I was telling, no, there are 50-60 people are from NASA are there in our campus. So I invited them to give one lecture. So we have taken one initiative. We don't use plastic in our office. So I was casually asking, what is the this thing, what you call situation in US. He said, "Theek hai, chalta." I mean, he did not tell chalta because he doesn't know Hindi, but he was telling, no problem, we will use the plastic and other thing. But India, at least, I am very happy that there are people who have taken. This is the role model for me is Ramachandra, TV Ramachandra, probably he will be coming today or tomorrow. I invited him to give a lecture on urban related aspects, what you call that ecosystem services. So when we have the habit of giving bouquets, correct, no? So he refused to accept that bouquet. Then I asked him, casually asked him what is the reason. He said there is a lot of plastic is there. So this is the example for me. So I stopped. Now I will not give bouquet to anybody. So there are other alternate mechanisms we found out where we can do the thing. So these are small things we can use it. We never give water bottles. Totally it is banned in our office. We give only water. We have glass. Glass is still better. So these are small things all of you can start doing so that we can reduce some of this can be reduced. Of course, there is a lot of change that is happening. So what is happening, with the climate change, phenology will change. When I am talking phenology, the crop duration can come down. If the crop duration comes down, then your yield will come down. So this is what is the impact at national level. Imagine the national level, if our production reduces by say 1%, 2% or 5%, we will not have enough food. So that is where the climate change really impacts. Of course, there are so many other things we can talk, especially in terms of physiology and other things, the mechanism C3, C4 and all those things, but that is not required at this juncture. But the problem that is what is happening is the duration, crop durations and other, especially this is because of the night-time increase in temperature. And also Ooty, one of the very good hotspot as far as our Western Ghats are concerned. You can see here so much of area is very, very critical. Critically it will have a problem, issues, especially with the 8.5. When you are talking RCP, RCP, I think, hope if you are not aware, you just search what is RCP. There are RCP 2.5 to 8.5 is there. So with the trend in the carbon dioxide, so much will have. So suppose if we reach by 2070 8.5, then we will end up in a big problem. Not only in the Ooty, in many of the places we will end up in a big problem. What is RCP 8.5? I will not tell. You people search and find out what is RCP. Okay. There are many satellites are there. Just now I think he was telling, our Professor Bala was telling about the carbon dioxide emissions and other things where it is unequally distributed. You see, the maximum comes from northern continents of US, then comes from Europe, then comes from China and India. So they are the major culprits where lot of emissions are happening. So this is where the remote sensing helps in finding out. May not be very accurate because we are talking about a global level this thing, but there are many machines are available to track many of these what you call heteroatomic molecules, which causes basically this greenhouse gases, what you call, including the other this thing, which acts as a traps all this temperature and energy. So Sentinel 5P, the European Union satellite, which can give a very good information about many of these molecules, especially the methane, nitrous oxide, heteroatomic molecules, which are responsible for climate change. But why you are talking about carbon dioxide? Because carbon dioxide will remain in the atmosphere for very, very long time compared to other this thing. That's why the problem is the carbon dioxide is the biggest threat that we have to reduce. Of course, no doubt carbon monoxide also dangerous. Methane also is dangerous. We are contributing very highest as far as methane is concerned because of the rice cultivation. So rice, because of anaerobic respiration, releases a lot of methane. So most of the South Asian nations release a lot of methane, but it will have a less effect compared to carbon dioxide. So carbon dioxide is one thing which we have to tackle. The only way is plant more. I don't think any industry can simply suck all the carbon dioxide, bring it to the 300 ppm, because we don't have technology. Remember one more thing, I'll finish up in another 1 or 2 minutes. Remember one thing, the new technology may not reduce climate change. A simple example I'll tell you, the batteries. Now people are telling you use electric vehicles. The electric vehicles require lithium. The lithium or any other this thing requires a huge amount of energy. Okay? AI will not solve any problem. It will create more and more problem. Why? Simply because AI requires your GPUs. Now GPU temperature go to 70, 80. In order to maintain that temperature, you require big ACs are required. Imagine the blockchain and other thing people are talking, or your what is that coins, bitcoins and other thing. You know how much energy they are consuming. People have to come out with all these things, reality of the things. So further, we under the NICES and many other programs, we have established many instruments. So one of these instruments is called as Flux Tower, where a lot of instruments are put it. We have established recently in the coffee Central Coffee Research Institute also we have established one. Our major aim is to measure different drivers of this climate change, especially one, and second thing is in terms of the carbon sequestration. We want to study from each of these different agroclimatic regions, how is the sequestration that is happening in terms of crops, in terms of other vegetation, in terms of trees and the forest and other thing. Many places we have established, this is what we are seeing, so which gives information about the carbon sequestration potentials. I think with this I will stop here. To tell only one thing I would like to tell all of you, we are doing independent research. We need to do a research which is, I think we should have a inter-center collaboration and other thing. Then only we can succeed in doing. It is not only inter-center, even inter-country and other things. If you have more and more such a collaboration and other things, we can come out with a, at least we should reduce, as promised by our Prime Minister, we should reduce our levels of 2006 by 2040. That is why I think that is what is the this promise he has given to in the recent discussions. So to happen that, it require, I was seeing all the students, they were eating, what is that, chips, gips and other things. Reduce all those things, reduce Swiggy, Gigi and other things. So this is how you can contribute to reduce the, what you call, all these effects of climate change. I tried to share some of my knowledge. I could have told many things, but there is no time, 1 hour. I wanted to focus more on the science component so that some of the students and because yesterday I tried to find out who are the, what do you call, your audience. So according to the audience, I try to, because too much of science and other things I tell, these people will not be able to understand fully. So that's why I try to give some background so that students can, tomorrow you can find. Why I am telling I am simple thing, you may be now get thrilled. Many of my students are in US now, okay? Many of them, because they do some good work, they apply, they go there and all. So this is one of the information, if anybody interested, they can come, 1 or 2 students I can try. Thank you very much for patient listening. As told by Professor Bala, so you are all silent, in spite of hungry, this thing you are silent. Thank you very much.
Thank you, sir. Thank you for your nice presentation. And we'll take up some questions quickly. We have around 10 minutes time. Yeah.
5 minutes sufficient? Yeah.
Thank you for your effective
and fishing, speech, and also charity begins at home. I come to bouquet and
Yeah.
water. Thank you. So I have one query and one question, sir. Query is, so recently under the present climate of many, even Dharmasthala, Gramina, Yojana, NGOs like Rotary and also Forest Department and all, Raksha land are making. And in the last 10 years, it is not only preserved, they are protecting also. Definitely there should be increasing trend towards that.
Yeah.
So one more, sir. This is only query. The second is, in Udupi, Shankarapura Mallige is very famous. It has got a geographical tagging also. So that actually we wanted to bring it to near Gokarna and all.
Okay.
So we did some soil studies also.
Okay.
And we have connection with that. But because this has got a foreign exchange, really they cut the
correct.
But what we got is major nutrients are almost same. Minor nutrients, there is boron, then iron, there is some variation as such. So if we do it, will it be, because we don't have an airport now to Uttar Kannada, and we don't have that belief like how it is being used in Katira temple and Uchila temple and all that, so that marketing will be there. So can we go for cultivation in a larger step, or is there any geospatial, this will help us for this? Thanks.
Yeah. Sir, your first question, there may be some increase in forest is there. But you told about Dharmasthala. No? While going to Dharmasthala, you see how much forest has been cut and they are growing rubber. Correct? Rubber cultivation is good for economy. The problem is it is becoming a what you call monocrop. So even forest also, if you see, go to the many of these South Kannada areas where earlier it was a barren land, now a lot of this thing has come, but they are basically eucalyptus or other. So these are all trees which are not good for soil, and they are also having an effect on other. No crop cultivates under. I mean, no vegetation comes under that. So this is the problem what we are facing. The biodiversity, whatever is there earlier, which is very essential. It is not only trees, sir. When you are having a tree, you require. I mean, so many other things also will come into the picture, like bird, this, that, so many things. We are losing that biodiversity also. So increasing just a forest is not the essential. Why I am telling the simple reason is, Britishers have just cut all the trees, especially in the Virajpet and other areas. I think you may be aware of that. Because they want to, imagine the plan, whatever Britishers have done, they have cut these trees during 1800, or during that period. They have taken all those things to this one, and they have planted teak. They are just saying they will be here in India for centuries together to meet the wood requirement for their country. So that is how the monocropping of teak has come into the picture. Now why you are getting this information, this human-elephant conflict? Because of that reason. Because teak is not a good as far as elephant, they won't eat that. So this is the reason, if you go to Belur and other, every day you will, recently when I was going, I am seeing, there is a message has come for elephants are roaming here and there. So this is the problem what is happening, we are disturbing the nature as it is. That is the biggest threat what you are facing. Your second question as far as the Mallige is concerned, I don't know the area, how much area it is being. It is a small area, we cannot do anything. It is a larger area, through the drone as well as using a satellite, to a great extent we can do some of the things, but not micronutrients. So we have not reached to that level. So probably major nutrients like NPK and all, I should not tell lie and other things. So I will tell you, technology has some limitations, some advantages. So we also have to tell the limitations also. It may be able to find out some of the major nutrients, but not micronutrients and other things. Still work has to be done. And other things, when you are talking of hyperspectral data and other things, we do analysis in the lab. But when you go to the farmer's field, it will be covered with something. So whether it comes in spite of all this, it comes, still a lot of research needs to be done. I am telling you about nitrogen, phosphorus to potassium to such an extent is possible to do it. But when you are talking trace boron and such type of things, maybe it is very difficult. But what is the area? It is a small area or it is a large area? Okay. So that maybe we can attempt such type of R&Ds to come out with some solutions for such type of things. Okay.
Sir, is it necessary to have ground truthing?
Yeah, please sit, sir. Please sit and ground truth is 100% required. 100%. But what happens is, with our experience, that is the problem. With our experience, we can do many things without ground truth. But a new person, no doubt, there is a ground truth. But nowadays what is happening, sir, many of the things are available in the open source, cloud sourcing, open source. Now there is a very good potential for all of the students to work on cloud sourced data itself. Because anywhere you go, a lot of information is available. Use AI and other things, very powerful systems are available that can be utilized for that. If there are no other questions, we will stop here. Students, any questions are there? Yeah.
How can high resolution satellite imagery be leveraged for detailed mapping of microclimatic conditions that impact coffee production?
So microclimatic, still see what happens is, most of this thing what we are studying, is a land surface temperature only. Okay, so the climate around the trees and other things, they are modified because of the trees. So you are very well aware, I think all of you are aware, when you come from outside to GKVK, our temperature will drop by 3-4%. Because of the evapotranspiration, temperature of surface temperature of all this vegetation is much lower compared to this thing. So microclimate is not possible to study using any of these data sets. It requires either you have to use this AWS, automatic weather stations and other things. But once you are having a network of AWS, probably the extrapolation other things, we can use the land surface temperature and other things which is derived from the satellite data to make it to a certain, to great extent. It's a good question actually. So this is one of the very important thing that is required for a coffee board. Thermal images, that is called as thermal imaging system. So earlier, no, we are having only like this one, it is a point based, but nowadays we have image also comes. So you can take FLIR, there are some companies there, they have come out with the imaging technology. So you can get a very good information. In fact, satellite started with satellite only. The initial thermal data started from the satellite from this Landsat thematic mapper, where they had one band of this one. Now India is also going to launch one satellite which is having 4 channels of thermal. But you cannot, using satellite, it is not possible to study microclimate. It is very difficult. Okay. I think already time, people may be hungry.
Yeah, I'm sure there are many more questions from student side. Sir is available during the lunch, as well as sir mentioned initially. You can visit Sir's Institute and you can interact with Sir anytime, whenever it is required. And a very important thing actually, as Sir mentioned initially, probably some of the scholars are the postgraduate students who are planning for formulating research related to the particular topic. Some of you are already working. Those who are working, you can probably integrate if it is feasible, possible. So for that, always you can the contact, interact with the sir. You can get his mobile number also. So if there are no questions, since time is already, we are reaching almost 1:50. It is very difficult during lunch hour or just after the lunch giving lecture. Instead of that, it was very good, ignited the minds of many of the students. It was very informative. With this, I personally, as well as on behalf of all of you, I thank Hebar sir for doing the I also thank KSTA for giving the opportunity to chair, as well as on behalf of my co-chair also, I thank KSTA and all of you for this wonderful opportunity. Thank you, one and all.
Thank you, Hebar sir, for giving insightful lecture on this today's session. I request Professor Nataraj sir, please present a plant and a certificate of appreciation to the today's speaker, Dr. Hebar sir. I also request Professor Ramakrishna sir, please.
Actually, there was one question from, I think I don't know his name. Are there any plants are there which can be used for indoors so that your carbon dioxide concentration will come down? There are many are there. Please search. So it is a very important information for all of you. You can keep many of plants in the indoor. You can reduce your carbon dioxide level, especially during night time. Just try, search and try during the night time.
Professor Ramakrishna sir to present a plant to today's chair, Professor Gangadhar sir from College of Horticulture. Thank you very much sir for sharing this session. I request Prakash KV sir, please present a plant and a certificate of appreciation to Professor S. Vijay Kumar sir for co-chairing this session. Thank you sir, once again thank you one and all, and we have lunch break for 20 minutes. Please assemble back at 2 o'clock. Thank you. I request him to introduce today's chair, Dr. Srinivasa sir.
So, good afternoon to one and all. So, respected Professor T. Ramchandra sir. So, due to time constraint, like I am reducing myself, introduction of Professor Srinivas sir as is chairing the session. So, Dr. Srinivasan is professor from Department of Chemistry, Tumkur University, and is ex-deputy advisor, National Assessment and Accreditation Council. So, his area of research is mainly synthetic chemistry, drug designing and all. And he has 151 plus publications to his credit with high citation, more than 1,000. And he visited nearly 164 NAC visits and verified about 287 plus IAQA and other related NAC works. And he's guided many PhD students and also got many grants and all. So just I'm cut short this CV, and I welcome Professor Srinivas sir to introduce T. V. Ramchandra sir. Please.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ನಾವೆಲ್ಲರೂ ಕರ್ನಾಟಕದವರೇ, ಹಾಗಾಗಿ ಬೇರೆ ಯಾರೋ ಹೊರಗಿನವ್ರು ಇಲ್ಲ ಅಂತ ಅನ್ಕೋತೇನೆ. ಮುಖ್ಯವಾಗಿ ನನಗೇನು ಸಂತೋಷದ ವಿಚಾರ ಅಂತ ಹೇಳಿದ್ರೆ, ಸರ್ ಉತ್ತರ ಕರ್ನಾಟಕದವರು, ಉತ್ತರ ಕನ್ನಡದಿಂದ ಬಂದಿರತಕ್ಕಂಥವ್ರು, ಆ್ಯಂಡ್ ಈ ಈಸ್ ಒನ್ ಅಮಾಂಗ್ ದ 2% ಸೈಂಟಿಸ್ಟ್ ಇನ್ ದ ವರ್ಲ್ಡ್, ಆ್ಯಂಡ್ ಈ ಹ್ಯಾಸ್ ಬ್ಯಾಗ್ಡ್ ಮೆನಿ ಅವಾರ್ಡ್ಸ್, ಆ್ಯಂಡ್ ಸರ್ ಹ್ಯಾಸ್ obtained his PhD in ecology and energy from Indian Institute of Science, and is a member of Karnataka State Wetland Authority, is a member of so many committees, is a member, and he has recipient of many awards like Johnny Biosphere Award in Ecology and Environment, Satish Dhawan Young Scientist Award, Namma Bengalorean Award, Karnataka State Paryavarana Award in 2017-18, Kadri Achyutan Memorial Sammohana Award, and PRCI Research Advisory at the Nanyang Academy of Science, Singapore, and Sir has published 352 papers in reputed journals, 75 book chapters, 19 books, and he has given 333 plenary lectures at national and international conferences, and he has guided 152 master students and 17 PhDs, and he is here today. We will be listening to him on the topic conservation of wetlands ecosystem based adoption of climate changes. So I welcome sir on behalf of KSTA and myself. We are all honored to be listen to sir's lecture. Thank you, sir. Thank you very much. Welcome, sir.
Well, good afternoon to everyone. What I am going to do for the next 1 hour, I think my talk is for 1 hour, it's about 2:30 now. First, I will take you to the Western Ghats, where I have worked for almost 2.5 or 3 decades now, and how we have made inroads into the policy making. Because there are some youngsters who may be interested in taking this idea forward. Then I will come to the Bangalore, the city which is dying, and tell you how the wetlands can support the city. You know, when we talk about the climate change, the day when we shun our irresponsible behavior, I think we will be mitigating the changes in climate. So, why do we need wetlands? Say, why do we have to adapt or mitigate the changes in climate? For that you need to maintain the ecosystem integrity. And that once you maintain the ecosystem integrity, you will have the ecological security. With that, what are the benefits? You will have the water security. The water is becoming a critical factor throughout the country. With the droughts happening in Karnataka, 175 or 180 taluks under drought is really an issue. And once there is a water scarcity, you will have food problem. So then the health related issues, all those things will happen. And once, if you maintain the ecosystem integrity, you will have the resource available to everyone. And ecosystem services sustain the livelihood of all the people who are all dependent biota. Happiness among everyone is the criteria. That's where you need to manage the ecosystem. And to manage the ecosystem, one has to be environmentally literate. That is the thing. People are educated, but they are not environmentally literate. That is where we see there are gaps in the decision making. When we talk about sustainability, if you can ensure the clean air and water to the next generation, you have maintained the sustainability. That, as I said earlier, for sustainable future, you need to maintain the ecosystem integrity. To maintain the ecosystem integrity, one has to take the decision appropriately. The responsible decision making is required. For that, to be more effective, one should have decentralized governance for the prudent management of the natural resources. So now, when you look at the wetlands of Bangalore, we have looked at what is the number of wetlands in Bangalore, what are the services provided by the wetlands, and what is the environmental cost in the developmental planning. We have looked at the natural capital accounting also. That is the latest thing. You might have seen some of the publication of ours as a part of the strategy paper of Kstacademy, which is available at Kstacademy. Those who are interested can take that copies from them. Okay. Then we need to manage this ecosystem involving all the stakeholders. Okay. Now, since many youngsters are here, the youngsters sitting in the last row, behave. You have come here not to chat among yourself, okay? If you have anything, you talk to me. This is where the responsibility has to come on everybody's shoulder. Audience also has to be responsible. The purpose of this program is a capacity building, disseminating the knowledge, and that's where everyone has to be attentive. It is not just taking a certificate and walking out of the room. That tomorrow when you walk out of this hall, you need to be a different person. Okay, now let us understand the ecosystem. In a simple way. See, when you look at the ecosystem, you can also understand the laws of thermodynamics. When you see the producer producing food, which is eaten by herbivore, which is eaten by the carnivores, you look at the energy and material transfer happens. That is what the laws of thermodynamics. And whatever is, when you look at that, when transfer happens, there is a loss of energy also. We call it as a law of entropy. That means looking at a simple food chain, our students of engineering and science can learn the principles of thermodynamics, can learn the principles of thermodynamics. And finally, whatever is left in the system gets converted into elemental form by bacteria and fungi. That's where when you look at nature, there is nothing called waste. Where do you see waste? You will see waste where waste people are more in number. You can brand the ward or the city based on the quantum of the waste that is accumulated in the city. How many waste fellows are there? Let us now look at what we inherited. One is we inherited Earth, which has the diversity of plants and animals. And if you look at our scriptures, talks about 8 to 12 million species on the Earth. And of course, in science, we talk about 1.3 million species. And out of 1.3 million species, probably we know the phytochemical properties are the medicinal use of about 8 to 10. That means we need many more youngsters to take up science to understand these aspects so that they can contribute to the wellness of the system. Now, let us look at where this diversity of life occurs. Latitudinally, as you see, I work in Western Ghats. Latitudinally, it is 8 degree latitude to 22 degree latitude. When you look at the number of species of plants and animals along the latitudinal gradient, you will see that the highest number of species of plants and animals occurs at 8 to 14 degree latitude. 8 to 14 degree latitude corresponds to Kerala, Karnataka and Tamil Nadu part of Western Ghats. That means all of us inherit this resource. It's our responsibility to manage that. So that is where science can contribute towards that. Okay. So now, how the science can help? We have big data today. We launched the satellites way back in 70s. Every 21 or 30 days interval, you get the picture of the Earth. When you have the picture of the Earth at a regular interval, you can see what changes are happening in the system. This big data, earlier to analyze the changes that is happening in an ecosystem or in a district, it used to take 6 to 8 months, one district. But because of the developments in the form of artificial intelligence and machine learning, my students could complete entire Western Ghats, the temporal analysis in 6 months. That is the advantage. That's how, the AI and ML helps you in the analyzing the pattern, the spatial patterns across the temporal or a time. Now, when you look at the changes that is happening from 1985 to 2018, you will see the green is decreasing. That means we are losing the forest. Green is not only decreasing, it is also getting fragmented. Fragmentation is the serious issue. We lose the diversity of plants and animals with the fragmentation. It leads to inbreeding and extinction of the species, etc. So, now we also looked at what is the amount of carbon that is stored in the trees. The plants during photosynthesis, they sequester the carbon and store it in the plant and gives us the oxygen. That is what we all breathe. Now that carbon, what is sequestered in the plant, if you can quantify, that is one of the services the ecosystem provide. That's where all the plants sequester the carbon. Above ground biomass, below ground biomass and in the soil. We quantified that above ground biomass, below ground biomass as well as in the soil carbon. We computed total carbon in the system which amounts to about 1.23 million gigagram of carbon in the vegetation and soil. Now, if you look at every year how much carbon gets sequestered, it's about 37,000 gigagram, which is equivalent to the carbon that is emitted in the major cities in southern India, like the Trivandrum, Cochin, Bangalore, Mangalore, etc. That means there is a balance in the system. To maintain the balance, we need to maintain the ecosystem also. And if you look at it from the economic angle, it amounts to about 100 billion rupees or $1.4 billion. You might ask, what is the use of this number? Say, when I go for the international meetings, we can argue that this carbon that is stored in our forest is the carbon emitted by the industrialized countries. And it is their responsibility to pay us that much amount to conserve the fragile ecosystem in our country, whether it's Himalaya or in the Western Ghats. Now, if this trend of degradation continues, what is going to happen? Let us look at, because we are talking about changes in climate change. We need to know how the changes in ecosystem integrity will also lead to the changes in climate. We see that there is a further degradation of forest happen because we have more and more irresponsible people. The nature is warning us. In spite of that, sometimes scientists become a government scientist. They approve all kinds of projects. For example, tunnel project in Karnataka, in our Ghat section, I have been protesting for a long time. But I heard there is a group of scientists who are pushing that agenda. That's where the message is in Uttarakhand. The last 12 or 13 days, 41 people are trapped there. That is the warning to us. That's where ecologically fragile region, we need to protect it. And for this protection to happen, I think all sections of the society who are the stakeholders of the conservation should have the spinal cord. Missing spinal cord in the bureaucracy, missing spinal cord among the scientists is the root cause of degradation in the ecosystem. So this may sound slightly harsh, but I have been airing this view. So that is where when I address the youngsters, please make sure that your spinal cords are intact. You need to rise and you need to question the system. Now, if you don't question, then whatever the damage we have done will continue to do in your generation. That means your next generation will not have water on the earth. So now further degradation will happen. The consequence of that is there will be increase in temperature. Overall 0.5 degrees increase in temperature. Kerala become warmer while the other part become slightly cooler. When Kerala become warmer, already the region is troubled with the vector-borne diseases. That will increase further. Chikungunya, then dengue, etc. And COVID also, you see the Kerala paid heavily. So that is going to happen. Then the other thing is the rainfall pattern. Kerala, which is receiving a higher quantum of rainfall for a longer duration, will start receiving the low quantum of rainfall. Then the wet cultivation they have to stop. The cash crops have to stop. It will affect the economy. Then the other worrying feature is the number of rainy days. Rain which is spread across 6 to 8 months. Instead of that, if it comes in a week's time, the same quantum of water in a short duration, you will have the floods. When you have flooding, and with the degradation of the landscape will not have the ability to retain the water, then you will have the landslides and mudslides. In 2018, when I published the article, I had written a warning sentence there saying that the Kerala and Karnataka will pay the heavy price in the form of landslides and mudslides. As usual, when scientists write, people don't take it seriously. But when the landslides and mudslide happened in Kodagu and Wayanad, people started looking at our work. But I thought that we read the destination, people have started looking at the scientific manuscripts. But unfortunately, after that again I see the same kind of problems are continuing in the place. So that is where, if you want to minimize the system and make the system resilient to the changes in climate, you need to maintain the ecosystem integrity. Now, why is the climate change a problem? You see that how the increase in temperature will lead to the catastrophic thing, whether it's a species loss or the drought. See, just a 0.5 degree increase in this one, you see the drought instances, how it increases. Similarly, rise in sea level, for 1.5 degree it is about 48 centimeter, and you can see that this is about the 46 million people get affected because of the increase in the temperature. So that with the increase in temperature to 2 degree, it increases to the 56 centimeter. That means the coastal towns will face the problem. People who are born in the west coast will have to pay the price for that. Then, these are general statistics. You know how people throughout the globe are going to pay the price. And this is to summarize what I said. We'll have the increase in temperature, the glacier melt, then you have the flooding happening in the region, then the extreme drought and decline in food productivity. When you don't have the food, no one can survive on the earth. To summarize what I said so far, climate change threatens the public health because increase in temperature will increase the vector-borne diseases which will affect us. Then the coastline, the sea level rise, then the cities become more vulnerable, then the water availability becomes the issue, and the food security, it would be an issue. So that means if you have to mitigate the change in climate, you can do it only through the conservation of ecosystem. One is you can also reduce the emission that in the industries and in the fossil fuel burning you can bring it down, and other thing is reducing the land degradation and retarding the deforestation. You know, when the deforestation happens, whatever the carbon that is stored get released to the environment, and second thing, there is an emission of higher amount of emission. So that means the deforestation is much more serious. We need to address that on priority. And understanding that, we thought that let us provide the decision support system to the decision maker so that they can visualize which are ecologically sensitive so that they can protect the thing. These are the various variables we used. We used the weighted approach. Based on that, we prioritize which villages in Western Ghats has to be conserved on priority. Now, see, we use these variables. For example, I said weighted approach. We divided Western Ghats into 5 minutes by 5 minutes grids or 9 kilometer by 9 kilometer grid. Yeah, and we found out what is the forest cover in each grid and we assign the weight. Similarly, for the interior forest or intact forest, then the flora and fauna. See, because my group has worked for 2.5 or 3 decades and my center has worked for almost 3.5 decades, we have a good data of flora and fauna. And of course, we have taken the help of BSI and ZSI also. So that is where we know that where are the endemic species. Based on that endemic and endangered species, we have assigned the weights to the grids. Then we also looked at the carbon. This one, we had the traditional transit-based quadrant approach to quantify the above ground biomass, etc. Now, if you look at the fauna's endemism, you see that the Kerala and Karnataka part have the higher fauna endemism. If you look at tree endemism, it is highest in Kerala, then the Karnataka, and as you go there, you see the herbs and shrubs are dominant in the Maharashtra and Gujarat. Okay. So then, based on all these variables, we integrated, and when you overlay all this one above the other in GIS, and you get the composite score. Based on that, you make a 4 group, ESR 1, 2, 3, and 4. These are the 4, this one, red is ESR 1, green, the dark green is ESR 2, then the ESR 3 is light green, and blue is ESR 4. Now, the decision makers knows which is the area should not be disturbed and which is the area to be disturbed. The development can happen. Okay, this gives at the village level. So we develop the decision support system that is available to everyone who want to have the one. See, they can look at this the decision support system. I'm just going online. See, this gives the decision support system, which you can visualize the Western Ghats, the eco-sensitive regions at the grid level. Also, you can look at the village level. So now you know which part of Western Ghats is highly ecologically sensitive. Now, if you want to know about your village, you can choose the village. For example, if you choose Karnataka, because many are from Karnataka here, I am choosing Karnataka. Then I will choose the district, let us say Coorg, okay. See, now Coorg, you know that which part of Coorg is ecologically highly sensitive, followed by ESR 2. ESR 1 and 2 are have to be conserved on priority. ESR 3 is the region which is available, you know, with some conservation, you can bring the quality to ESR 2 or ESR 1. Then if you are interested at taluk level, you can also go to the taluk level, okay. This gives the Markera. Then if you want a particular village, you can choose the village, okay. So you can choose any village what you want to see. Then if you want to know why that is ecologically sensitive region 1, then all the variables, you know, the details comes there. And whatever the data which we have used for developing this decision support system is we have put it online. You know, I launched this site on July 14. Within a 10 days, there was a question in the parliament. only the media took this one and they just made the publicity. But apart from that, we didn't do any additional thing. Then once there was a query in the parliament, of course they asked me to respond, I responded to that. Then I saw that in 2 weeks, the committee from the ministry landed in my lab asking for the details. When I did the presentation, it helped to us to some extent because the committee was meeting the government of Karnataka officials and ministers regarding eco-sensitive villages in Karnataka. The Karnataka government was vehemently opposing Kstacademy committee report as well as the Madhav Gadgil committee report. But when the committee met me and after listening to my presentation, they realized they went and highlighted the carbon sequestration potential of the Western Ghats. And when they highlighted that, what is the worth of the Western Ghat in terms of one variable, carbon sequestration, the government of Karnataka said we will accept the Kstacademy committee report. And that's what the minister made a remark the very next day. See, this is how the science should get into the policy making. That's how we have been doing it and that's how it has to be. And then after we developed, see, within this one you can see how many people have accessed the thing. Today if you look at it, it's about 5,900 people have accessed our website. And then there was a demand for the big, because today's generation is mobile. They wanted Android version. Then we developed the Android version also. And, this is then people wanted this thing to be in various languages. We wrote a small thing highlighting what is the features of this and all the languages. And also we put the videos of this one, people explaining the thing. If you want to know about Malayalam, you can click on the Malayalam version. You will come to know the features of this one. Okay. So then, see, this is an Android version. If you scan this, so you can download this app, which we have named it as Sahyadri. Sahyadri means Western Ghat, so that you can scan this QR code. Then you have this Sahyadri in your fingertip. You know that where the ecologically sensitive this one and all. And yesterday, Dr. Ramesh was speaking to me. Then he said that his colleague is in NGT. His classmate is in NGT. When I spoke to that gentleman, I told him that, see, NGT is talking about ecologically sensitive villages. It's asking the government of Karnataka, government of Tamil Nadu, Maharashtra to provide the list of the villages. Already the list of the villages is available online. When these Shadamurkas who are governing the state are not willing to share the information, at least you can take this thing. See, of course, in the meanwhile, I had sent to the NGT and Supreme Court about the endeavor, and Supreme Court acknowledged this one, saying that they will take it forward. So that means there is a hope in the system. Don't be cynic and thinking that the present governance system is only destroying the system. There is no hope in the system. If you are active, you will have the satisfaction of doing something for the system. Well, now with this, let me take you to the from Western Ghats to the wetlands of the Karnataka and Bangalore. And before that, let us try to understand how the catchment integrity helps in sustaining the water. I have been talking about it because my generation are all graduated looking at the literature from the West. The Western literatures talked about the trees as the culprits of removing the water from the system. That is where the engineers who are graduated, the first thing they do is to cut the trees because they want to have more water in the reservoir. But after I published this, now the views have changed. So now I am going to demonstrate how the land cover or the land use in the catchment decides the water sustainability. Now for that, the glimpse of this one is, if you look at 91, when I was a student, the region had abundant water. But today the same region, same month, same day, there is no water. Now what is the problem? Could be because of the loss of vegetation. Here you see the degradation. So now the land cover, how the ecosystem integrity is maintained, ecosystem process also depends on that. Ecosystem process, when we talk about hydrological cycle, nutrient cycle, biogeochemical cycle. That means all these things can happen only if you have maintain the integrity of the ecosystem. So now to understand that, I will take you to a river basin, Sharavati. It originates at Ambutirtha, traverses 128 kilometers, joins the the ocean, at 1 hour. When you talk to the engineers, they ask about the river, they think only this blue line is a river. They do not understand the concept of the river basin or the catchment or the Jalanayan Pradesh or the watershed. Now, the integrity of the watershed decides the water availability. Now, if you want to understand this, see, what is the changes we did in this system? We constructed a dam way back in 1965. Constructing a dam has any impact on the ecosystem or the services of the ecosystem. If you want to know, let us look at the rainfall. Now, the rainfall data is available in our country for the last 123 years. You can download the data, just make a 2-time period analysis. 1901 to 1964, 1965 to today. When you do that comparative assessment, you will be surprised to see 1901 to 1964, this entire region, that is the Linganmakki catchment area, was receiving the rainfall of 3,000 to 4,500 millimeter. But after 1965, if you look at, one portion receives the rainfall of 3,000 to 4,500, while the other portion receives the rainfall of 1,700 to 1,900. That means 50% reduction in the rainfall has happened. If you want to know why, that is, you just look at the remote sensing data, the land cover. You see, wherever forests are there, rainfall is maintained. Wherever forests are degraded, then we have lost the rainfall. You might ask, that might be rain shadow region. That's what the critics always tell me. So for them, we look at the topography, the entire region is a rain catching region. There is no rain shadow region. The region receives the orographic precipitation, the same kind of rainfall. And it was happening from 1901 to 64 and 1965 to today. So now, why this happened? When we constructed a dam, 179 villages were submerged. Those villagers were forcefully evicted from their homeland and they were dumped in the drier belt. Those people, the farmers were doing the wet cultivation. They were growing the cash crop like sugarcane, rice, etc. They couldn't survive in Bhadravati or a drier belt. What they did is they waited for the reservoir work to be completed. Then they came to this region. They converted forest into agricultural land, and agricultural land today has become a degraded land in this region. Now that is the scenario there. One portion where degraded land is there, rainfall has declined, and the other side where forests are there, you see still the rainfall is maintained. Now to understand this linkages further, let us do the analysis, the sub-basin wide. You see there is a first order stream, 2 first order stream join from the second order, then cluster of stream from the tributary. Let us delineate the basin for each tributary. There are basins, sub-basins on the western side, and there are sub-basins on the eastern side. In each sub-basin, let us look at what is the forest cover and the rainfall. Now when you see on the eastern side, forest cover is 30%, rainfall is 1,770. While on the western side, forest cover is 65%, rainfall is 4,800, or the forest cover is 60%, rainfall is 4,400. This illustrates there is a linkage between the forest and the rainfall, where the Kadidru Matra Nadnal Neeru. That is what is the thing, we need to understand that. Now, what is how much rain you get it? But more important is how long the water will be available in your well, in your river, that decides the fate of all biota. See, if there is no water in the forest, then the animal will come to the land. That is what, if you want to minimize the human-animal conflict, you need to make sure the integrity of the forest ecosystem is maintained. So now, for that, what we did is, we monitored these select streams and river for about 36 months. Why 36 months? We wanted to understand the seasonal variability, monsoon, summer, what is the variability, and year-to-year variability. We put the sensors in the underlying layers. We selected the catchment dominated by native species forest, then another set of catchment dominated by monoculture plantation. The third is this one is a degraded catchment with the urban population, etc. Now, when we see the native species forest, because native species forests are diverse, roots are diverse. Because roots are diverse, there is a diversity of microorganisms, and abundant microorganisms were there. That is what evident from the soil microbial biota. And not only that, if you want to understand further, bulk density. You know, because of the microbial activity, soil becomes porous or permeable, which allows the water to percolate, and bulk density is lower. So that is when it fills, when the water infiltrates, it fills this zone, the groundwater zone, then it fills the Vadose zone. Then only after filling these two layers, then only the water flows in the river or stream. Then you might ask, what is the use of this? See, you have water because of the monsoon rain of 4 months. Then after rain stops, the water that is stored in the Vadose zone moves laterally to the river or stream or a lake for the next 4 months. Then during summer, the water that is stored here comes to the river or stream for the next 4 months, which we call it as a base flow. Hydrology people talk about it, okay? So that's how 12 months water is there. Now, if you replace the native species forest with the monoculture plantation, because of the similarity of the leaves and their degradation thing and alkali generation, etc., you see that only a small amount of water get infiltrated. That's where wherever the streams are they dominated by monoculture plantation, we have water for 6 to 8 months. When you degrade the catchment, we have water only for 4 months. Based on our experiment, we graded the streams as A, B, C, D. A are the streams which have the water for 12 months. B are the streams which have the water for 8 months. C are the one for the 6 months. D for the 4 months. Now, when you look at A type of streams occur, when the catchment has the forest cover more than 60%, that too with the native species forest. Wherever the forests are converted into monoculture plantation, you have 6 to 8 months of water in the stream. See, somebody in the name of development will convert the native species forest into rubber plantation. He or she is depriving the local villagers the 4 to 6 months of water. Then when we degrade the catchment with the forest cover less than 30%, you see the water available only for 4 months. Okay. Now, if you want to see how much water get infiltrated, you see wherever forests are there, the forest, there is a 60 to 65% of the water, rainwater get infiltrated. That is the water available for the post-monsoon period. During wherever forests are not are degraded, you see there is not much infiltration, the maximum 22 or 28%. Now, if you want to see whether this water sustains the livelihood of the people, we looked at the water demand in agriculture, horticulture, livestock rearing, etc. and the domestic purposes. You see wherever forests are there, the water available is much higher than the water demand. And demand for water in the region where the forests are there is much higher compared to where the forests are not there. See, when people talk about development, they say that country has to develop, then we have to remove the forest. For them, we have to tell, see, wherever the forests are there, demand for water is higher and people are prosperous. Now, to understand that, you see, this is the region where 12 months water is available. The green are the 8 months, blue are the light yellow is the 6 months, and blue is the 4 months. Now, if you want to see how it reflected on the livelihood of the people, farmers in this region, you know, if they earn 1,54,000 rupees per acre per year, farmers in this region earn only 32,000 rupees per acre per year. That's mainly because since the water is available for 12 months, they can grow cash crop or multiple crop. That's where the earning is 1,54,000 rupees per acre per year. Whereas here, since the water is available only for 48 months, they have they can grow only one crop. More importantly, as many of you are a science student, you will understand that the occurrence of native species of forest is the abundant here. See, when you overlay the forest cover here, you see that overlaps with the water availability there. Wherever forests are intact, we have the water available throughout the year. Okay? And another interesting thing is the pollinators. The presence of pollinators, the diversity and abundance is high. See, we see higher number of pollinators in this region compared to this region. Because of the higher pollinators, you know, the pollination is efficient. When pollination is efficient, the yield of the crop is higher. See, our study shows if the farmers, for example, the paddy, if the yield is 12 to 16 or 18 quintal per acre, in this region, the farmers have to struggle to get the yield of 6 to 8 quintal per acre. Now, the government of India want to double the income of the farmers. My suggestion to government of India is just maintain the ecosystem integrity. Nature does all the job. The government need not spend any money because they will get 12 to 18 quintal per acre as against 6 to 8 quintal per acre. This is what I have been telling the government, And of course, sometimes the government consists of dumb and deaf fellows. So that is where we need to make inroads and see changes happens in the system. Now, let's look at the diversity of animals. You see this all, they syndicate the various, the taxa, you know, sloth, bear, tiger, etc. They all occur where water is there 12 months, you know. Where water is not there, only two-legged animals are there. You know who the two-legged animals? Okay. Fighting for the water. Now, how the diversity gives us a medicine, if you want to understand, we describe the two species or new species of fish. You know, this we named it as Sistura Sharavatiensis and Nagodiensis because it was in Sharavati stream and Nagodi stream. It has a medicinal properties. Being a scientist, I am also ambitious. I brought the fish to the lab to see whether I can culture it and have the medicinal property, but none of them have the medicinal properties at Bangalore lab. So the message is, if you want medicinal properties, you need to grow them in their habitat. For the fish to grow in their habitat, you know, the water should be there throughout the year. For the water to be there in the stream, you need to have the terrestrial ecosystem intact. That brings the linkage between the terrestrial ecosystem to the aquatic diversity. So that is the one. Now we are talking about changes in climate. If there is no water, what will happen to the humans? Let us try to understand. One thing is certain, we all have only one earth. We might have landed on moon, but still we a long way to find water on the moon. When we face a serious consequence of the changes in climate, we will not have the water on the earth. In such a situation, how the organisms will manage? Let us try to understand. For example, the frogs. You all know the frogs as amphibians because they have two stages in the life cycle. The first stage, juvenile stage, is in the water. The next stage is on the land. Because of that, you call them as amphibian. Now, if the water is not there, what will happen to the frog? The juvenile cannot survive, the tadpole cannot survive. But we come across the species, Philatus leucorinus, bypassing the tadpole stage in a system where there is a scarcity of water. So that is very important from evolution point of view and also the mitigation or the adaptation point of view of to the climate change. That means this organism has learned how to survive. You know, when we did this study, we saw on the 14th day of fertilization of the egg, the younger ones are emerging out. Then we brought the fertilized egg to the Bangalore lab. We monitored it for this one. We noticed on the 14th day, the younger ones were coming out. So that means the animals have learned how to get adapted to the changes in climate. Whatever our supremacy in our brain, whatever our supremacy in our the technology, we will not survive. Okay? Now that's where understanding these linkages, our elders identified the patch of forest and they declared it as sacred forest because they knew that wherever forests are there, the water is there. They knew that next generation is going to be irresponsible generation. To bring awareness, they protected the forest and called it as Devarakadu or sacred forest or cows or rice in Goa and various names in other parts of Western Ghats. But what is happening? See, if you look at the Lord Shiva, his head always has a hair. The hair symbolizes the Mother Earth with the green trees. As long as Mother Earth is covered with a green saree of native species, she retains the water and she gives the water to all of us. Whereas when we degrade that, when we convert that saree into the synthetic saree of rubber or acacia or eucalyptus, we will have water for only 6 to 8 months. When we degrade the landscape, then we will not have water even for 4 months. Okay? Now, unfortunately, the so-called people, you know, people in Bangalore, Mumbai think that forest has no value. They are converting forest into small concrete land. You know, go to South Canara or this one. Yesterday's sacred forest, today's this idle land has become. Okay? Because this brain didn't understand these linkages. So that's where we should see that this kind of patch of forest which was giving the water has to be protected. In fact, those who have heard today morning All India Radio at about 7:35 or 7:30, you would have heard there was a forest officer talking about the sacred forest and the linkages with the thing. That is how we are trying to communicate to the wider section of the society. Well, people, if we are talking about development, what kind of development? Let us try to understand. For me, you know, the development which does not deprive the local people the right to live. That is the true development. That is the sustainable development. Here we connected Kerala with Mumbai, but we didn't deprive the local people the right for fishing or this. That is where one has to do the honest EIA. But you see what happened in the recent Nicobar Island, the EIA has done. Okay. Now, when I look at this lady who is in the late 50s, she tells me what is sustainability. I was surprised. This lady collects a bucket full of bivalve. One bucket full of bivalves in the market fetches her 350 rupees, which is enough for her to run her family. So she won't go back and collect the second bucket because she knows that if she does not do the over harvesting today, she has a resource for tomorrow. But what do we do, the city dweller? We are interested in our grandchildren, great grandchildren, and amass the wealth. That's what is happening, So let us learn from the history. If we do not manage the system, how it will affect us. For example, the classic case, the East Island. People thought the land is available. They went on expanding. But people have to abandon the island finally because there was a water scarcity. Similar thing happened in the last leg of Vijayanagara kingdom. If you have read the history book, you will see that last phase of the Vijayanagara kingdom failed because of the water scarcity. That means natural resource availability decides the fate of the region. And the latest thing is the zoonotic diseases. I was traveling in Western Ghats. We were studying the landslide had happened. We were asked to submit the report. I was traveling in Western Ghats. I didn't see the COVID in the villages where there were good forests. That is mainly because the people in those regions were having a diverse food. Whereas the city dwellers, the pizza fellows, they were dying like the flies. In the apartments, every day I was hearing 4 days, 5 days kind of a thing. So that means if you maintain the ecosystem integrity, you get the diversity of food. When you have diverse food, you have the diverse medicine. When you have diverse medicine, you have the immunity in the system. To narrate one incident, when I was doing a study on landslides in that region, a couple of villagers met me. We were 8 of us, my team was 8 of us. Around 1 o'clock we completed our study, we were about to return. One of the villagers came and said, "Sir, why don't you have food in my house?" I said, "It's already 1 o'clock, why to trouble the ladies at home? I would rather go to the hotel and have the food." He just said that, "Sir, you spend half an hour with me and then tell me whether I have given you the food or not." He took me to home, the entire team. We were chatting for half an hour. In half an hour, food was ready. I was surprised to see the food plate contained the 5 varieties of dishes, all of leaves. The surrounding area, they have done tambli, chutney, all those things they had prepared. Such a diverse food and healthy food they had. Of course, if I tell somebody in Bangalore I am coming home, or if I go and knock at the door, people from inside say that we are not at home. Such a situation. Whereas the villagers invite us. In fact, I have done the studies in Western Ghats, not having food in the hotel. People have taken me home. Even when I was a student, that's the kind of love and affection they had showed on me. I have given back to them in the form of these decision support system and many of the publications. The message here is you maintain the ecosystem, the integrity by managing the ecosystem. You need to maintain physical integrity and chemical integrity of the ecosystem, then only you can have biological integrity. The species that occur in a particular region which are endemic to that region, you can have it only if you maintain the physical and chemical integrity. For that, there are people sitting in AC room, half working brains, they come with a river linking project. They think that if they connect the rivers, they have solved the problem of the country, but they are creating the mess. The river, when you connect it, for example, Ganga to Kaveri, the species in Ganga can become an exotic species to the Kaveri. Then it outcompetes our native species. That's what we have to see. If you want to understand further, you can look at the classic case of alligator fish, which is not a fish, which is a kind of a, I'm sure Ramakrishna is there, Professor Dr. Ramakrishna, he will highlight further. Okay, now with this, let me go to the wetlands of Bangalore. When I look at the history book of wetlands in Bangalore, 1800, we had 1452 water bodies in Bangalore, 80% green cover. Because of that, the temperature in the region was 14 to 16 degrees Celsius. And for few days in December, the temperature was 0 degrees Celsius. In a place closer to my institute, Palace Orchard, we were growing apples because of the prevailing temperature at that time. And today, we have 193 wetlands. Most of them are polluted. And less than 4% green cover. And consequence of that, temperature is 34 to 37 degrees Celsius. What is the greatest achievement of Bangaloreans? Doubling the temperature. Okay, the city with growing apple became a city of waste and waste fellows. So now the city which was a garden city became a garbage city, and today it's a dead city. And when you look at the lakes, it's all interconnected. You know, it is like a small hillock, the city, when you look at the 3D, and this location has the highest point, 942 meters. If you come to my campus, my main gate at the campus is the highest point. Not only we are number 1 in the country, my campus is also located at the top highest point in Bangalore. And the ecosystem approach is to maintain the connectivity among the lakes so that water moves. As the water moves, you know, the treatment happens. So, okay. Now people who do not understand why wetlands are required, we get fish, we get water, we get the fodder. Then it does the job of groundwater recharge, carbon sequestration, etc. And of course, recreation is the other service done by the ecosystem. You know, why I am highlighting this is when I sit in the committees in Bangalore, some of the urban experts come. They come and tell me, lakes in Bangalore not required. They think that lakes are only meant for irrigation purposes. And one of the person I told, gentlemen, lakes also does the groundwater recharge. And also I told him, other job the lake does which urbanites take advantage is the recreation service. All the half-brain fellows with a half pant will be jogging in the morning. That is where they need to understand the importance of the lake. Otherwise, they jog, they throw the garbage in the lake and they come. Unfortunate thing. Okay. Now, if you see historically, our care market was a lake. You know, town hall area was a lake. And, you know, we had a protective wall and the water. See, earlier rulers looked at the water security and protection for the people. That's where they had the vision. Today's today's rulers, when they look at the lake, they think about the Lakeview apartment, Lulu Mall, all these things. You know, they encourage even the Raja Kalways to create the malls. I'm sure, because I studied that. Now, let us look at how important lakes are there. See, when the lakes were there, I was getting water at 80 to 100 feet. When people removed the lake, the water table went down to 600 feet. Today, you go to Nagshetty Halli, where Antariksha Bhavan is there. Surrounding area, people met me saying that there is no water. They have gone down to 1900 feet. There is no water there. That's where we have gone up in search of water to the moon. We had a successful Chandrayaan, you know. So, that is what happens. You need to invest and spend more money in search of water. That is not a good sign. And wherever the concrete areas are there, groundwater table has gone down. For example, Whitefield, Electronic City, you see serious scarcity of water. Now, if the lake is good, what is the worth of it? Because we all belong to the population. What is the use in terms of the economy? How much is the thing? You know, whenever I meet people, first thing they ask me is how much you earn. Nobody asks me how much you have written, what is the use of that. They ask how much you earn. In fact, one lady shouted at me saying that you are a useless fellow, still you are studying in a university. She thinks that working in IISc is studying in a university. She thinks that I don't earn. So that's the unfortunate part. But if the lake is good, what is the worth of it? The worth is 10,500 rupees per day per hectare. When the lake is polluted, for example, in the same catchment, you know, Amruthalli Lake, the worth has come down to 20 rupees per day per hectare. Now, who are the people dependent on the lake? Fishermen, washerwomen, farmers, etc. Now, that section of the society are deprived of their right to live because people like us, we throw the pollutant into the water body. Now let's look at the worth of the thing. We did a mapping of wetlands in Karnataka. There are 39,000 wetlands in Karnataka. Then we did that ecosystem survey. That is the strategy paper we published as a part of KSTA publication. And we looked at what is the provisioning, regulating and cultural services of this wetland. And finally we arrived at what is the worth of the wetlands in Karnataka, 7,320 billion rupees. And it gives us resources every year, 284 billion rupees every year from the wetlands in Karnataka. That's where I've been telling the government, we need to move towards the green GDP. When we talk about GDP, we should also account the degradation cost of our so-called developmental part. So that is the thing, that is where, one is, the legal wing is very weak in our country. We do not have appropriate youngsters to argue in the court. And of course, judiciary also is not aware of some of these aspects. So that's where I expect more and more youth getting into the legal front, have the environmental understanding and take up this cause in a bigger way. Okay. Now, we looked at what is the worth of this one per hectare also. This is the total ecosystem supply value. We looked at both the inland and coastal ecosystem. Okay. Now, what is the threat to the wetland? Biggest threat is a human being. Okay. Unplanned urbanization, we lose floodplains, loss of interconnectivity among wetland, narrowing drains with concretization and loss of riparian vegetation. Now, to substantiate what I said, look at how the changes are happening in Bangalore. 1973, the area of Bangalore, current area is 740 square kilometers, 68% green cover, where 2019 it is about 81% is red. Red are building, green is vegetation, blue is water body, yellow is open space. 1973, a 68% green cover, aptly Bangalore was known as a pensioners' paradise or the gardener's city. 1992, industries came up in Pune and Koramangala, we see changes happening there. Then outskirts, we see the IT, BT sectors coming and changes happening here. Then further intensification happened 2006 and 2009. And today if you look at 2021, 85% is concretized, or 2022, 86% concrete. And if this continues, by 2025, 98% would be choked with concrete. You will see only the cement. See, earlier we used to say water, water everywhere, but now we have to say concrete, concrete everywhere. Okay, and we have reached a situation where the oxygen deficiency is also there. There are instances people using the oxygen cylinder in the late evening, the age group of 50 plus, and some youngsters also use oxygen cylinder because of the oxygen deficiency in the region. There is a water scarcity, there is an oxygen deficiency in the system. That's where I've been telling the government we need to decongest Bangalore. Okay, now let's look at how many trees are there in Bangalore. See, all this spatial analysis you can do with the recent technologies like geoinformatics. We did a mapping in ISA campus using GPS, Global Positioning System. My student could identify the trees, the species. Then we linked that with the remote sensing data. Then using that kind of training data, we used it for the entire Bangalore and we quantified how many trees are there in Bangalore, which is about 1.5 million trees for the 9.5 million population. That means for every 7 or 8% there is one tree. You might ask how many trees are required. In fact, there are a group of people, they think that trees are not required. In assembly once somebody asked me, when I was invited to Vidhan Sabha, one of the ministers told me, we don't require trees in Bangalore, why are you fighting for trees? Then I asked him, are you breathing? The requirement of oxygen, they do not know from where it comes. This has been talked about in our scriptures. For example, in Bible talks about at least 320 times the nature conservation. If you study the Quran, it talks of the imminent war if you pollute the water body. That's why if you visit the dargah, you have to wash your feet and finger with a clean water before you enter the dargah. If you look at our scriptures, it also brings about the linkage between the water, children and trees. If you have a well at home, you are wealthy. 10 wells are equal to 1 lake, 10 lakes are equal to 1 reservoir, 10 reservoir is equal to 1 child and 10 children are equal to 1 tree. That's a benefit what you get from 10 the children. 10 children you can get by planting and nurturing a sapling. Now I put it other way. When you cut a tree, you are murdering your own 10 children. See, that's a powerful message our elders had given. But anyway, irresponsible populations still have not gone through the scripture. Now, not only that, we are emitting more. Which sector we are emitting? If you look at, of course, energy production, fossil fuel based thing contribute. Then the waste sector, about 7 to 8% of emission comes from the waste sector. And the cities which do not have a good public transport have higher emission from a transportation sector. For example, Hyderabad, 54% of emission come from the transportation sector, and Bangalore is about 45%. And not only that, the classic case is this building. When people look at this building, they think that architecture is good. Architecture is good, but unfortunately, this is a classic case of copy-paste. Today's engineers, today's architect, today's civil engineer are the copy-paste cats. They go to these European countries, they look at that architecture, which is designed for the temperate climate or the cold climate, where you need to conserve the heat to have the appropriate thermal comfort inside the building. But unfortunately, they come to Bangalore or Chennai or Hyderabad, the tropical climate, they paste this, the architecture in Bangalore. And now the consequence of that, if you want to study, when I studied 3,000 households, I see in the normal building, people, electricity consumption is about 700 to 1,200 or 1,400 units per person per year. Whereas in this glass facade building, it's about 14,000 to 17,000 units per person per year. 10 times higher electricity consumption because of one copy-paste culture. So for heaven's sake, don't think about copy-paste. When the assignments are given, do the assignment properly than doing a copy-paste, okay? So that means unplanned urbanization. We lost the ecosystem. We enhanced the polluted in the environment with our other architecture. Now if you travel from the airport to the Hebbal, you will see all those glass facade buildings have come up. I've been telling the city administration we need to bring a restriction on the glass facade building. Only when I am in the committee they think about that, but after that they will allow that to happen. Okay, now let's look at how many wetland we have lost. We have lost about 79% of the water bodies. In Bangalore, 88% green cover with a 1,055% increase in the concrete area. Consequence is the temperature which was 21 degree in 90s became 24 degrees in 2000 or 28 degrees in the 2010, and today it's about 34 to 37 degrees Celsius. And if you want to understand the role played by this ecosystem in moderating the climate, you go from the city center, you will see wherever lakes are there, temperatures are 2 degrees lower. Whether it is the lake or the park or even my campus where good vegetation is there, temperature is 2 degrees lower. Because of that we do good science. So, okay, the consequence of mismanaging the wetland is that floods and water scarcity. See, we have flooding happening in the region and the drought situation in the other part. And the interconnectivity among the lake is lost. You can see the lake which is interconnected, we lost it because everybody encroaches. The politician encroaches, film actor encroaches. R.R. Nagar, my friend Sarathi is there. He is sitting on a train. So these are the kinds of people who are creating the mess in the system. Okay? And if you look at when the lake is clean, it looks like this. When the lake is polluted, it is infested with the invasive species of the... See, when the thick bed of invasive species cover the lake, it does not allow the sunlight to penetrate. In absence of sunlight, the food chain, the crashes. You see that algae comes down, because of the zooplankton population comes down, or the fish population comes down. That's where the productivity of the lake comes down from 10,500 rupees per hectare per day to the 20 rupees per hectare per day. The classic case of Bangalore is the frothing lakes and a fire. Frothing, we have to address the pollutant entering the lake. This indicates there is the phosphorus getting into the lake, nutrient getting into the lake. This shows that there is a carbohydrate, the greases or the oil getting into the water body. What is the solution for this? According to 21st century bureaucrats and engineers of the Bangalore, is that they put when people, international media started talking about the froth coming to the lake, they just put this barricade. I wrote an article in the media saying that this is an irresponsible action by the city administration. And city administration called me and said, sir, you are always a critic, we take your criticism. I said, your solution is for 4 days. You watch out, I said, in my article. As I predicted, on the 4th day, the froth crossed over and it entered the street. And again the problem continued. So that means the solution is for 4 days, but what is the cost? To build this barricade, they spend 2 crores. Their agenda is to mismanage that 2 crores. Okay? Now, how they are giving the pollutant to all of us, let us see. Solid waste is dumped on the lake, and the lake receives the industrial effluent, untreated sewage. Now, every unit of pollutant entering the lake, it gets magnified to 1 million times in fish. Okay? And people in the lake, in the vicinity of the lake, use this lake water to grow the vegetables. You know, they grow the pudina, spinach, and radish, and all those seasonal the vegetables. We just collected the samples of vegetables and fish. We analyzed, and we found that all of them had heavy metal. You know, heavy metal in a food chain. Heavy metal in the food is creating a havoc in Bangalore. There is a higher incidence of cancer and kidney failure in the city. Those who have watched TV yesterday would have seen the doctor from the Institute of Oncology was on TV. He was telling Bangalore is on the top as far as the cancer instances are there, which I had talked about 10 years back. And the other one is the kidney failure. Kidney failure, which was 1 in 1 lakh about 12 years back, today it's 1 in 5,000. That's where every ward has the dialysis unit. Having dialysis unit is not a good sign. You know, it shows how the city is dying, unhealthy system. Okay? Then we said lake has to be rejuvenated. So that is where we carried out a study to say how to rejuvenate the lake. You know, one of the important things to decontaminate the lake, that means the silt which has the contaminant, you need to remove that from the lake. We did the quantification of that to find out what was the earlier depth and the current depth. Okay, this is the current depth, and when you take a difference of that, it will tell us what is the silt that is there in the system. You know, we found that about the 6 and 3 million, about 11 million cubic meter of silt is there in these two lakes, Vartur and Belantur. You know, when I gave a report at that time, like any other report, people thought that there is one more report. But local people took it to the Supreme Court. NGT penalized the government of Karnataka based on my report 500 crores, and they said that this lake has to be rejuvenated. The committee was constituted. I was made a member of the committee with Santosh Hegde as the chairman of the committee, and we started the journey. That is where desilting started. You know, when I said 11 million cubic meter of silt is there, then I saw some people in Bangalore started criticizing me. So TVR wants the 11 million cubic meter of silt to be removed from the lake, which will create the traffic problem. So then, you know, then we did the proper, this one to tell them how to, that's where we carried out a detailed study, and that is where the army joined hands with us. You know, this is my team, the army fellows and my students, everyone, we did detailed study for a month to see the contaminants. Then the silt that was there in the lake, the Vartur lake didn't have the contaminants, where the Belandur had the thing. When I talked to the farmers of the Vartur lake, they agreed to take the silt. You know, without any traffic problem, in the immediate vicinity, 400 acres of land was fertilized with this silt. You know, after 4 months, you know, I visit the lake every month. When I visited after 4 months to this lake, the Vartur, vicinity of the Vartur lake, farmers in that vicinity, they invited me with the open hand. You know, this is the bumper crop they had got. You know, that is, every farmer said, you know, per acre, they had made the profit of 1.5 lakh. That is because they didn't invest on the fertilizer, and since the soil had nutrient N and P, they could have the bumper crop. And other thing is, now they will grow 3 crops a year, 1.5 into 3, you know. You can see 4.5 lakh into 400 the acres we have given this silt. You can see what is the worth of the silt in the system. You know, that is how sensible the decision making can happen if the scientists join hands with the decision makers. And of course, finally the farmers and the local people are also happy with the system. Now this is the treatment option we are talking to them, And one of the success model, see, I crossed 3:30. Will you allow me for another 5 or 12 minutes, or shall I stop right now? 10 minutes, okay. So anyway, the tea break is there. I'm just getting into the tea break because I don't want addicts in the youngsters, okay? So now one of the example, now I have talked about science. Now let us see how the science benefit the society. There is a lake, Jakkur Lake is there. 2005, we carried out a study in Jakkur Lake, and surrounding there were 25 wells were there. All this water, well as well as the lake water had nitrate. Nitrate is a carcinogen which introduces cancer. Then I pushed the government to rejuvenate the lake at that time. Then the government constituted a committee. I was again a member of the committee. And Sidaya was the commissioner of the BDA. We had a very favorable environment, and Yellappa Reddy was the chairman of the committee. Then at that time the government said they can treat the wastewater only to the secondary level. As you all know, the wastewater treatment has 3 levels: primary, secondary, tertiary. Primary treatment will remove the large particle. The secondary treatment will remove the chemical ions. Tertiary treatment will remove the nutrient, N and P. See, when we discharge the sewage, it has nutrient along with the chemical ion. So, if you have the secondary treatment plant, you are removing only the chemical ion, not the nutrient. And nitrate is because of the nutrient, N getting into the system, which get oxidized into the nitrate. So, that means the problem of nitrate is not solved with the investment by the government. Then I suggested to the committee that let us have a constructed wetland and algal pond, which was integrated with this secondary treatment plant, which does the tertiary level treatment. That means it removes the nutrient. Then last 10 years, my students have monitored the lake and the surrounding the borewells. Today there are about 300 wells. None of the borewells have the nitrate. At least my science is giving clean water to the 300 borewell users. That is the hope. And this report, what we came out of the study, we have put it online, which shows that 85 to 90% removal of nutrient in the system. Okay. Now, the solution for the water in a Bangalore. The Mekedatu and all the jokers keep talking about. See, my solution is simple. I get a rain of 700 to 850 millimeter. If catch that rain, I get 15 TMC of water. Bangalore requires 18 TMC. That means 70% of the water required for Bangalore is available in the form of rain. The best option is rainwater harvesting. Roof harvesting will give you 4 months additional water. The next best option is through the lake. Rejuvenate the lake, retain the rainwater in the lake. So groundwater sources get recharged with the clean water. Then the second option, if you are using 18 TMC of water, you are generating 18 TMC of wastewater, treat it similar to Jakkur Lake model. You get 16 TMC of water. That means 15 TMC because of the rainwater and 16 TMC because of the wastewater treatment. You have 31 TMC, which is a surplus situation. For that, I have a 5R formula. First R is a responsible citizen. When people are responsible, they rejuvenate the lake, they retain the rainwater, and they allow the reuse or recycle of the wastewater. Okay? So then, what are the other things we have done? We have done the water body creation and the mini forest. I said the linkage between the vegetation and water I have demonstrated through this. And the most powerful weapon which I have been practicing is sensitizing the youth. My audience sometimes goes up to 1,000, 2,000 kind of a thing. So that's mainly because we interact with a lot of youngsters. Even last week I was with one of the engineering college where about 1,000 people were there. Okay, see, we created a water body in the campus. This is a perfect lab for me, for my student to do the biofuel study. Not only students are happy, I have an otter. I don't know from where it has come, but I have an otter in the campus. If otter is there in the water body, it's a voracious eater of fish. That means the fish has to be there. When we did the biodiversity study, we saw there is an adequate algae, zooplankton and fish. The message is that if you facilitate the system, the nature knows how to establish the food chain. Okay? And when people listen to me, they also implement. This is what happened in Mudbidre. This saint is a Mudbidre Jain Swamiji. There was a water scarcity in 2014 and 15. And when he met me, I suggested about the water body. He said he has 12 acres of land. We gave a proposal where the lowest water location and how much water can be stored. I said that if you create a water body, June 5th when it rains, you can collect the water. And also you take up the desilting of 32 lakes are there in the mood with, can you take up the desilting? He said, 32 is too difficult for me. Then I said, at least 2 you do it, 1 or 2. And he did a 2-lake desilting. Because the same did it, remaining 30 lakes were desilted by the local people under Shramadhan. That is the hope in our system. That is what the spiritual leaders have to do. That is I'm a firm believer. Science, society, culture and spirituality should go hand in hand in our country if you want to see the progress in our country. If you erode one of the component, you will have a problem. So that is what, when I see the success here, it is because of the youth. See, Swamiji is young and youth have taken part, and there is a student from Alva Science and Technology. And CEO of Alvas is also quite young. So when I saw his youthful nature, I thought I should give one medicine to him. So then I made sure he creates a water body in his campus which stores 25 lakh liters of water. And he also take up the planting of native species. Within a year when I visit that institution as a guest faculty, the next year I see the greenery with the abundant water in the system, smile on our face. The positive thing is, when the water body was created, before creation, this man is alone, bachelor, struggling to get married. But after creating water body, he gets a partner who takes care of the entire family. The message is that if you want happiness at home, do something for the mother nature. The nature will reward you with that. So if you search on the Facebook, all these faceless fellows will search on the Facebook, get married. Very next month they think about divorce. So best thing is, do the nature this one, okay? Now, I will tell you the story about how we solve the God's problem. If you come to Gokarna, there is a temple. Lord Shiva is there, in front of him, his son Ganesha is standing. There is the pond, Koti Tirtha. It was filled with the wheat, and the local youth wrote to me saying that there is a pollution problem, can you study? We went and studied at no cost to them. Then we realized that it is because of the organic input getting into the system. When the organic thing, the rice balls, people perform the ritual, the rice balls and all those things is left in the water body, which that degrades, and that's where hydrogen sulfide is generated, smell is there. So, but that is a difficult thing to stop in our country. You can stop water, but you cannot stop this practice. So what I did is I had a meeting with the priest. You can see that my meeting with the priest, I convinced the priest, you allow them, I have no problem. They were surprised. I said, when you allow them, you chant. And when you chant, you collect 200 rupees per family. So when you collect 200 rupees, I have about 20 to 25,000 rupees revenue every month, which we give it to the NGO. The NGO has hired 3 youth. Their job is to do the de-weeding, and in the excess rice ball, they take it out and give it to cattle in the Goshala. And for the last 3 years, if you look at the lake, it looks like this. The lake earlier was contaminated. Lord Shiva and his son were taking bath of this water. Poor fellows. But after meeting scientists, they started taking bath in this water. Naturally, they must be happy. If you look at my profile, last 5 years, tremendous work we have done. We have succeeded in the system. That's because we have solved the God's problem also. Okay, that's okay. Now, when somebody leaves us, at a very young age, one of my colleagues, Harish Bhatt, passed away, very well-known ornithologist. Instead of crying for his death, what we did is we got the children to the campus. I got 500 ficus species planted, 500 ficus sapling, 5 varieties were planted in the campus. Children, when they celebrate birthday, they come and water the sapling. Low-cost mechanism to manage the system. And all of them have survived. That's how whenever I go there, when I hear the bird calling, I remember Harish Bhatt. Invariably, when I take a walk, I do that, okay? Well, if you come to the campus another 2 minutes, you will see this climber. I was fascinated by the architecture. I thought I should have it in my campus, that in Bangalore. So what I did is I brought the seed to the campus, this pot, which had 14 seeds. Out of 14, 7 seeds I planted in 7 locations in the campus. Out of 7, only 1 survived. Where it survived? It is next to this building where I worked for 2 decades. Even the plants knows who will take care. Why other 6 didn't survive? Though it was planted by me in the same environment, because I was not going and talking to them every day. Okay? And in front of the campus, my building, we created a mini forest in 2 hectares area. 49 native species, 500 saplings were planted when I was a student. Today you come and look at the region, you get a feel of the rainforest. And temperature is 2 degrees lower. See, moderating microclimate, you can see that. Groundwater, which was 150 feet earlier, today I have water at 10 feet. Now tell me, what is the solution for water crisis in Bangalore or any city or any village? Maintain the ecosystem integrity, manage the watershed. Okay? So then, bring this, give this knowledge to the youth. When youth get the knowledge, they become sensible. When they are sensible, they become responsible. Today's youth are addicts of mobile. They have become slaves of technology. That's why they become irresponsible in the system. That's why there are certain social problems associated with that. That's why we are trying to remove that. I travel throughout the country bringing this awareness. Then we also conduct a course on environmental management. This is for the capacity building for the people working in industry and universities. This is the 22nd session I have conducted. That means for the last 21 years I have conducted this session. This is in addition to my regular teaching for my PhD students. Okay? So we organize a symposium popularly known as Lake Symposium once in 2 years. From 98 we have been conducting 13 events we did. Uniqueness of the event is not only the international national delegates come, the school children and college students come. They attend 3 days, they get the knowledge. And on the last day, they do the presentation. They demonstrate their ability. That builds the confidence in the youth. The children do the simple experiment like carbon sequestration or the catchment mapping or the water quality assessment. They come to the lab, analyze, and the children in rural area, they do the neighborhood mapping of biodiversity. Biodiversity Act says that there should be PBR in every panchayat, People's Biodiversity Register, documenting biodiversity. Government didn't succeed. When I did this in 2016, in 1 year I got 170 villages and 92% accurate. That is the hope in our youth. That's the hope in our school children. If you want accurate data, put youngsters into the thing. They will do wonderful job. Okay? If you need more details, you can go to this website. You can write to me at this tvr@iscac.ac.in. And this the portal gives my publications. You can look at the publications, whether it's a Google Scholar or the ResearchGate. And when you access my portal, you will see that all publications are archived. Okay? And also my talks, YouTube is available in YouTube. If you want to a Kannada version, you just search YouTube, TV Ramchandra, you will get all my talks. And also this gives a glimpse of the children doing the water chemistry in some rural school where there was no facility. I have created the lab facility in some of the rural school. You might ask, are you so rich? Are you Birla or Tata? No. When the awards come to me, the money I don't take it home. I give it to as an investment for the next generation. I do that. Okay? So, the work what we did for Aganashni, you are likely to have the announcement as the Ramsar site. The site, we had a unique biodiversity. It fulfills all the criteria of the thing, but for some reason people have not taken note of it. I've been talking about it with the ministry and all. Now final stage, I think on 2nd February it's going to be announced. So this is the report which we gave to the government. So that means Aganashni is going to be, Kokrebelluru was declared a Ramsar site, and this is going to be another this one. The journey of a scientist, when these kind of things happen, there will be satisfaction. There is a hope in the system. That hope, if it disseminate, carry forward to the youth will shine as the stalwart for the country. That's what I'm looking forward. Thank you all for listening to me. That's my hope is this youngsters, when I put the seeds of environmental knowledge, they become a sensible managers for tomorrow, other decision makers for tomorrow. When they become that, they'll make sure there is a smile on everybody's face. This is the youth which works behind me, though I'm just doing the job of the ambassador. But it's the effort of about 30 plus youngsters working with me. Thank you all.
Thank you very much for your nice, inspiring talk. And if you have any doubts, you can write to sir for clarification. Only one person is allowed. Okay, please. Sir, listen.
Yeah.
Sir, namaskara.
Namaskara.
We are very happy to see you here because our classes used to have your papers as reference. T. Ramchandra, T. Ramchandra, used to echo in our village. I have a small question. How about the different forest types, how they are resilient to climate change? Just for evergreen and moist deciduous also, if you just put in some idea.
No, I would say that when I say that you should maintain the ecosystem integrity, don't worry about the type, because they all depend on for a particular region, that kind of the diversity prevails, evergreen, deciduous, these are all this one. If you have converted evergreen into monoculture plantation, that is a tragedy. Giving the evergreen forest to the MPM, Mysore Paper Mill, and they converting into that 450 hectares into the monoculture, that's a tragedy. So I would say where the deciduous is there, think of deciduous species. Where grassland is there, maintain the integrity of grassland. Don't try to convert grassland into evergreen forest because of your love for the evergreen species. So the heterogeneity has to be maintained. When you do that, the material and energy transfer happen across the system. That's what stabilizes the thing. Finally, if you look at the entire earth, you have various biomes that maintain the system balance, okay? Yeah.
Sir is available during break, you can ask another So thank you very much, sir. You are insightful and elaborating lecture. Everybody is actually inspired with this talk. So that motivation also we have created here. So that's what we need. Certificate of appreciation.
You wasted a paper. No, after certain age, and I think you should stop. There's no point in giving certificate to me or Dr. Ramakrishna and such. It's of no use. We are saturated now. Our only journey towards the final days. That's all.
Thank you, sir. We will
give.
Request.
We don't have any tea break now. Immediately after this, we will take it. Okay, after this. Huh? Okay, 5 minutes.
2020, let me just say that. So Dr. Indu Kemurthy is a principal research scientist and heads the climate, environmental and sustainability sector at the Center for Studies, Science, Technology and Policy. I think as Madam said, like you guys can visit the website and know more about their activity. And just in brief, I say that like Dr. Murthy is an expert of the United Nations Framework Convention on Climate Change for Greenhouse Gas Inventory Review Process, a member of Commission on the Ecosystem Management of the IUCN, and a member of the International Platform for Adaptation Matrices. So many more of this, so I'm not going to drag on that. So
Thanks for that.
I'll just hand over the session to Madam. So please.
Thank you. Very good afternoon and very happy to be here. Thanks to Kstacademy for actually inviting me for this. So without losing much time, I'll just jump into the topic. I've been given to understand that the previous speaker has already introduced climate change quite at length. So looking at the topic of the talk, I had kind of put in some context slides. So I'm going to kind of do a fast forward on those things. I'm not going to spend too much time on this, but just to kind of set the context, the reason that we are worried about climate change as an issue, as rightly pointed out, is that never in the history of Earth did we cross the dotted line that you see on this particular graph, right? So this is in comparison to the 1950 average, and what you see, I would want you to pay attention to is the scale up there, 800,000 years. That's a very long time scale that we are talking about. And never in the history of Earth had ever that particular, the graph that you see there, has it crossed that particular line. And what you see is that it's only in the near past that this tipping has actually happened. Now, as you can see from this graph, it's been increasing, it's been decreasing. So it seems like, okay, maybe it was a natural process of increase and decline. The crests and troughs kind of interchange. They go in a cyclic manner. But the problem is the rate at which it has happened in such a small time scale. And it's just overshot everything that happened in 800,000 years. So, which is why the entire world, be it the politicians around the world, be it the scientists around the world, be it the policymakers around the world, everybody is concerned about it. And if you know the history of climate and climate convention, it was in Rio de Janeiro that the entire thing came into focus and everybody started talking about climate change as an issue, and as a science, it's evolved over time. So moving forward, another context that's important for us to remember whenever we are looking at solution to the problem is that it very clearly, this particular graph very clearly illustrates that we humans have had a hand in the problem becoming much more than what it was in the past. It's escalated over time. So which is why what you see in this particular graph is the natural causes. If it was where the natural causes, we would have been where this particular graph is showing. But then it's only the combined effect of natural and the human influence is what has made us to be where we are today. So which is why when you're looking at the solution to the problem, you really need to understand the problem in its entirety. So the clear signals, as you must have heard the previous speakers also speak about, is there's been temperature changes, large scale warming largely all across the world. Every decade, every year, there are new records being made with respect to the highest temperatures being recorded. And of course, even the precipitation changes, sea level rise, and so on and so forth. There are enough signals that you cannot ignore anymore and say that, okay, it's a natural process that's happening and we don't need to do anything about it. So they're very, very stark signals that are emerging. So just to kind of sum up some of the big things that are happening as it's been put together by the Intergovernmental Panel on Climate Change, the carbon dioxide concentration that's been recorded now is highest in at least 2 million years, fastest rate of sea level rise in about 3,000 years, lowest level extent of Arctic ice in 1,000 years, and unprecedented glacial retreat. These are first order impacts that we are talking about, those signals. But then the second and third order, which is to do with rainfall patterns changing, heat waves, as a result of heat waves, the related productivity issues, labor and other things. And also when you're talking about extreme rainfall events, the kind of flooding that happens, its impact on multiple things is something that those are the second and third order impacts. So given that there are multiple impacts, that's global, but even when you look at India, there has been quite some significant change. Some work that we did at our center, we see that the summer maximum temperature, which is your March, April, May temperatures, right? So if you look at even the 30-year period, just before 2020 or 2022, there's been quite some substantial increase in the summer maximum temperature. The same goes to say even with the winter minimum temperature. Even if you look at the rainfall, the Kharif season or the June, July, August, September, the primary monsoon season, there's been an increase in rainfall, right? The patterns are changing. When I say increase, it seems like good news if you're talking about the drier regions, but it's not always good news because it doesn't get distributed evenly. You have heavy rainfall events, you will have an extended dry spell or a drought, and then there is another bucket of rainfall that happens. So which is why the variability is the biggest concern, and that's why this becomes a larger issue any part of the globe that you look at. Now the biggest factors that are contributing to the problem of climate change before we get into the mitigation aspect is we need to look at which are the sectors, which are the culprits basically. So wherever you look at, we all know that the power sector is definitely, if it's coal power, there are emissions related to that, basically fossil fuel use in general. So transport sector again is one of the key emitters. You look at industry, industrial processes are heat intensive processes. They consume a lot of energy, they emit a lot of greenhouse gases as well. Now, although we say carbon dioxide, essentially that's not the only gas that's of concern. There is methane, there is nitrous oxide, there are hexafluorides, HF6, SF6 and a whole bunch of other greenhouse gases. But we convert it to CO2 terms and generally say, okay, in CO2 equivalent terms, the increase is quite large, right? And as you see in this picture, even agriculture, because if you obviously, rice cultivation, as you will all know, is a very water intensive cultivation that happens. And when you have standing water for extended periods of time, there's anaerobic conditions that are created that results in methane emissions. So that's also a sector that is contributing to the greenhouse gas emissions. Livestock, I will not get into the details, but that's also a sector. When we actually talk about the carbon budgets and the kind of emissions that happen across the globe or even within India, there's something called a national communications that Government of India prepares. There you look at every single sector and how much is each of these sectors emitting. Now, there is one sector which is not an emitter by and large, at least within India, which is the forest. So when you grow forest, simple school science, photosynthesis gets captured, right? So that's why the forests are called the sink of carbon as opposed to all other sectors that we talk about. Now, because of this, we are seeing large-scale impacts. It touches every single stream of life that we are depending on or we are very closely related to, be it agriculture, be it health for that matter, forests and biodiversity. In the next session, you'll be actually listening into Dr. Mahesh Shankar, who will be talking about grasslands, which is a very crucial ecosystem in itself. You will understand the importance of these ecosystems as you listen to him. So other than that, even the food produce, the coffee that we drink, the tea, the cocoa production, there have been studies across the world where they found that changes in temperature, changes in the soil moisture conditions because of changes in rainfall can actually impact the flavors of these produce. So the coffee that you drink today may not taste the same if climate change continues. There have been studies across the world which are trying to kind of demonstrate that. So there are enough and more than enough evidence to show that the impacts are quite large. And the biggest problem is that climate change is actually a threat or a risk multiplier. Now, it's just one component that we are talking about, but the thing is, it can impact all sectors, all streams of the economy. It touches lives and livelihoods. So obviously, where there are disparities, where there are already issues, it will aggravate the issues to be much larger, which is why it definitely is a case for action. It's real, it's happening, and it's today and it's now. It's not far away in the future. So we really need to start acting. And projections, climate projections, there are models which kind of say how will the temperature change, how will the rainfall patterns change, how will the extreme events be moving into the future, say 30 years down the lane, 50 years or 100 years. And very clearly what we see is, by and large, it's a warmer and a wetter future. Right? So obviously, which means you are also looking at extreme events like heat waves, heavy rainfall events, more droughts, more frequent, more higher magnitude levels. And that's something we are already experiencing. We read every day in the newspaper about some extreme event or the other in different parts of the world. So, which is definitely an important case, particularly in a developing country like India, because we are dependent, we have a lot of what we call as the climate sensitive sectors. Agriculture, as you know, is a very climate sensitive sector. Take for example Karnataka itself. I've been given to believe that most of you here are based out of Karnataka or are from Karnataka. Rain-fed agriculture in Karnataka is almost 70%. There's no assured irrigation, so there is no timely rainfall, there is no even distribution of rainfall. Then obviously that is a problem to agriculture. That's a problem to food production. So when yield gets compromised, then you have markets, economy, people's lives, livelihoods, a whole bunch of other things that kind of begin to emanate from that singular problem. So all of these underpin the need for climate action. Now when we say climate action, it's a two-pronged approach. One is what we call as mitigation, the other is what is called as adaptation. Now without getting into what or how it is defined in general, I'll just spend a minute trying to explain to you in very simple terms how each of these are different, right? When you talk about adaptation, we are trying to actually look at solution from the impact side. You have impact, so you're trying to see how do you reduce the impact, right, over a period of time. That's all about adaptation. It's due to existing. It's basically there have been greenhouse gas emissions that have happened over many, many decades, centuries, and the impacts are being felt today. Now, the problem is these are varied across different geographies. What happens in Jammu and Kashmir may not be the same as what happens in northern Karnataka. So it's very local and it's extremely context specific. The kind of solutions that you look for here is extremely local and context specific. And then of course it's basically you're trying to look at how do I protect, how do I decrease, how do I buffer any harm that's occurring because of whatever has happened in the past because of emissions. Whereas when you say mitigation, the general English term mitigation is to avert, yes, but when you talk of it from a climate perspective, we are talking about how do we prevent future emissions, future carbon emissions. That's what we are talking about. Now we talked about all those various different sectors. So in each of those sectors, what is it that can be done which will reduce the amount of greenhouse gases that are emitted into the atmosphere? So it's long term. It's looking forward. It's a forward-thinking approach that goes in. And it also tries to look at how do you reduce the severity of any future climate harm. So that's what mitigation is all about. You try to kind of look at those aspects. So this is what is very important to understand. Mitigation has to happen. Now, it is never this or that in the climate action space. You need to do mitigation, but at the same time, you also need to do adaptation. Now, the reason why we need to adapt is because mitigation is a long-term solution. It's slow. It requires global action. It's not necessary that, okay, in Karnataka or let's say in India, if we do all actions which do not worsen the problem of climate change, it's not going to solve the problem. It's a global problem. Every country around the world needs to act on certain things. which is why there are these, what is called as a climate negotiation that happens year after year in November, December. It's called the COP. You will start reading about it very soon in the newspapers, the Conference of Parties. It's the 28th Conference of Parties that's going to happen very soon, where climate leaders around the world, or leaders from different parts of the world, the presidents and prime ministers of every important country, about 190 plus countries, all gather to actually talk about what is that action, because it's a concerted effort. They need to agree on things and it cannot be imposed. They need to be able to do certain things, but remember that requires finance, which is where all that negotiation leads into. Now let's look at what are the big tickets when we are talking about mitigation. I'm kind of doing this very fast because we started almost 35 minutes late. So I will keep it quite short, but I'm open to question and answer, which we can spend like 15-20 minutes if you want some elaboration further on. So looking at what are the solutions and approaches that are being practiced, that are being implemented across various parts of the world, including India. As I said, power sector is one of the key things. And I'm sure all of you know that India is going big on renewable energy, right? So we see a lot of electric vehicles coming on the roads these days. There are solar parks being built, wind power plants, that are actually being implemented. Now, that is a way to decrease our dependency on coal power. But there are issues there, primarily because, again, if you look at the renewables, that's also a climate sensitive sector, because the sun doesn't shine all year through in all parts of India, right? And the wind is also not the best. I mean, you can't produce wind energy in every part of India. Now, which means you need storage. Now, technology for storage is again something that's still emerging. There's a lot of research that's going on, but there's a lot that needs to be done. Now, the electric cars that you see, there is a problem with the range, right? I'm sure you hear about the range and other things, because people want to invest, but they say, I can't travel beyond so many kilometers. I need infrastructure for charging my electric vehicle. So people kind of, shy away from that. So there is infrastructure development that needs to happen, which is related to EV becoming larger. Now, again, if the electric vehicle is an electric vehicle or it's a clean energy, only if your source of charging is from a renewable power. Now again, if you are plugging into a socket which is coming from a coal power plant, we're not doing anything great. You're actually creating another loop there, because your batteries, you have to recycle them. Do we have recycling technologies, or are we going to create more waste? So these are difficult questions, but then every country, every group is trying to look at try to find answers around these. Now, similarly, when you look at electric mobility, I already spoke about. Now, talking about deforestation, maybe in India it's not really such a large problem, but at the same time, in many parts of the world, in countries like Indonesia, Brazil and other places, deforestation is one of the biggest problems, because when you cut a forest, as I told you, there are sinks of carbon. Now, if the wood is burnt, all the carbon that is stored in the wood gets released. But if it's converted into, say, a table or a chair, now these particular products have a life, right? It could be there for 100 years. If some of you have ancestral homes of 100 years or 150 years, traditionally homes were built with wood only. You will have very old doors, 150 years old doors. Now, you don't replace it, right? It's good enough even today. So, as long as the produce is in use, you don't burn it, the carbon is stored, some amount of carbon is stored. But the minute you burn it, it gets released. Now, the other problem is that whenever we talk about forest, the sink of carbon is not just the tree, it's also the soil underneath the standing live forest. Now, when you cut down the forest, you're basically exposing that soil to direct sunlight if you don't convert it to anything else. So there is oxidation, there is release of large amounts of carbon that can happen. Which is why when you talk about forest, we consider it as a forest carbon sink, and when there is deforestation, it becomes a source, right? So that's the way it is looked at. Now, you will see something very interesting, and you might be wondering, how does reducing meat consumption has anything to do with emissions, but it's kind of, red meat is it has a very large footprint. It's not about just eating, it's about the entire life cycle of that particular produce, right? From production to it being transported, it's being stored, cold storage that goes with it. So every single thing, cradle to grave, if you look at where it is produced to where it is consumed, if you look at the footprint of a vegetarian diet, like proteins and pulses have a very smaller footprint as compared to very clearly established. So that's dietary shifts is definitely one of the key things that's important when you look at solving the problem of climate change. Likewise, carbon capture and storage technologies. Now, this is one case where it becomes very, very important in the mitigation space when you're looking at certain sectors or certain kinds of industries. Anybody from engineering background here? Okay, students maybe. Not a problem. So, but if you look at the iron and steel industry, when you look at cement industry, there are huge emissions coming from these. Now, the technologies are already quite mature in these industries, and they're very heat intensive processes that go in there. Now, to switch to anything beyond what exists today, A, technology is limited. B, probably it's very hard to get the emissions to zero. So in which case, you need to adopt what is called as carbon capture and storage. Now, people are also talking about carbon capture, storage and utilization. How do you utilize the captured carbon? Can you put it back into other processes? So these are questions. There is very limited work that's been done on this, but it's a very important space because there are certain sectors where you can never hit ground zero, come whatever you do, it's impossible to get it to ground zero. So which is where that becomes very, very important from a mitigation perspective. Now this sounds very interesting. There are options, there are opportunities, but then let's also remember there are challenges. Now, particularly from a developing country perspective, you are always kind of trying to balance development versus climate. Now, India is a developing country, as you know. We still have to kind of have the minimum, say, per capita consumption levels have to increase. Energy availability per capita has to increase. I'm not saying we need to match the developed country the goals. Even if you have a realistic estimate, it's still very hard. We still need to get there. So which means if you have to develop, there is energy consumption. There is a lot of emissions related to it. Now, we are here at a time where we have to go low carbon, but at the same time not compromise on development. Now, that in itself is a challenge, not just for India, but many countries around the world who have a large population and who are still developing. There's a lot more that still needs to be achieved, right? So keeping this in mind, we at C-STEP, we do some work around trying to see how do we balance the two, balancing climate and development, and we do some long-term modeling studies. We have our own homegrown model called Safari. Now this is Sustainable Alternative Futures for India. If anyone is interested to know more about it, go to our website and just type Safari, you will be able to get more information on this. So what we do here is that we try to ask these difficult questions of how do we achieve certain goals of desired quality of life. So much of nutrition per capita, so much of energy per capita. So we look at these different scenarios and then we try to see how do we still keep it low carbon. So that's the thing. And one more interesting thing that this model can do is that although I'm looking at the transport sector, it doesn't look at it in silos. We use something called systems thinking. I will demonstrate it shortly. Just park your question or any question you might have around systems thinking for just a moment. In 1 or 2 slides, I'll give you with an example what this model can do, which is quite unique to the work that we carry out in this particular space. Now, with respect to the options or opportunities that are there in various sectors, I've just put some examples which we actually put into the model for looking at mitigation, for reducing emissions in the future. Now in the building sector, obviously energy efficiency is one of the key things you will have to do come what may, because there are multiple things that are already happening. Efficiency is one. Appliance usage patterns. For example, how do you cut down the usage itself? How do you reduce the usage? Are there ways to do it? Right? In buildings, people are talking about, if there are architects, they would understand that they're talking about passive cooling technologies. This is through design. How do you design a building so that your cooling requirements is reduced? Cross ventilation, to be in very simple terms. That's very basic, but they do a lot more around cooling. And then they also look at alternative construction materials. As I said, cement is an industry where there is a lot of emission. Now, if you have to cut down the building sector emissions, you also need to cut down the usage of cement. Now, are there options to use anything other than cement? So, there are alternate building materials also that you can explore with. So, our model tries to look at these multiple scenarios. If I use cement, how much is the material demand? How much is the emission? If I cut down, say, 50% of cement and replace it with something which is not as energy intensive, what can it do? So, these are the things that we look at. Likewise, in agriculture, irrigation pumping is one of the biggest contributors to energy emissions in that particular space. So, and then dietary shift is another. Likewise, in transport, EV is definitely one. Also, changes in behavior. What about shared mobility? Instead of people, each of us taking our own cars, each of us taking our own scooters and motorbikes, if the behavior shifts to using shared mobility, or if there is a change in, for example, COVID taught us that hybrid working is possible. So if we do switch to that, it will kind of bring down the number of kilometers each of us are going to be traveling, which cuts down again consumption of fuels, which cuts down the emissions related to that. So those are the things. And also another thing is about urban spaces. Now, there is always this thing about urban sprawl. You're spreading quite across, or you're looking at very compact cities. Now, if everything is within walking distance, again, you cut down on your transport and you cut down on emissions related to that. So these are the kind of things that one can look at when you're talking about mitigation. There are different things that people can do. It's a permutation combination, right? It's not one size fit all. It depends on a case-to-case basis, depending on which city you're working. If it's a tier 2 city, it could be something else. If it's a tier 1 city, it could be something else, right? And of course, industries, I already spoke about it, so I'm not going to speak more about it. Now coming to the thing that I was talking about, the systems thinking. So here is an example. Now, what the model that I spoke about, Safari, can do is that it can look at what are the trade-offs of doing a certain activity, right? Sometimes, we miss out on what problem we might be creating by implementing something blindly. Now, what Safari can do is, it is able to kind of help us map and think through these issues also. So let's take, for example, transport emission mitigation. Now, in the transport sector, one of the key things that you can do is electric vehicles, right? We already spoke about it. Instead of a petrol or a diesel transport, we switch to EVs. Let's say we switch to EVs. Now, there is electricity demand increase that happens the minute you switch to electric vehicles. I already alluded to this. It could lead to power sector emissions if your source of energy is not renewables. Now, EV targets, obviously, so which means you need to align or calibrate your electric vehicle targets to the rate of what we call as grid decarbonization. Grid decarbonization is to switching from thermal energy to other forms of cleaner energy. Can we go nuclear? Can we look at hydropower to some extent? Can we look at solar, wind, and all other different options? So then, you will need to calibrate it accordingly. Now, the other way of looking at transport mitigation is there's something called biofuels. There's a blending of petrol with biofuels, ethanol blending that happens. India has a policy and there's a target around that. Now, the minute you talk about biofuels, in India, biofuel production is mainly from sugarcane, bagasse. Now, sugarcane is a water guzzler. It requires a lot of water for growing. Now, obviously, there are land and water constraints, and in a changing climate, these problems could increase. Now, there is a land constraint because either you are going to take up land which is available to grow more of sugarcane, which means maybe you might compromise on developing more solar parks. That also requires land. Or you're compromising on existing agricultural land, which is compromising food production, right? So, and water, as I already said, as we move forward, as you all might be knowing, we already are kind of, strapped when it comes to groundwater. We are depleted enough our groundwater resources. So there is an issue already. Now this, moving forward, it's going to become worse. So you're basically impacting food security. So how do you address the problem? Again, calibrate your ethanol blending, keeping in mind land availability, food security, without compromising food security. How do you achieve it? And probably stick to 2G ethanol only and not try to look at alternatives. The third is what I spoke about, urban compact urban forms, where of course you can have a compact city, but the problem is more compact your buildings, you go high rise, there are cooling demands that come from it. Now air conditioning, cooling is again dependent on power. So there is again an issue out there, right? So then how do you kind of allude to the problem? So can we look at green spaces? Can we look at better designs of buildings? So which is why in this model, what it does is you can take up an intervention, right? Once I do an intervention, then it also talks about what are the trade-offs. How is it going to impact land? How is it going to impact water? How is it going to impact the power sector? So it crosstalk is happening. It's not just, okay, I'm the transport guy, I will look at only transport. I don't care what's happening elsewhere. As long as my sector is concerned, what I've implemented is clean. But that's not how it works, right? It has to be intersectoral, and that's what needs to be done. So when you do this, you're able to kind of come up with a strategy to minimize the trade-off. That's what is needed in any climate action. Any long-term solutions that you are looking at, we will need to be very careful on what we are going to be implementing, and we are able to do it with this particular model. Now, while we are doing all this, when I say while, not the modeling exercise, I'm talking about mitigation in general, but still the climate doesn't wait saying that, okay, these guys are doing something, okay, we will wait and see what is going to happen. Is it actually going to cool? But the problem is the risks continue. It's because of emissions that have happened in the past. There's a lot that is up there, and there's the slow process of warming that is happening. So you have multiple risks that are continuing to happen. And as I already said, we have climate sensitive sectors and we have populations dependent on these climate sensitive sectors. Economy dependent on these climate sensitive sectors, be it forestry, be it agriculture, be it fisheries, right? It's a very close link to the economy. So now you can't wait for the best of science to emerge. You can't wait to say that, okay, we will cut down emissions, we will solve the problem. We are anyway doing it. Let what is happening happen. Probably there won't be people, we will even lose some ecosystems. It's called something like climate tipping points, as they say, right? The Amazon might completely disappear, or the Indian Ocean monsoon. There could be changes there. So these are things that you can't go back on. When you say a tipping point, there is no looking back. It's a one-way traffic. So if we have to avoid that, if we have to find ways of coping with changes that are anyway happening, we need what is called as adaptation. Now the first step towards adaptation is recognizing that there are vulnerabilities, there are risks that are out there. And that's going to be the next part, which I'm going to finish in another 7 to 10 minutes, and then we can have an interaction. Now, the minute we talk about risks, it's not as simple as a dictionary definition of a risk when you're talking about climate risk, right? So what you see here in this particular diagram is that at the center is risk here. Now, this risk is at the intersection of what we call as a hazard, which is basically your climate, right? So what is a hazard? It's the potential occurrence of any physical event, natural or human induced. So it could be a heavy rainfall event, it could be a drought, right? So that's a hazard if it happens to a very high magnitude thing. Now the other is what is called as vulnerability, which is to do with what is the system property, is it vulnerable? Now for example, if you remember COVID, people with morbidities, elderly people, very young population were said to be more sensitive, right? So they were supposed to be more vulnerable, right? If you have some preconditions, you become vulnerable. So that's what vulnerability is all about. It talks about what is the predisposition. Some of us have allergies, right? Certain times of the year, come what may, you are prone to certain allergies. But there are a lot of us who don't face those allergies. So that's your vulnerability. The third is what is called as exposure. It's by lieu of being in a certain place. Now, I don't know how many of you who are from outside Bangalore, if you've come, see, I'm pretty sensitive to the kind of changes that happen in the environment and the climate. Now, when I first moved to Bangalore about 30 years ago, I had perpetually a cold. I never had it. I grew up along the coast. I never had that problem then. But the minute I moved into Bangalore, it was happening. Then when I consulted a doctor, etc., they said, okay, it's because of your exposure to pollen load. There are a lot of flowering trees in Bangalore, right? So that's your exposure. By being in a certain place, right, at a certain time of the year, I become more exposed to a certain condition. So when these three interact together, that's what is risk. That's what is defined as risk. So it's a complicated issue in itself, but just to kind of understand risk or a climate risk, this is what needs to be done. Now, why do we need to understand risk in the first place? So the reason why we need to understand is that, for example, there is always limited funding. We're thinking from a government perspective, right? There is always limited funding. It's not like, we have enough money to spend on anything and everything. So you obviously, every government, every line department needs to prioritize its action. Now for prioritization, this particular exercise of risk assessment helps. It helps you to understand which cropping system, which community, where people are most vulnerable, where are they most at risk. And then it tells you that, okay, it ranks it, and it also tells you what is the driver of that particular risk, what is actually contributing to it, because we use a certain set of indicators or variables to understand the system property. So when you do that, you're able to pinpoint, okay, out of the 5 different things that contribute to risk, 1 and 2 contribute 80%. So a policymaker or a line department will actually put in more money on looking into that particular problem and coming up with strategies to address that particular problem. And then of course, one can also develop projects and proposals to address the problem, which is where the adaptation component, which was missing from the title of my talk, where we get into, which feeds into this coping with any inevitable changes that are still going to happen, right? So that's what adaptation is about. So when we talk about adaptation or adaptation strategy, which emerges from our understanding of climate vulnerabilities and climate risks together, is what is called as adaptation. Now here, there are multiple ways of looking at adaptation. One can look at increasing the resilience of people by doing certain activities, increasing the resilience of even infrastructure, because even infrastructure are vulnerable. They are at risk. If they are in a coastal region where there is sea level rise, there is coastal erosion, there is flooding that's happening, there is saltwater intrusion that is happening because of climate change, they are at risk. So they can use alternate materials, they can look at structures in a better way. Classic example is in the state of Assam. Brahmaputra, as you know, changes its course quite regularly, right? Every year we hear about flooding in the northeast. So what have they done? Basically people living very close to the coast, they have innovative ways of constructing their houses. They put it on top of a stilt. They have a typical name for it. I don't remember it offhand. But, that's their way to cope with any rise in the tide. Up till a certain point, they are able to cope with it. So this is adaptation. How do you adjust to the inevitable? Anyway, it's going to happen. So let me do what I need to do. It's like insurance. All of us have to die some point of time or the other, but we do not know when. So which is why we take insurance. Once we start earning, each of us put in some money into health insurance, life insurance, and so on and so forth. Every family does it. There's nothing new, nothing innovative about it. But that's the logic behind this as well. If you just connect it to that, you will be able to kind of comprehend it much easier. Likewise, flood protection measures, they create sea walls, mangroves, right? Mangroves are basically the kind of vegetation that happens along the coast and wetlands. Now that protects, it's a natural protection, it's like a seawall, right? So these are various different adaptation strategies which are basically targeted towards trying to cope with the inevitable change. Whatever you do, there is some level of change that's going to happen, which is called committed climate change. So which is why you need to be starting to adjust every single thing that you do as you move forward. And this is all because if we do not do this, the entire development that we are looking at as a country gets derailed. It can derail everything, because if you look at the SDGs or the Sustainable Development Goals, it's all about, better life, better energy, better biodiversity, right? Better health, equity we are talking about. So if you connect all the dots together, so your development and climate, they're like two sides of a coin. It's not this or that. Both can happen together, but you really need to be cognizant of how do you get that together? How do you understand? How do you make it happen together? So that's what is important when you look at climate action as such. So this is my last slide. So like I said, even if we cut down emissions and bring it to zero, right now, today, we still will have some warming because of gases that are already emitted into the atmosphere. And these are cumulative emissions, so it will remain. So we will need to be prepared for a warmer future, better future also, as many of the modeling studies do talk about, and we will need to adapt. And if we do start planning ahead, if we do start talking about these solutions, and we don't talk just short term. For example, the EV that we are talking about, yes, EV is rolled out, but then did we think about where the power is coming from? What about the batteries? Can we think about recycling? Can we think about circular economy, which is picking up now? End of life, what do you do with the batteries? So I think these are things that one needs to be very, very cognizant of whenever you're thinking of a solution. Yes, the solutions are important. Sometimes they seem very urgent and we need to act today, now. But the thing is, we will need to also think about, okay, I'm doing this today, but what does this mean, say 10 years later? What does this mean 15 years? It's like your career plan, right? You are doing something because you want to reach a certain goal. You have a vision. You're moving towards it, step by step. And then you make course correction in between. So basically, climate action is just like that. With this, I'm going to close my talk. Happy to take any questions. Thank you.
Thank you, ma'am, for your wonderful presentation. So, ma'am has given a glimpse of the climate change, the sources of the climate change, the impacts, and how to overcome, like the mitigation and the adaptations. And this climate change, it is not a single man's problem or a single country's problem. So it is the global problem. So, ma'am, we have given a good overview and the glimpse of the climate change. Yeah, we can have one or two questions. Thank you, please.
This El Nino affects at a metro city like here and a coastal city like Udupi and Mangalore. So we need to be different, leaving the marine aspects separately.
See, El Nino, although we experience it locally, it is because of something that happens in very different part of the world. So it's very hard to, yes, it's predictable. WMO comes up with these, that this, in a few months it could be a El Nino year and so on and so forth. But the local impacts, that is something it's kind of very hard. I'm not an expert on it also. So maybe there are ways to look at it, but I myself do not have very clear understanding. But I do know that it is because of something that happens somewhere in very different part of the world. And you can't really predict and say that this much is only going to happen in this place.
Because of the variation of rainfall, or what is that, in a particular...
No, it's because of Pacific currents. Oceanic currents, yes.
This time we had that, especially rain, start it was more, it was too less. So I think that has affected the.
It's a combined effect, I would say. You can't really attribute it just because it's El Nino or something. It's because of a multiple cumulative effect of multiple things that you do experience a lot of these changes.
I had a small doubt about the topic.
Yes.
Because sustainable development includes sustainable means so like what we have and it has to maintain. In the resilience word, will it have a double this on that?
I didn't get your question. What do you mean?
No, sustainable means something taking care of everything. So resilience is.
You build, I mean, in simple terms, you're building the strength of the system so that it continues to exist. Sometimes it might not exist in the same form. It might take a newer form, but at the same time, the services that are provided by a system continue. If you think of it in an ecosystem perspective, that's what you could say.
Does the Safari handle the rating with respect to carbon credit, the kind of capturing them and all those things? You advise on that?
Carbon credits is something that you can't do with Safari. What you can do is, what is the material demand, what will be the emissions if you increase consumption of A, consumption of B, or if you come up with a new strategy, new technology, for example, hydrogen. If hydrogen is introduced, then you cut down on emissions by so much. So those are the things that you can do with Safari. You can create what is called as what if scenarios. What if this happens? What if that happens? It's a tool to do that. Thank you.
We have with us Dr. Rangaswamy, Registrar, VTU. So please come.
Thank you, madam, for your interesting talk. I request Professor Rangaswamy sir, Register VT, to present a client and certificate of appreciation to madam. Thank you very much, sir. Thank you, madam. Also request to present client and appreciation certificate, which you can see. Thank you, sir.
Good evening, students. We have last talk of today's session. After this, we have a cultural program from yourself only. So we have to do, the lot of entertainment will be there. So today, now I request Rangaswamy sir and chair of this session, Register VTU, and Dr. K.V. Prakash sir to please come onto the stage, and I request today's speaker, Vanteshwar sir, to come onto the dais. Where are you? Sir? Mahesh Shankaran sir. ಇಲ್ಲಿ ಕೂತಿದ್ರಲ್ಲ ಅಲ್ಲಿ ಬ್ಯಾಗ್ ಇಟ್ಟಿದ್ದಾರೆ ಮಹೇಶ್ ಶಂಕರ್. Bharat. I request Mahesh Shankaran sir, please come on to the stage. Please sit down. Yeah, please. Today is the last session of the day. We have co-chair Sri K.V. Prakash sir and the chairperson of this session Dr. Rangaswamy sir and today's speaker Dr. Mahesh Shankaran sir. Dr. K.V. Prakash sir has done his BFSc from College of Fisheries, Mangalore. Sir is my super senior, University of Agricultural Sciences, Bangalore, and he became entrepreneur. Presently, sir is founder and director of EcoMold, and he started recently 4 startup companies. With this brief introduction about Prakash sir, thank you very much sir for accepting as a co-chair and welcome you sir, and I request you to introduce today's chair Dr. Rangaswamy sir for this session.
Okay. Welcome Dr. Rangaswamy sir. He is an eminent personality. He is currently the registrar in
done his BSc, MSc, PhD under botany and palynology in Bangalore University, and he has completed his masters in 1995 and PhD in 2001 from Bangalore University. Obtained a higher level training in biotechnology, bacteriology, and air sampling techniques from Environmental Diagnostic Laboratory, Florida, USA, in 2008. And attended course on aerobiology organized by European Aerobiological Association jointly with International Aerobiology Association at Roskilde University, Holbæk, Denmark. During
July 2011, and significantly contributed in the area of microbiology and biotechnology. His area of professional activity is atmospheric microbiology and biotechnology. He has wonderful publications, 57 research papers in national and international journals, 20 research papers, project reports in proceedings, authorized one farmers training manual in Canada, Biology 1 and Biology 2 subject for pre-university students in 2005 edition, one book chapters published by Springer, more than 225 pollen and molds weekly monitoring reports in Times of India between 1996 and 2003. 24 popular NSD articles in local dailies. Dr. B. Rangaswamy so a lot of achievements in the list, more than 5 achievements and 6 awards. I will read out the awards. P.H. Gregory Award issued by Indian Aerobiological Society. Outstanding project award 3 times from for the year 2012, 2019. Awarded first prize in at the 5th Karnataka Science and Technology Academy, Government of Karnataka Annual Conference held at Dayanand Sagar Institute, Bangalore, and many more awards, including Rajya Sabha Award, National Bapu National Award, and Paul Harris Fellow by Rotary International. We welcome you, sir. We are really amazed to have you here. Thank you very much.
Everyone, namaskara. Good evening. It's a great opportunity to introduce a very versatile and very distinguished speaker, Dr. Nayak Shankar. Nayak Shankar is currently a professor of ecology at NCBS, National Center for Biological Sciences, here at Bangalore. He is a community and ecosystem ecologist whose research focuses on understanding how climate change impacts the distribution, structure, and functioning of tropical ecosystems globally, with a focus on savannas and grasslands, and more recently, forests. He is particularly interested in applying this knowledge to the restoration of degraded lands in a changing climate. He has also contributed to shaping international policy on climatic change, biodiversity, and land through his work with IPCC and IPPE assessment on land degradation, climatic change, and biodiversity. He holds the RM AAA Chair Professorship for Global Change at NCBS. He is an elected fellow of Indian Academy of Sciences and the Indian National Science Academy, and notably, he is a recipient of the Infosys Prize for Allied Sciences. With this introduction, I request all of you to give him a big hand. A very distinguished professor will be delivering the talk. The title of the talk will be delivering is The Paradox of Forest Grassland Mosaic, revisiting the one planet, one biome paradigm. With these few words, I request to Professor Shankaran, my Shankaran, to deliver the talk. Thank you.
Thank you. Hi, can you hear me back there? Am I audible? Yeah. Well, first off, I'd like to thank the organizers for inviting me here to give this talk, and also for the wonderful and kind words of introduction. So, what I'm going to be talking about is something slightly different from some of the earlier talks you've heard today. Right, so as Dr. Indu Murthy said, I work on grassland ecosystems, and I'm going to be talking about grassland ecosystems and one particular grassland ecosystem. I'll come to that in a bit. And I'll be focusing more on the ecology of it. So I'm not going to be talking about climate change impacts on human societies, but I'm going to be talking about climate change impacts on natural ecosystems, right? And if you've had the chance to see the recent IPCC IPBES joint report, what they highlighted was that we're currently in the midst of two crises. We have a climate crisis, but we also have a biodiversity crisis that we're going through. We are losing species at an amazing rate, right? And both of these impact human well-being and quality of life. And one of the conclusions of that report was that if we just look at one of them, and most of our focus has been on the climate crisis, and we're ignoring the biodiversity crisis, then that's a bit of a problem. And essentially what we need is win-win solutions. So we need solutions that, you know, deal with the climate crisis, but doesn't come at the cost of biodiversity, right? And I'm going to be talking about one such ecosystem that has been largely ignored, and it continues to be ignored, particularly when it comes to things like clean energy and development and so on, and that is grassland ecosystems. And I'll talk about one particular grassland ecosystem, which are the montane forest grassland mosaics, right? Now you open any ecology textbook, right, and you'll see a figure like this. This is Whitaker's biome classification, and essentially what it tells us is for a given combination of climatic variables, so in this case precipitation and temperature, you'll have one kind of characteristic biome. So that is one climate, one biome. So in areas where you have a lot of precipitation and warm, you should see tropical evergreen forests. Where it's really dry and hot, you expect to see deserts and so on, right? I mean, all of us have seen this. And this holds true most of the time, right? Most of the time we know that, you know, under these climate conditions, we're going to get a tundra. Under these climate conditions, we're going to get a tropical wet evergreen forest and so on. But do all ecosystems actually fit the bill, right? I don't know how many of you have traveled up in the Western Ghats, gone up to the high elevations of the Western Ghats. So if you go to places like the Upper Nilgiris or Erevikulam National Park and so on, you'll see an ecosystem that looks like this. This is an amazing ecosystem, but this is one that actually contradicts the one climate, one biome paradigm, because under the same climate, essentially what you're seeing patches of forest and patches of grassland right next to one another. So within the same climate, you have multiple biomes, right? And this is not just restricted to India. If we look at other places across the globe, these are the same kind of mosaics. You see them in Sri Lanka, you see them in Malawi, you see them in Bolivia, Madagascar, Brazil, and so on. Where they occur, they're not very widespread, so they're very limited, and so they're rare biomes, but they're widely distributed. And the thing about these biomes is they hold many endemic species, and at least if we look at the Western Ghats, the forest or the shoulder grassland mosaics in the Western Ghats, they're very important for many ecological functions, particularly hydrology. They play a key role because they serve as watersheds for many of the rivers that originate in these ecosystems, right? So now the question is, are they natural or are they anthropogenic? So if people are trained with the whole one climate, one climax ecosystem, when they view that, which is how the colonial foresters, you know, in the 1800s, when they first saw these ecosystems, they said, well, grasslands cannot be climax, so these are obviously degraded ecosystems. It used to be a forest, but sometime in the past, the indigenous communities up in the Nilgiris have mismanaged this as a result of fire and grazing, and that is why we have these ecosystems like they are today. But is that really the case? So there's some work from Professor Sukumar's group at IISc where they went and took these soil cores and they tried to date you know, these ecosystems. And because grasses, which are C4, they follow the C4 photosynthetic pathway, and the trees, which are C3, you can actually identify them based on, you know, isotopic signatures. They have different isotopic signatures, so you can say whether in the past the system was a grassland or a forest and so on, right? And so they took these cores, and this is what the graph looks like. You don't need to worry about it. All it's saying is proportion of grasses versus trees, and they were able to date the cores up to 40,000 years ago. So even though, you know, it has fluctuated, there were both trees and grasses present in the system for at least 40,000 years. So that's long before humans came to this place. We had both grasses and trees in the system, suggesting that they've persisted, they were present prior to human habitation, suggesting that it's not likely a system where humans have come and cut the trees, and which is why we have the grasslands, right? And the same kind of studies have been done in these kind of mosaics across the globe, in Brazil in particular, and multiple lines of evidence, if you look at pollen and if you look at isotopic signatures, suggests that these grassland mosaics are actually ancient. They're ancient mosaics and they're not anthropogenic artifacts, right? In many cases they predate human presence, and so they do not, so they appear to be natural rather than these anthropogenic artifacts. So then the question becomes, right, in most of these cases it seems like they're natural, but what actually maintains it, right? So you have a system where you have both trees and grass right next to one another and they're stable, right? How is this possible? How did this arise in the first place? So there are two questions that come here. How did these systems arise in the first place, and actually what maintains them? The answer to the first question, I don't know. We're still trying to figure it out, and I have no idea how these systems came about. But what I'll talk about is how these systems are actually maintained, right? And people have been thinking about this for a long time, and many different theories people have proposed. So one of the theories which Ranganathan, who was the forest officer there in 1938, he proposed it's as a result of microclimate. Other people propose it's a result of soil. You have soil differences, which is why you have forests and then you have trees and grasses. Others said it was because of fire. Fire maintains the grasslands in an open state. And people also mentioned herbivory. Large mammals, eat the grasses, destroy the forests, and they maintain this mosaic of trees versus grasses. Now, even though people have been talking about this since 1938, there have actually been very few tests of which one of these mechanisms is actually responsible for the maintenance of these grasslands, right? And so you'd see statements in the literature like this. Hence, frost occurrence probably does not provide a satisfactory explanation for the restriction of sholas to the depression and grasslands to the exposed surfaces. The assumptions that grasslands are steady state vegetation maintained by soil or edaphic factors holds good. So that's soil. With no conclusive evidence for the frost hypothesis, the fire hypothesis has gained favor, and fire has an important role in maintaining grasslands. So all of these conclusions were drawn without any actual tests of it. So one of the things we set out to do was we said, let's actually go and test and see which one of these factors actually maintains this mosaic. And that will give us an idea of how these systems are going to change with respect, in the future as the climate changes. And our study system was the Shola grassland mosaics, which are found right across the Western Ghats, high elevation, but we're focusing on the Nilgiris, the upper elevations of the Nilgiri plateau. And before this is work done with a lot of people. Like I had in my title slides, Atul Joshi and Jayashree, who were collaborators. Atul is now at ATRI, Jayashree is still at NCBS, and many students who have helped us collect this data in the past, okay? So before I get into the, to the meat of the study, how many of you have been to Ooty? Has anybody here been to Ooty? Some of you have been to Ooty, right? So one of the things we wanted to ask is, how did these systems look like in the past? Right, and so what Atul did was he went to the India office at the British Library, and he went through all this old correspondence from, from the 1800s, from the British foresters that are all available there. And so this is what Ooty looked like in the 1800s. That's Ooty Lake, and it was all a grassland, right? And now when the British came there, they looked at this grassland and said, this cannot be a climax, it has to be a forest, and so this is clearly a result of humans mismanaging, the indigenous communities mismanaging the system, and so they started planting trees. So this is what it looked like in 1834. If you've been to Ooty, this is St. Stephen's Cathedral. This is what it looked like in 1834. By 1851, there were more trees out there. They'd planted more trees. By 1905, this is what the cathedral looked like. And by 2015, you can see all of the native grasslands are all gone. It's a whole bunch of actually exotic trees. They planted over 40 exotic species. Most of them didn't take hold, but there were few that actually went out of control. And one of them was Acacia munzii, or black wattle. which they recognize as soon as they started planting it, they recognize that it's a problem. And now, if you go to the upper Nilgiris, almost all of these grassland, 70% of these grassland habitats have been lost to this wattle. I don't know if you can see, there's a brightish green patch here, which is the forest, and all that other stuff is just grasslands that have been invaded by this exotic tree. So what you have here is a system where tree planting has resulted in a loss of a very critical kind of habitat, which are the grasslands, which leads to loss of biodiversity, loss of endemic species, and it's also changing the hydrological cycles of this place, right? And the thing is, we continue to do that. There's a whole, everybody is talking about reducing carbon, you know, a trillion trees campaign. You must have heard about this. Everybody wants to plant 1 trillion trees to reduce CO2 from the atmosphere. Where do you plant those trees? You plant those trees in open places. And what are these open places? They're grasslands, right? And the assumption is that grasslands are wastelands. Actually, many of the grasslands in India are still classified as wastelands, right? So you don't need any kind of, it's very, convert them to solar farms, give them to industry, whatever, so on and so forth, right? So grasslands are a huge problem. If you've seen what's going on with Hesargata, right? Last remaining grasslands are under siege, right? But the fact is, they are actually natural ecosystems that have their own value. And it's something called biome awareness disparity. Apparently people like forests much more than they like grasslands. I don't know why that is, but that's the case. Anyhow, you know, the forest department continues to try and plant trees. In this case, it was a lot of native trees in these grassland habitats, but none of these trees survived, which is lucky for us. But why was that the case, right? So we asked the question, what actually is preventing native trees from establishing in these grasslands? So it could be either the seeds are not coming there, or the seed to seedling stage, you know, that transition doesn't work, or this transition doesn't work, and so on, right? And so one of the questions we asked, do soils and or microclimate influence seed germination? And we did a very simple experiment. This was just using 2 species, but it was a highly replicated experiment. So we took soils from the grassland, we took soils from the shola forest, and then we germinated seeds in either grassland soil or in shola soil. And then we placed these trays either inside the shola microclimate, or we placed them outside, which is the grassland microclimate. So we had every combination of grassland soil and shola soil, and then grassland microclimate and shola microclimate, right? And what are the results? You know, this dark bar is for the native species, invasive species, which is acacia, and the lighter bars are for the native shola trees. This is the shola system, and this is in the grassland microclimate. And essentially what we see is actually there's no effect of soil, so it's not a soil difference. People say there's edaphic properties, but soil does not seem to limit the establishment of trees in this ecosystem. And in fact, if you look in grasslands, the germination rate of trees is actually higher in the grasslands than inside the shola. So it should actually favor forest establishment, but it doesn't. And the invasive species, you know, is germinating 3 times more than the native species. Okay, so if you come back here, it doesn't look like soils have any impact on this transition from seeds to seedlings, and microclimate actually it's more favorable in the grassland, so more trees should be germinating. So where's the next bottleneck? From seedling to sapling, right? So we looked at that, you know, is there a bottleneck here? And again, we just continued with those seeds. Once they're germinated, we let them grow, and then same thing, shola soil or grassland soil, and within shola patches or in grassland patches. And what do we see here? This is just a survival curve. So if you look at the grassland, this is the invasive species on the top and the native species below. So by the time winter is over, all the native species, all the tree seedlings are dead when they're in the grassland. But you know, the invasive species still survives. It's able to tolerate winter in the grassland. If you look inside the forest, both of them do just as well, and there's a high bit of survival. Yeah? So drastic overwinter mortality of these native trees in these grasslands, and much higher survival inside the forest patches, right? And greater survival of the invasive acacia in the grasslands, which the native species are not able to sort of overcome. all of this strongly suggests that something over winter, which is most likely temperature, is actually what's limiting these trees from establishing in these grasslands. And if we look, we actually measured temperatures from inside the forest to outside in the grassland. This is over a 10-meter range. And if you look inside the forest, the lowest temperatures reached in winter is 4 degrees. 10 meters away, just from here to there, the lowest temperatures reached is -4 in the grassland, right? So there's a huge temperature gradient just across the border when you go from inside the forest to outside the forest. And what this means is that in grasslands you have frost, whereas frost never occurs inside the forest, strongly suggesting to us that frost is something that's actually killing these tree seedlings, right? So soils do not appear to limit establishment. Native tree species are unable to survive in the winter in grasslands, but acacias do. And so we actually wanted to test is if we raise the temperatures, will the native species actually survive? So we did a warming experiment with 5 native and 1 invasive species. You know, it was a huge process where we actually took these, planted these seeds in these seedling bags, and then every evening we used to place these thermal blankets over it that will keep it warm. So we used to warm these seedlings so that frost does not occur, right? And if we look at this is the temperature, the blue ones are in the grassland, and the red ones are in our experimental warming treatment. 2 of the days we couldn't go there because either it became too late, so we couldn't enter the forest, or one night there was a huge storm which blew out all our thermal blankets. And only 2 nights in our experimental treatment did temperatures go below 0 and frost occur, whereas in the grassland 17 nights we had frost. And what happens to the survival? Again, if you look at the control treatments, which is just outside, once again most of the seedlings were dead by the end of 60 days because of the winter, whereas in our nighttime warming is actually 40% survival. So there's much higher survival when these things are warm than when they're not warmed. And once again, if you look at warming, the invasive species does really even better, right? So this is a bit of a problem. So there's significantly greater survival when protected from freezing temperatures, and overwinter survival of acacias is nearly 90% following warming. What does this mean for these grassland ecosystems? Like I said, they are highly restricted, highly endangered ecosystems. These results suggest that low nighttime temperatures what actually prevents the native trees from establishing, and that's what's maintaining these systems for the last 30,000, 40,000 years. Unfortunately, while future warming is likely to favor native trees, so native trees will be able to establish in these grasslands, the problem is it's likely to facilitate the invasive species even more, because the invasive species do even better under warming, right? So if you look at the future of these grassland ecosystems, we've already lost about 70% of it, to these exotic plantations. We know climate is warming, and we know as a result of warming, it's going to lead to greater establishment of trees in these grasslands, and which is going to be a problem for these grasslands. So how are we going to conserve it? I don't have the answer to that question, but it's something that we need to think about, because these grasslands, we know that once the trees have established, it changes the hydrological flow, right? There's much more water that comes off immediately in the streams, whereas where you have natural forest patches, the stream flow goes on much through the year. So it's going to change the hydrological cycles, which has implications for people living downstream, and so on and so forth. With that, I will just call it quits. I can go on and on and on about grasslands and why we shouldn't be planting trees in them, but I guess I had 15 to 20 minutes, so I thought I'd kind of keep it short. There's a lot of people I'd like to thank, from the Tamil Nadu Forest Department to Federal, to people at the India office, and of course, all of the people at NCDS and who've helped us, and the Infosys Science Foundation and the RM Tulpulate Trust. Thank you, and I'm sorry if I went really quickly. Yeah.
Wonderful piece of presentation, Professor Mahesh Shankar. And I think Professor Mahesh can take 2-3 questions related to forest grassland mosaic. And before that, in fact, I remember one of my professors who had to made an 96 Academy, 2 decades back. He was explaining in one day that, the Tirupati near Grove, there was no plant, species named Ugadia heptandra, which is a glass plant, which was discovered way back in 1919. And from then, that since 1952, there was a power project which was taking place in that area. The plant disappeared. And subsequent effort to identify the plant in that area was, went on in. But after that was rediscovered after some 65, 70 years in the same place. And it was listed in the IUCN. And what it shows, probably, even though if they disappear from their nature, the original place, probably reappear.
Soil bank.
It's all because what you said about the soil bank. And another important one, you also used to mention about the vegetation. You told about so many pictures with the solar, etc. You used to mention about the cliff vegetation, which is one of the very unique vegetation, which you will not find in many other places. That is something that habitat is something which is different. The plants which we find in the cliff will not be found in the other places or something like that. These are the two mysterious stories you used to tell all about. And thanks for reconnecting that my old stories to today's lecture. So now the subject is open for 2-3 questions. If there are many interesting questions, please. I think
seems like I explained it all.
No. This is the future research more will be on this area. Please note that. And we'll be having plenty of opportunity to do research on this area. And this will allow us to do research for another century probably. Yes? Yeah.
I think very in a simple way, without proper consultation or experts involved, don't get into invasive species or alien species and thinking that we are building the vegetation there. So that's what I want.
Yeah, that's one very important message. And don't plant trees in grasslands.
Just because you want to plant trees, you do not do that without proper consultation. That's plain and clear.
Yeah.
Thank you very much.
Sure. No.
Thank you very much, sir. Very, very beautiful lecture. Beautiful actually. Grasslands are very beautiful. So thank you very much, sir, for your kind acceptance for our invitation to enjoy the lecture. And I request Dr. Ramakrishna sir to please present plant and certificate appreciation to the Sankaran sir. Professor Nagraj sir, please present plant certificate of appreciation to Professor Rangswamy sir. Yes, sir. Thank you, sir. Thank you very much. I request Lakshmi Kant sir, please present plant and certificate of appreciation to Sri Prakash sir. Thank you, one and all. And if you are ready, you can start now your cultural program. Dinner will be ready at 8:30. So please have dinner and go. So that's what I can say now. So voluntarily you can please arrange the stage and you can perform.